Well, hello and welcome YouTube. Mr. Robinson back here with yet another brand new exciting video, all math-based of course, and as always, it is an honor and a privilege to be serving you here today, as it is every day here in my virtual classroom. Step on inside and fasten your seatbelts. This is going to be a very super long one. If you were with me several months ago, I guess 5 to 6 months ago, based on what our first semester was, I recorded a video covering all of my skills quiz questions from Integrated Math 1 from my fall semester. And I'm going to do the same thing here for my spring semester 1. Now, that video was just under 5 hours long, so this may be the same thing, all depending on how slowly I teach through the problems and when I need a calculator for certain skills and all that kind of stuff. So I'll kind of show you what this layout looks like. I can't guarantee you that at the time of uploading there's going to be a PDF down below, because the way that I arranged this was not first in PDF form. I layered these all together by mistake. So I'm going to have to do that on my own time. And also apologies if I have to scratch you with the nose. And I got a couple sniffles here, a little tickle in my throat. I have 3 water bottles ready to go. Might have to pause here and there if this is a 5-hour video. So we'll see all that happens. But I'll run down through with you kind of what this looks like, what all those skills are at the very least. You know, someday maybe I get timestamps for all this stuff. Let me pop up. I have a calculator ready to go as well in case, so get your calculator ready if you need it, and you know, just enjoy this video, guys. Enjoy this video. So let me first pop up what these skills are for my Integrated Math 1 curriculum, and let me show you the layout of this if you weren't with us last time on it, because it's a little interesting. It's not exactly as you'd think that it would be, especially if I haven't done a skills-based thing, because I'm literally going to be doing all the quizzes again. All right, skill 16 is on geometric sequences, and I'll show you what these things are as we go along, but they won't say them by name. I will have to each time. Skill 16 is on geometric sequences. 17, exponential growth and decay models, still uses exponents. 16 and 19, I'll use exponents. Graphing exponential functions on 18. You'll have to see me kind of paste in graphs, and you'll have to see me sometimes go up to graphs because they were on some of the pages of the PDFs that they're on. So it's a little weird for skill 18. It's going to be a little dicey. Skill 19, solving exponential equations, meaning equations with exponents in them, not using logarithms. Skill 20, distance formula, midpoint formula. So those are on graphs or with graphing points. 21 and 22, we got angle addition postulate, segment for 21, angle addition postulate for 22, and then midpoint or bisectors for segments, angle bisectors there on 22. 23, parallel and perpendicular lines. Basically, are they parallel or perpendicular? Oh, great. This cough might happen. It's like a tickle. And make the equation of a line that's parallel or perpendicular to another line. 24 and 25 really are the same thing. Special angle pairs, angle theorems, and algebra. 24 is basically without using the algebra. 25 is using the algebra. And 24, sometimes I just ask you to name a set of pairs. 26, polygons, interior and exterior angle theorems. So using things with polygons from triangles onward, and sometimes the remote exterior angle theorem for triangles. Sometimes they use algebra. Skill 27, triangle properties slash congruencies. So this is the start. 27 is kind of with 29. So this is going to be kind of weird with 28 in the middle, because 28 is more of kind of an argumentative thing. It's hard to explain, like where you just argue logic and reasoning. But 27 is where you start triangle congruencies. So angle, side angle, if you ever heard of this stuff, angle, side angle, things like that. But you don't do the 2-column proofs until 29. And not that these were quizzes. I don't necessarily ask them to fill out an entire proof. Sometimes it's just fill in the blank or whatever it is. And sorry if I keep looking over here. There's text coming from my phone that I see on my screen. My sisters are texting back and forth about something we have to take care of. And skill number 30 is on transformations, translations, rotations, and reflections. So those were the 15 skills that we did. Excuse me. I don't know what to do with this. Now, what's going to happen here, and you're going to see it from this first thing. We got a week 1 in skill 16. I'm not doing the problem this very moment, but week 1, skill 16, boom. Week 2 is skill 16 and skill 17. Week 3 should likely have 16, 17, and 18. So what you're going to see is a buildup of a new skill for each week, but the previous skills still exist in those weeks. So you're going to see more questions from skill 16 than any other quiz, because they start off each quiz. My students didn't have to do every skill in every quiz. In fact, they could only do up to 5. So if we're in week number 12, and they have skills 16 to maybe 27 to do, they might do skills 17, 19, 23, 26, and 27. and they skipped skill 16. Well, this is a good review for them to look back on. That's why it's good for me to go over these here as a video so they can find all the skill 16 questions that they want, or the skill 18, or whatever it is, over and over. Now, when I first introduce a skill, I'll slow down more on it. So on skill 16, the first time you see a question of that ilk, and I'll just keep scrubbing through these as you see them, I'll be a little slower the first time. But as I move on to the skill 16s in later weeks, I'm going to speed up more and more to the point I'm just doing the problem without even teaching it. Kind of just doing it, and there's the answer. Any questions, move on. Now, you're going to see here a couple things that are going to happen later when you hit week 8 and such. There's an answer key thing on the front of theirs, an answer prompt thing for them to answer from, and then week 18 spills over into here, so this is where they got to kind of do the graphs. So I'll probably draw the graphs up here whenever they fit. Now, eventually I run into more pages, so like, let's see, okay, these don't do it. Okay, so these weeks don't do that. So like week 10, I can still fit all the skills on here. And then they hit a midterm, which does have all the skills from week 16 to 25 on it. And then it's differently laid out because they could do all 10 skills. Week 12, you start to see this jump into, here's a next page of problems for that week. So it gets a little interesting. And one thing of note, guys, there were mistakes on my quizzes, like typos that I'm like, oh, kiddos, you're going to have to change this, or this is going to lead to a dumb answer. And I never changed them on these files. I just changed them the day of. So we're going to run into them, and I don't know when they exist and when they show up. I might not even know until after I do the answer and say, oh, that's what I was supposed to do for this problem. So there are some things that are going to happen. Anyway, all told, and I know there's a lot of talk throughout. This video is long anyway, and you can tell. This goes up to week 18. I know there are 2 weeks that are skipped. I think there's a week 7 that's skipped and a week 11. I guess technically week 11 was the midterm. And week 7 was technically our like spring break or ski week or whatever you'd call it, President's Day week. Week 18, week 18, by the way, only covers skills 26 to 30, just those last 5 skills. So actually week 16 is not hit there. So you can see what's going on. All told, there are, I think, more than 250 problems. So even if I averaged a problem a minute, that's still over 4 hours with this talk as well. So hopefully you're strapped in and ready to go. Obviously, you're probably not in here to watch the whole video. If you are insane, like I am for recording it. And I'm starting this. It's 8:10 p.m. my time right now. So when I finish, it's going to be 1 o'clock in the morning. So we'll see how this goes, guys. We're going to go ahead and get started. Enjoy whatever baseball's in the background. I didn't get to watch baseball today. Been a pretty busy boy. That's why I'm starting this at 8 o'clock. Before I begin, I'm going to go ahead and some water. Ready? Here we go. Week number 1. Skill 16 only. Find the next 3 terms in this sequence, and then write the explicit rule for the sequence and find the value of the 10th term. Okay. A geometric sequence is a sequence whose terms are separated by a common ratio. If you heard about arithmetic sequence, where terms are separated by a common difference, these are the terms, by the way, right here. Separated by a common difference. Common difference means what you add or subtract going from one value to the next. I should technically say add, meaning you add negative numbers sometimes. In a geometric sequence, a common ratio is what you multiply going from one number to the next. I don't want so I didn't want to say add or subtract because I don't want to say multiply or divide. Numbers may go smaller, but we're asking what you're multiplying by from one number to the next. So in this particular sequence, and most people can probably tell me, this is a geometric sequence right now because you are multiplying by -4 going from one number to the next. That is the common ratio. The ratio is -4. If you were to find the next 3 terms of this sequence, you can work recursively in that form by multiplying 128 by -4, that value by -4, and that value by -4. And when you do so, you get the next 3 terms in the sequence. And what's going to happen also is the signs are going to alternate. That was negative, positive, negative, positive. We'll have negative, positive, negative. So even if you forget to do the multiplication part or whatever, you can get those things ready to go. So I'm going to go to the calculator right now just to begin with and do that part with you. Let's go ahead and do 128 times -4. That number times -4, and that number times -4. So you're seeing the 3 answers right here. I'm going to write them down as I see them. -512, excuse me, positive 2,048, and -8,192. So those are the 3 answer, or those are the three portions of the answer there. That answers the question, find the next three terms in the sequence. Now I did that recursively. By recursion, I mean using the previous value to get the next value, and that's a nice tool to use for something like that. If they said find the 100th term, which you don't often do for geometric sequences because that would be huge, I would do something else. I would do something using what's called an explicit rule, and that leads me to number 2. Write the explicit rule for the below sequence, then find the value of the 10th term. So there are two things being asked here, writing the rule and finding the value. Now an explicit rule comes in this form that looks like this. It's going to be a little confusing to look at, but if you've done things with sequences before, hopefully it makes sense. Not just geometric, but also arithmetic. To find the value of some term n, you take the value of the first term, multiply by your common ratio, n minus 1 times. Now these are known as subscripts, a sub n and a sub 1. A just representing the value of terms in your sequence. The sub 1 is your first term, so in this particular sequence, my a sub 1, the value of the first term is negative 3. The value of the second term is negative 6, like that. If they said find the value of the 10th term, I could, here's the 4th, right? I could multiply by my common ratio, 5th, 6th, 7th, 8th, 9th, 10th, over and over till I get there. But the geometric sequence explicit rule also gets me there. My common ratio in this case, by the way, is 2, multiplying by 2, going from one value to the next. And if you're having trouble coming up with what you're multiplying by, you can divide one number by the one before it. Negative 6 divided by negative 3 is 2. Negative 12 divided by negative 6 is 2. Negative 24 divided by negative 12 is 2. Positive 2. These are negative numbers and they stay negative. 8 divided by negative 2 is negative 4. Negative 32 divided by 8 is negative 4. 128 divided by negative 32 is negative 4. So are these. They gave you negative 4. Divide one value by the one before it. And that's important when we hit those other ones that become weird fractions or decimals, or it's just a hard number to figure out. That's a way to go about it. And that's what we're going to do, because it is what you're multiplying by. And you have to divide to figure it out. Anyway, first term is negative 3, common ratio is 2. Your rule, to find the value of the nth term, you take your value of your first term, negative 3, multiply by 2, n minus 1 times. And it's n minus 1 times because, remember, you start at negative 3. Negative 3 is your first term. If I want to find my second term, plugging in 2 into here, I'm going to multiply by 2 just once, not twice. I'm already at my first term. My second term is just a single times 2 away. The fourth term is 3 times 2 is away. And the 10th term, which we have to find, a sub 10, is 9 terms away. So I'm going to multiply by 2 9 times. That's not 2 times 9. That's 2 to the 9th power. 2 times 2 times 2, 9 times, starting from negative 3. So if I go to my calculator, I can do, and remember, this is my version of doing this slowly the first time. I'm not going to spend as long doing it the next time like this, if there's a question like that. So this is what I'm going to set my calculator, and this is what comes out. That's not negative 3 times 18, right? 2 times 9 is negative 3 times 2 to the 9th power. So it is negative 1,536. I don't know why that looks so blurry on here. It seems like it should be sharper. Anyway, that's the answer. That's the value of the 10th term, negative 1,536. And those were the two, I guess, questions within that part. Now remember, this 9 came from 10 minus 1. In order of operations, we do things inside the exponents first before we do something with the exponent. So I do 10 minus 1 beforehand. Okay, now as I move on to week number 2, you're going to see another set of sequence values, another skill 16, right? I'm going to start with skill 16 each time I repeat a thing. Okay, so skill 16, again, write the explicit rule for the below sequence. So this is a sequence where you might say, okay, and you might notice we're dividing by 3, right? Dividing by 3. And what's 10 divided by 3? It is 10/3. Okay, that seems to make sense. But r isn't 3. You don't say r is 3, because 3 would mean what you're multiplying by, and we're not multiplying by 3. We're dividing by 3. So we have to figure out what we're multiplying by, because if we needed to write a rule, that's what we would be using. And the answer is 1/3. Remember what I said. Divide one term by the one before it. What is 30 over 90? It's the same thing as what 10 over 30 is and what 10/3 over 10 is. That one's a little weird. But this all reduces to 1/3. That is your common ratio. And if you ever forget that little nugget of like what you're multiplying by one to the next, think about it. You're doing 90 times some r value, which equals 30. How do you solve for that r value? You divide both sides by 90, like that. Now the fraction has to reduce, just like these did, but that's where the division comes from. 90 times what is 30? Divide by 90 to figure it out. Same thing with 30 times what is 10. 10 times what is 10/3. Okay. So anyway, 1/3. So we have to write the explicit rule. Your a sub 1 is 90. Value of the first term. Notice I'm only the third problem in of what I say, 250 some odd problems. This is going to be a long thing. So a sub n equals 90 times 1/3 to the n minus 1 power. These parentheses around this guy are very important for fractions and negative numbers because they have to adhere to order of operations. They have to both be a part of the exponent. So you absolutely need parentheses for those if you're going to use fractions or negatives. All right, find a sub 16 in the below geometric sequence, which would mean we do need the explicit rule for it. They're saying find the value of the 16th term or multiply something over and over until you find the 16th, but I'm going to use the rule. So your common ratio, and this is where, am I going to do 1/2 divided by -1/8? No, you find the two terms that you think are going to help you best for this. I believe going from -2 to 8 is going to be easiest. That is -4 that's being multiplied. And if you believe that this is a geometric sequence by what I stated, then that means that the common ratio is that this will always be times -4, even with other values. I just don't have to test it. I just know it's -4. So the common ratio here is -4. The first value is -1/8. My explicit rule to find the value of any term n is -1/8 times -4 to the n minus 1 power. Now that's not the answer, in fact, so let's not box it. That's wrong to do. So let's go ahead and find the 16th term by substituting 16 into that rule. And that's the glory of having such a rule. 16 minus 1 is 15. I'll go to the calculator. I'll show you it if it seems to be something that's worth showing. Otherwise, you can go ahead and try it and see if you get the same number. Actually, you know what? I will show it to you because I want to show you that I got to use parentheses around that -4 right here, just like that. Otherwise, it might lead to a false answer, all depending on what you do. Anyway, it's that big number. Let me go ahead and write that down. Then you want to write exactly. It's positive. All right. 134,217,728. That is the value of the 16th term. For what context? There wasn't any. Skill 17 will have context applied to problems. It still uses an exponential basis represented a little differently. Okay, these are word problems modeling what are called exponential growth and decay on skill 17. You're going to see me use this format of equation each time. Now, this may look different from what you just saw over here for skill 16, but I promise you they have the same idea. There are some things that are a little slightly different based on what we're doing with it, but what you have is final value, initial value, growth or decay factor, and exponent. Here you have final value, initial value, common ratio, it's what you multiply by, it can make it go bigger or smaller, and an exponent. -1, but an exponent. And the idea is still the same with this. Once it cleans up, they may look identical except for this being a y and this maybe being a t. So it just depends on what you're doing with them. But this model is set up so that we can do percentage increases and decreases based on the context of the problem. Let's read a problem and see what's going on with it. Annual sales for a fast food restaurant are $650,000 and are increasing at a rate of 4% per year. Write an equation that models the restaurant's annual sales after T years. So we're not actually answering a question in full. We're just writing the model, kind of like an explicit rule. But in this case here, we have the initial value, 650,000, which is our A in this case. Kind of our A sub 1, but it's more of an A sub 0. This is at time 0. Annual sales for a fast food restaurant are this many right now. Not at time 1, not 1 year from now or 1 month or 1 second, I guess, but now in the 0 second. So it's kind of an A sub 0, and that's why it's not a T minus 1, because we are kind of at a y-intercept, not at some first term in a sequence. Okay, increasing 4% per year. R isn't 4. We're not multiplying by 4. Excuse me. Yeah, R. It's not a common ratio either. R is actually 0.04. What you do is take the 4's decimal, which is like 4.0, and you divide it by 100. You take it 2 decimal places to the left, because 4% is 4 out of 100. And 4 out of 100 is 0.04. To increase at this rate, what this means as far as writing this model is we are going to add from 1 this 0.04 value. The decimal equivalent of this value is what we actually multiply by when it comes to doing a percent increase or decrease. If I take 50% of something, I don't multiply that value by 50. I multiply it by 0.5. 0.5 is 50%, move 2 decimal places over. 0.5 is equivalent to 1/2. 1/2 is the same as 50%. You get the picture. Times 50 over 100. But anyway, so let's do this. Increasing at a rate of 4% per year. So I'm not going to take 4% and then add it. I'm going to add 4% to this 1. And this 1 is 100%. Think of decimal equivalents. This is 1.00. If you move it 2 over, that's 100%. Hopefully it's making sense, or hopefully you've heard this before. So what's this equation going to look like? Y equals 650,000 times 1 plus 0.04 to the t power. I want to simplify the inside. I'm going to ask that each time we do this, 1.04 to the t power like that. That is the equation that models the scenario. Now, I'm not answering a question with it. It could ask, find the annual sales for the restaurant after 10 years, and I'd substitute in 10 for t. That'd be it. But that's what's being asked for the model. This model can now be for any year t. You could see it on a curve, and you're going to see graphing exponential functions on skill 18 coming up in the next week. Okay. In the fictitious, oh yes, so this was January. I don't know when you're watching this. Maybe it's in the year 2023. Maybe it's in the year 2035. I have no idea. But The Last of Us came out in January of this year. Love the show. Love the game. So this is my way of spreading to my students love for a game. They're like freshmen, and this is something that's pretty graphic content, so I don't know if they're allowed to watch it. And kids watch anything these days on their phones, I guess. Anyway, let's move forward. In the fictitious world of The Last of Us, new HBO show based on the same name video game, PlayStation, Earth's population in 2003 was big, 6.386 billion, before the cordyceps outbreak occurred, which caused widespread infection and death. There on out, Earth's population began to decrease at a constant yearly rate of 27.6%. On this show, what would be Earth's population in the year 2023? So, a lot of things going on in the problem, and we have to kind of break down what it is. First of all, we have an initial value. So this is the A, 638600000. You can't mess up on your zeros, otherwise it completely messes up your problem. R value here starts from 27.6. Move it 2 decimal places over, it's 0.276. Population decreases. There's a virus outbreak, a fungus outbreak, and we're dying by widespread. That's going to shrink us pretty far down. Now, T is going to be something else I talk about as well. First, let me write the model for this. 638600000 times 1 minus 0.276 to the t power. This is for a model for this equation. What's happening by the subtraction is because we're losing people. That decrease happens. Let me simplify this inside. That is I don't want to be wrong, 724, I believe. So the other way of saying this is why I also like the simplification. A 27.6 decrease, if they say something like, hey, decrease by that amount, that also means you're taking 72.4% of the value. And by the way, I don't trust my own math. I'm going to go ahead and try that in the calculator. I got to use it anyway later. Yeah, 0.724. You're taking 72.4% of that something also, which means it's lessening. It's getting smaller. And over the course of how many years? Here's the next part. The year 2023, do I plug in this number? No. Our year 0 for this was 2003. 2023 is 20 years later. So when t is 20, that's what we're going to substitute here. 0.724 to the 20th power. And let's approximate what that is. I'm going to the calculator for it. I want to show you what it looks like. I know I had an intent with this problem. These were problems I made up. So it's, where's graph calculator? So I wanted to have nice numbers here. I could have done something a little, I kind of wanted them to say 6.386 billion, but the problem is this other number gets really small to the point that you probably don't want to say that. So raise the 20th power and check that out. Let me first write it. How many zeros? 1, 2, 3, 4, 5, 6. Am I counting that right? I think 6 zeros. 1, 2, 3, 4, 5, 6, and then a 5. And the 0.48. Now, let's talk about that. This is all I wrote. I didn't write let me write the 0.48. the thing with these problems, when they ask you the actual question, the first one just to write a model. This time they're asking how many people. There's context. And context means we got to provide units, and we got to do proper decimal, non-decimal rounding. We're talking about people. People aren't evaluated in decimals, and I don't know if I got to talk to you about that kind of stuff or not. Now, when it comes to rounding up or rounding down, I'm going to go ahead and round to the nearest number on a lot of these. I used to make arguments in the past, and I still would, that maybe that person hasn't died yet, or they are on their way of dying, or they have died, like that kind of thing. And then I would say, no, you cut off the decimal, even if it says 0.9. These days, I'm less concerned about that and more concerned about understanding the context. First of all, writing the units. You can say people or population is. And what is this? This is 10 million people. So that's the idea. Hey, you got about 10 million people left on the planet now. Was that accurate to the show? I don't know. I think I did Reddit research that some people said it's somewhere between 100,000 and 10 million people. I didn't want to make it so depressing and make 100,000 out of it. And this was about the world's population in 2003. So there's that. Anyway, I'm babbling. We're just about a half hour in. We got to keep moving on. So that's skill 16, skill 17. We're going to do skill 16 and 17 again, and we'll add skill 18 with graphing after this. Okay, skill 16. Write the first 4 terms in the geometric sequence given the following rule. So this time you now have the rule to deal with, and we got to get the first 4 terms. There are 2 ways you can do this. The first way I probably wouldn't recommend as much, but it's actually substitute 1, 2, 3, and 4 into there. Like actually find explicitly a sub 1, 2, 3, and 4 by plugging 1 in, and 2 in, and 3 in, and 4 in right into there. So it'd be like negative 5 times 4 to the 1 minus 1, or to the 0 power, and negative 5 times 4 to the 2 minus 1, or first power, negative 5 times 4 to the 3 minus 1 power, or 2, and negative 5 times 4 to the 4 minus 1 power, or 3. Now I'll tell you what those are. 4 to the 0 power is 1, not 0, but 1, times negative 5 is negative 5. 4 to the first power is 4, times negative 5 is negative 20. 4 squared is 16, times negative 5 is negative 80. And 4 cubed is 64, times negative 5 is negative 320. So there would be your first 4 terms. That's a way to do it. Here's another way to do it. Take note of what's going on. This is your first term. If you understand the rule, this is your first term. This is your common ratio. Your first term is negative 5. I mean, we answered that before, but that's what it is. That's what the number is. 4 is the common ratio. That's what you multiply from one value to the next. What's negative 5 times 4? What's negative 20 times 4? And what's negative 80 times 4? And there they are. That's kind of how I recommend it. Depends on how many you have to... No, yeah, that's how I'd recommend it. It's kind of recursion. Go from one value to the next. As long as you have the first term, I'd say you're good to go. Either way, you do get to the answer. All right, find a sub 12 in the below geometric sequence. Now, I said right exact decimal. I guess it goes down kind of like that. So to find a sub 12, this is one of those things where you might want to come up with a rule. Okay, so this will be your a sub 1. You might notice right off the bat, and I'm going to tell you straight up, we're dividing by 2. That's that's the pattern. But that also means you're multiplying by 1/2. And I've brought that up a couple times now. Or 0.5, if you will. But times 1/2 each time, that's your common ratio. So there's your a sub 1. A sub n is a sub 1 times r to the n minus 1 power. You can see how I went a little speedier this time than last time with these. So let's go ahead and find a sub 12 by doing exactly that, following this. This is to the 11th power, 12 minus 1. And I'm going to go and punch that in. I'll put a 0.5 in here. Raised to the, I know you don't see this, raised to the 11th. All right, 31.25. It's not a bad decimal or anything, but I didn't want them to round to something if they practiced it. It's exactly 31.25. That is the 12th term in the sequence. I'm sure I could have done that recursively faster in my head, but we're not doing that. Skill 17, word problems. A new car that sells for $18,000 depreciates 25% each year. Write a function that models the value of the car, then find the value of the car after 4 years. 2 questions were being asked. I tend to write the model the first time anyway. In the future, I might not, unless it's requested, just for time. But in this case, we have an initial value. This is y equals a, the initial value is a, times 1 plus or minus r to the t power. Depreciates. These are kind of words you're going to have to either know or figure out. Depreciate, decrease. 1 minus 0.25 is that value there, 25%, raised to the t power. So simplified for the model, that's a 0.75 inside there. So there's the model. And now let's find the value of the car after 4 years. Now, this was dollars, so when I do dollars here, I expect my students to pretty much use cents as well. So 2 decimal places is where I want to do kind of the rounding. So 75 to the 4th power after 4 years. Let's check out the calculator on this. 18,000 times 0.75 to the 4th power. And it's this number. Let me write that first. 5695. Now, I'm going to put the 0.31. You see 0.3125. I'm going to go ahead and do 0.31 for cents on the dollar. And I'm going to put the dollar sign in front of it. And that's going to be the value of the car. Now, will the dealership care if you don't pay those 31 cents? No. In fact, they might even round up and call it $5,700. They might let you take it out of the lot for $5,600. For the sake of argument and for other problems where the cents are needed, units are going to matter in that way. So I'm going to differentiate. Humans, no decimals. Dollars, 2 decimals. I mean, I won't do 3 and I won't do 1. I might do no decimals in some problems, but 0 or 2. Hopefully that makes sense. All right, in the real world of Earth's population, in 2003, okay. In the real world, Earth's population in 2003 was that, and has increased at a constant yearly rate of 1.1%. Is Earth's population... What is this? This must be a typo PDF. This must be an old one. So I apologize for this one here. I really should have looked through this because these are old edits, and I didn't look through them. My bad. So let me try and think about what this probably said. And I hope this is an updated one. In the real world, Earth's population in 2003 was that many billion and has increased at a constant yearly rate of 1.1%. What is Earth's population in the year 2023? So this is not a Last of Us scenario. This is an us scenario. This is all of us scenario. So let's see what this is going to be. Now hopefully this is probably pretty close to what the actual population is. I think I remember somebody telling me that this was not only off, but well off. I think I was looking at wrong data. Thanks, Google. But let's go with the question. All right. Y equals 638600000 times. Now let me kind of go faster now. We're going to do 1 plus our R value. Now the R value, you got to be careful here. It's not 0.11. You got to move it 2 decimal places over. That's 0.11, 0.011. So what happens when you add 1 with 0.011? It's 1.011. For a model, it would be to the t power. Our t is 20, just like last time. So this is what we're going to compute. 386000000 1.011 to the 20th power. All right, I'm going to write this out. I know you can't see it. And this is exact. All right. I figured it would have a decimal, but maybe I accounted for this. 79478933262. So this is boom, boom, boom. So that's billion. So people. So I think the inaccuracy, and anyone else can back me up when they look at it, they said, Mr. Robinson, I think we already have 8 billion people. And I said, well, okay. Then I looked at outdated information. Maybe it was from 2022. Maybe it was January. Whatever. So I looked at wrong data, or outdated data. Okay, skill 18. Now let me see if I paste. Did I paste anything over this already? Paste. There it is. Perfect. Okay, so I'm going to be drawing graphs with these pretty much all the time for you guys, or wherever I can do them. We're going to draw graphs. This is the new skill, graphing exponential functions. So I'm going to probably spend longer the first time, and then I really want to speed it up after. I mean, really, really speed it up after. If we were to graph this by nature the first time in ever, you'd have to know exponential properties beforehand, and I'm going to go pretty fast on those properties, something that you just kind of have to know. I'm going to plug in some values like these. Boom. And I'm going to start with 1. You saw order of operations right before. You do 2 to the power first and then multiply that by -4, or whichever way you put it. Just make sure you don't do negative 4 times 2 first, right? So negative 4 times 2 to the 0. 2 to the 0 is 1 times negative 4 is negative 4. 2 to the 1 is 2 times negative 4 is negative 8. 2 squared is 4 times negative 4 is negative 16. 2 cubed is 8 times negative 4 is negative 32. And I'm saying these numbers. Those are what I'm substituting. 2 to the negative first. Negative 4 times 2 to the negative first. 2 to the negative first power is 1 over 2 to the positive first power. This is negative 4 times 1 half, or negative 4 divided by 2. So instead of multiplying by 2, we're dividing by 2, which is negative 2. And then times 2 to the negative second is over 2 squared, so over 4. Negative 4 over 4 is negative 1. These are the points we're going to plot on this graph, or at least ones that we can fit. So this is going to look like 0, negative 4, 1, negative 8, and honestly, I can't fit these other ones, 2, negative 16, and 3, negative 32. Negative 1, negative 2, and negative 2, negative 1. Now, what would happen over time? Maybe you can see the pattern now, and this will help us for the future, because I don't want to do this each and every time. I don't even want to do the table each and every time. Is you can see that we are multiplying by 2 each time as we increased from here. Now, you can also see that we divided by 2 going this direction because we're multiplying by 2 going downward, right? But you want to probably start from the 0 value because there's going to be some relevance to that you're going to notice each and every time. Multiply by 2 one way, divide by 2 the other way, or multiply by 1 half going the other way. So if I kept dividing by 2, what is negative 1 divided by 2? It's negative 1 half. Negative 1 half divided by 2 is negative a quarter. That's the kind of thing I'm going to be doing a lot faster later. Now what you'll notice on this graph, because I'm going to connect these dots, there are points in between that I'm not calculating, but they do exist. And they exist in a smooth curve fashion. This is what your models would look like, only often positive. What's going to happen is you keep dividing a value by 2 over and over. It's going to keep getting smaller. And I say smaller like not larger negatives. I mean like closer to 0 smaller. Does it ever become 0? No. You divide a negative number over and over by 2. It's really small, but it's never 0. Will it ever become positive? No. So it's just going to become super small negatives getting closer to 0. So what we do is we feature that with what's known as an asymptote. And I didn't make up the word. A-S-Y-M-P-T-O-T-E. A-S-Y-M-P-T-O-T-E. It's a dotted line that it's not a part of the graph, but it represents our graph in a feature kind of way. It says, I will not touch or cross this line. I will merely approach it. I get closer and closer to it, and the dotted line kind of helps accentuate that idea. So this gets closer to the asymptote. Otherwise, it's something we shouldn't touch or cross. We just get closer to. And the other way takes off forever. So it's not like a parabola. It's not a U-shape. Excuse me, but that's what number 1 looks like. I spent a lot of time on that table doing that. I don't think I want to do that each time, but I'll kind of show you some of the patterns with this as we go along. Number 2, graph 3 times 1/3 to the x power. Now, what you did notice is a pattern that I do want to throw into the fold. And then I'll kind of say more as we go along regarding what we can actually do with this. When we can make tables, but we can also, if you know how to do it without it, it'll be a lot faster. And that's what I'll eventually do. By the way, this is called negative exponential growth on number 1. Negative and growth. It grows negatively. This number 2, it's called positive exponential decay. And you're going to see why in a moment. Okay. Let's start with this, 0. 1/3 to the 0 power is 1. 3 times 1 is 3. Now this 1/3, just like this 2, is going to represent what we multiply by as x increases by 1, and what we divide by as x decreases by 1. So we're going to be multiplying by 1/3 over and over this way, which also means dividing by 3. Keep that in mind. But you might want to keep the fraction once you start hitting fractions. 3 times 1/3 is 3 divided by 3, which is 1. 1 times 1/3 is 1/3, and 1/3 times 1/3 is 1/9. See, it's a lot easier to say what's 1/3 times 1/3 instead of what's 1/3 divided by 3. That being said, if I start dividing by 1/3 going this way, I had to multiply by 1/3 to get to 3. So what was this number up here? Dividing by 1/3 is the same as multiplying by its reciprocal, 3. Instead of saying divide by 1/3, you say, hey, let's multiply that by 3. I think it's a lot easier to say. And what's 3 times 3? It's 9. And 9 times 3 is 27. Now, not all these points we can fit, absolutely not, but we're going to fit what we can. Start from that y-intercept of 0, 3, and we have 1, 1, 2, 1 third, 3, 1 ninth, which it's getting closer to that asymptote, and none of these graphs are going to have any shifts, no vertical, no horizontal, nothing like that. All the asymptotes are going to be at y equals 0. That's not going to change, at least not for IM1 stuff. There's negative 1, 9 like that, and the graph decays in such a way, kind of like the car depreciation or the humans in The Last of Us. We're losing people and getting closer to 0 there, but it's from the positive side, so this is what is known as positive exponential decay. And always draw arrows because this has an infinite domain. It goes forever left and right. The range is limited by the asymptote and getting closer to 0, but that's what it is. Now, we want to start at this place here for a very good reason. I want to point to these before moving forward, so my other graphs will be a lot faster. These are coming in the form y equals a times b to the x power. It's really no different than our geometric sequence. Let's start with this. Really no different from our exponential models of y equals a times 1 plus or minus r to the t power, or our geometric sequences a sub n equals a sub 1 times r to the t power. N minus 1 power. These are all exponential functions. They all have some initial value and then multiplied by some growth or decay amount and then raised to a power. They all do that. They're all exponential in nature. They just have different representations and forms based on the variables you need for certain context. This is an xy axis, so we use x and y. This in geometric things, they only use integers, and they're only from the first term onwards. They use subscripts with it, and all that kind of stuff. And this one uses rates and time and is in context. So it's all kind of situationally based, but it's all there. Point being, notice every time the x was 0, you raise this thing to the 0 power, you get 1. 2 to the 0 is 1. 1/3 to the 0 is 1. And what happens is you end up just multiplying by the a value of negative 4 or 3. And what was negative 4 was the a value, 3 was the a value. There's a y-intercept of 0, a. A is your y-intercept. B is clearly the growth or decay factor. It's what you multiply by as x increases by 1 each time. You can see that in the tables. Multiply as x increases, divide by as x decreases. And that's what we can do. We don't need this plugging into an equation. We don't need to do this, use a table. You can. I'm not going to anymore. I'm 42 minutes into this thing. I'm not going to do that anymore. I'm going to use that table in this way. And in the future, I'm not going to end up using the table unless there's something new that I have to do. But those are the two graphs for that problem. That's skill 18. Let's move forward to week number 4. Okay, skill 16, write the next 3 terms below in the geometric sequence. No decimal answers allowed. And we just did some fraction things before, so this is good practice. What's this next term, and next term? Now, I say no decimal answers because these are getting smaller, like they're decaying. They're getting closer to 0, just like the previous stuff. This is a lot kind of like one of those problems before. I'm not going to write the rule, but I do want to find the common ratio. And it's the same thing dividing any one by the one before it. Let's do negative 3 over negative 9. I think that's best. That reduces to 1/3. And I want to say 1/3. I don't want to say 0.3 repeating or 0.3. I don't even want decimals in my answers. Let's multiply these by 1/3, which indeed means the same thing as dividing by 3, but you just saw what that looked like on the last set. Negative 3 times 1/3 is negative 1. Negative 1 times 1/3 is negative 1/3. Negative 1/3 times 1/3 is negative 1/9. You multiply numerator with numerator and denominator with denominator. Those are the next 3 terms in the sequence. No decimal answers were written. Because remember, that would be some negative 0.3 value and some negative 0.1 repeating value. Those would be rounded, though. Even if you say repeating, I don't know if it's rounded, but I said it's not allowed. Let's use fractions. Easy to compute. All done. Number 2, write the explicit rule for the below geometric sequence. So we have this. So remember, these are going to pop up all the time. It's, do you know it, do you not? So maybe you can give this a shot. This is a sub n equals first term of negative 1 times, common ratio looks like it's negative 5. Hopefully you can see that to the n minus 1 power. Here's another accepted answer. You don't really need the negative 1. You just need the negative symbol. Now, is it okay for me to do negative times negative is a positive? No. This negative is a value on the outside. In order of operations, PEMDAS doesn't allow for that kind of thing. You'd have to make sure the signs alternate each time here. We need one and the other. One or the other works just fine. All right, skill 17, exponential growth decay models. A Product guarantees to exterminate 30% of all bacteria in an area every day. If an infested room contains 1,000 bacteria, which doesn't sound like a lot because they're little microorganisms, how much would remain in the room after 1 week? Round to the nearest whole number. So I asked them to do that here. All right, 30% of all bacteria in an area every day. So as a model, removed, exterminate, right? We start with 1,000 bacteria, and 1 minus 30% is 0.3 as a decimal equivalent. So to the t power. So 1,000 minus times 0.7 to the t power. After 1 week. So do I substitute 1 for t? No. This 30% removals every day. 1 week, we're saying 7 days. So we're going to raise this to the 7th power. That's what I'm going to do. So 1,000 times 0.7 to the 7th power. Now I'm getting this number, 82.3543. I said round to the nearest whole number. The nearest whole number is 82. So this is around, there are 82 bacteria remaining. Kind of a weird question that I came up with as far as like, what does 82 bacteria look like? How much is it actually infesting the room? How big are these actual bacteria? Probably not. This product doesn't actually seem that great. Because a lot of them say like kills 99.9% of all germs and things like that. I just want to make sure that the numbers look good and they don't have to make too big. All right. In 2001, a Tom Brady rookie card could be purchased for $5 due to his wondrous football career success. Very much so. This card increased 50% in value yearly. How much would the card's value be this year? This year was 2023. I don't know when you're watching this, but 2023. 2001 Tom Brady rookie. Oh, I wish he was still playing. All right. So our model, $5 initial. Wish I bought it for that much. Increased 50%. So 1 plus 0.5. So I'm just going to write 1.5. I got to start speeding some of these up, right? And this year, 2023, from 2021, 22 years later. So to the 22nd power. They didn't ask for a model, so I'm not writing it with T. Let me type this in. All right, so this number is, I'm going to go to the nearest cent. So I got dollars, 37409 point, it said 13821. So I'm going to put 14. 14 cents. I want those 14 cents if I'm going to sell it. $37,409.14. You go, Tom. All right, skill 18. Let's go ahead and graph these. So, like I said from last time, let's do it in table mode. I'm going to go a lot faster this time. Someday I'm going to stop doing the tables. Get ready for those. Put 0 in the middle. You need some on the right, some on the left. You know what I mean? Let's even add some. 1, 2, 3, negative 1, negative 2, negative 3. This 2 represents the y-intercept. Boom. That's this guy. That's A. B is the growth factor. Times 2 is 4. Times 2 is 8. Times 2 is 16. So these are points on the graph. 0, 2, 1, 4, etc. Divided by 2 is 1. Divided by 2 is 1/2. Now, divided by 2 is 1/4. Remember, these are also times 1/2. Now, this isn't much different from geometric sequences. I'm not writing it as a list, and we're getting the 0th term and negative and things like that. It's not much different, right? It's like a common ratio, recursive rule, recursively going from one value to the next. That's what I kind of keep telling my students with it. So even though we're seeing it like a table, even though we have to graph it, not much different. So for those who still struggle with it, I mean, really think about it that way. That's what's happening. And eventually, like I said, I'm going to stop doing the table. So when I say times 2 is 4, times 2 is 8, just be ready to plot them. Like right now, I'm not even actually looking at my table to plot these. I'm taking half of the previous value. 1/2, 1/4, things like that. And this has an asymptote on the x-axis, the equation y equals 0 right there. And I can go ahead and draw that curve. And that's positive exponential growth. And I think all of these will have one positive, one negative. So I think I can both fit them on the same graph as long as this is the graph I'm going to use. All right. Excuse me. Negative 8 times 1/4 to the x power. I cannot fit that there. All right, 0, -8, right? That's my y-intercept. Multiply by a quarter. That's divided by 4, so I get -2 when x is 1. When x is 2 times a quarter again. What is -2 times 1/4? Well, it's -2 quarters, which is -1/2. So I get -1/2 there. At 3, it's -1/8. That's actually a lot faster to do than the previous one. Now on this side, I divide by 1/4, which is also multiplying by 4. -8 times 4 is -32, so I get -32 there. And I clearly can't fit that, so I'm done coming up with points. You might ask how many points you should fit. As long as the fractions seem relevant, and as many as you can fit on the other side. So this is negative exponential decay. I have -8 right here. And by the way, you're likely to see repeats of some values in some form. Maybe you don't see -8 times a quarter to the x power later, but maybe you see -8 times 4 to the x power, or 8 times 1/4 to the x power. You're going to see repeats somewhere, because I got to fit them on these scales. And there are only so many things you can do before students go, what, 5 times 1/6? And I don't do things like that. So anyway, 1 comma -2, 2 comma -1/2, 3 comma -1/8. And you can see, if I want to get and have -1/32, that is insignificant as far as a point goes. At some point I draw the curve, and that time is now. But you can see that goes pretty, that goes pretty sharp. You know, I would mark wrong for my students if they did certain things, like kind of like what I'm doing right there. Not exactly. Don't cross the asymptote. Make sure you never go fully vertical. You know, things like that. There is -1 comma -32. It's down there. So don't actually go vertical. That's not vertical. Don't actually go vertical like that. You know, do what you can. All right, skill 19. This is the new skill here. Solving exponential equations. Our goal is to find out what this x is right here, with this x. This isn't 4x plus 5, but we can kind of do the same thing as we would do 4x plus 5, right? I'd want to solve for x. I'd do this really fast. We subtract 5 from both sides because we want to get the term by itself, and then we divide both sides by 4. You get 16. The difference is here, this isn't 4 times x. It's 4 to the x power. But I will begin with subtracting 5 from both sides. I want to get this thing by itself. Now, there are different ways to do this. Some calculator usage, I give my students what's called a power table, so they can do a kind of a lookup. Can I raise 4 to what power to get 64? And the answer is yeah. I'm going to tell you these things out loud here. So my main thing, this problem's a lot easier than others because the answer is 3. 4 cubed is 64. But what I'm going to do is this whole, let's get to match bases. And the reason I talk about that is so that you can practice it for problems where you have to do it. Maybe even this second one. But we are going to have to do it a lot. So what I'm going to always do these times, even for me it's very redundant, I don't need it for myself. I'm sure some of you guys don't need it as well. 64 is 4, whoops, something happened to my mouse thing. 64 is 4 to the 3rd power. So I'm rewriting this as that. That's an equivalent. What I just achieved, though, is I've matched these bases. 4 isn't the answer, but I've been able to get these bases the same in an equation where these two things are equal. 4 to some power equals 4 cubed. What is that some power? It must have to be 3. This is where we get x equals 3, and that's solving for x. Maybe we did it right before. Hey, 4 cubed is 64, x is 3. I get that, but this match base thing is going to be used later. So you have to kind of get ready for that. Once you match bases, you set the exponents equal to each other. So that's the goal. Isolate your exponential terms where you can. Match bases. Set exponents equal to each other. Solve for x using simple algebraic means. 81 to the x equals 3 to the x plus 12 power. Now, 81 can be rewritten as 3 to the 4th power. Check this out. Instead of 81 to the x, I'm going to write it as 3 to the 4th to the x. Remember my goal. Match your bases. Are these the same base? Sort of. I'm trying to achieve 3, but it's not yet a 3 because 3 to the 4th is being raised to the x. 3 may be raised to the 4th, but 3 to the 4th is being raised to the x. Got me? All right, there's a property that exists that when you raise a base to an exponent, it's being raised to an exponent, these two exponents multiply together. That means instead of writing that 3 to the 4th to the x, I can rewrite it as 3 to the 4 times x, or 3 to the 4x like that. So those multiplied. Now I've matched my bases. Excuse me. Now, I'm so sorry for this. Let me pause for one moment. Okay, just sip some water. Now I've matched my bases. Now I set the exponents equal. It's not as obvious as what x is right now. Set those exponents equal. 4x equals x plus 12. Subtract x from both sides. Divide both sides by 3. You get x equals 4. And you can double check it. It's correct. 81 to the 4th is the same thing as 3 to the 16th. It'll work out. But that's the answer. That's what we're going to do in skill 19. So I'm going to try and do these a little bit faster over time. Now that you start to see the idea of what's going on. Hopefully it makes some sense. All right, week 5. Let's rotate back from the beginning. Find the 13th term giving the following rule. That looks weird, but let's go ahead and do it. You know what you do? You substitute 13 into here. A sub 13 equals 256 over 243 times 3 halves to the 13 minus 1 power or to the 12th power. Now punch this in the calculator. I don't remember if this is good looking or not. I'm sure I set it up in such a way that I wanted it to be. So let me see what kind of happens here. 3 halves to the 12th power. Okay, so the exact answer, yeah, this is fine. The exact answer is 136, 0.6875. I'm sure there's a fraction equivalent. I'm not sure it's something I was trying to go to. Let me see what the fraction looks like. The fraction is 2,187 over 16. I mean, it's a calculator usage problem. One or the other's fine. This is exact. It's not rounded. So that's it. Just plug in the number and make it work. The question for my students is, will they not be bamboozled by it? Can they use parentheses? And do they know what the question means when they ask the 13th term? That's all. Find the next 3 terms in the sequence, then write its rule. So I do want 2 things for this problem here. Next 3 terms in the sequence, you can notice potentially we are multiplying by negative 4. So I'm going to go ahead and do those in the calculator right now. Negative 448 times negative 4. That'll be a positive 1792. Now, the skills-based quiz stuff, something that is very controversial, is on these questions, they have to get the answers exactly right. Exactly right in every part of the problem for a given skill in order to receive what's known as a 2. A 2, that you can get a score of a 0, a 1, or a 2 on these. And a score of 2 is you got the problems both exactly right. And that means no flaws. Don't round that early. That proper negative. And doing both parts. Find the next 3 terms in the sequence and write the rule. There's everything involved. This needs an A sub n. It strives toward perfection, but the idea is they can retake these over and over. This skill 16, you're going to see like 20 times. So they get to review it over and over and try it over and over. And I guess that's the idea. Anyway, here's the first term. Here's the common ratio. Here's n minus 1. That is your rule. So my point is, if they wanted a 2 on skill 16 in this quiz, that had to be exact. Was it hard? I don't know, but it's particular. You got to make sure you don't mess up for one part. That's all. The population of Winnemucca, Nevada can be modeled by this equation, where T is the number of years since 1990. What was the population in 1990, and by what percentage did the population increase by each year? There are 2 by's on that, my bad. So by what percentage did it increase each year? Or whatever. Okay, this time you're given the equation. Now remember, the form is y equals a times 1 plus or minus r to the t power. A is the initial value. It says number of years since 1990. What was the population in 1990? This is the initial. The initial was 6,191 people. That was the initial population. So that's that question, the answer. I'm basically asking them to now take the model and dissect the A and the R. What percentage did the population increase by each year? 1.04. It's more than 1, so it is an increase. This is 1 plus R, or 1 plus 0.04. This is the R value. It's not 0.04% though. 0.04 is 4%. That's a 4% increase. So basically the way that it's being stated is, if this were a word problem where I said the population had this many people in 1990 increased by this each year, this is the equation they would write. So that's kind of their question. What would the information be for me to write this equation that I see? And those are the 2 values. Excuse me. An adult takes 400 milligrams of ibuprofen each hour. The The amount of ibuprofen in the person's system decreases by about 29%. How much ibuprofen is left after 6 hours? You'll notice in all the word problems, and I struggle really hard with this. It's kind of difficult to do. I always try and do different scenarios for each thing. I don't think you're going to get another car question. You'll get money questions. But, another, I try and change them up. Some get a little inventive. Okay, so initial value is 400. 29% decrease, so 1 minus 0.29 to the t power, so 400 times 0.71 to the t power is the model. All right, 6 hours later, 0.716 hours. This time, see, I didn't ask them what to round to. In this case, I kind of accept what they put because it's not money and it's not people. So it's kind of argumentative as to what I would expect. Maybe I told them in class, maybe I updated it on a different sheet, but this is about 51.24. I'll just go ahead and use 2 decimals for this, milligrams of ibuprofen. That's how much is left. Units matter. Excuse me. All right, skill 18. Let's try and graph without a table, shall we? If it seems smooth for me to explain, then I'm going to go ahead and probably do that in the future. I know I can't ask you guys how was that. I can. I can't hear your answer. Hopefully the answer is, it was okay. And if not, do a table, see if you get the same thing. Just hear it out loud. 5 times 2 to the x power. Your y-intercept is 5. If you think about the table, that's what we start, 0, 5. As x increases by 1, you multiply another 2 times 2 times 2. It's like your common ratio, right? Times 2 times 2 each time. 5 times 2 is 10. Do I plot it right here? No, you go 1 over. When x increases, 1 over. When x increases by 1, you now multiply by 2. If I increase x another set, I'd go up to 20, not to 15. 10 times 2 is 20. That's where I'd go. To the left, I got to divide by 2. And this is where studying the table can be helpful, because maybe you don't know the exact values. I'll tell you them. Maybe you know them for 2's, but really, it's also a graphing thing, right? You're dividing by 2. You're taking half the height. Half of 5 is right there. It's at 2.5. Half of that's 1 1/4, of course, and half of 1 1/4 is 5/8, of course, right? So it's just plot half the height. At that point, it's what's halfway. It's not even as a number, just visually, what's halfway, right? Try and kind of do that. And that's just kind of that idea. That's the idea. -6 times 1/3 to the x power, -6 being the y-intercept, times 1/3. This is known as decay. You are getting smaller, closer to 0. It's going this way. So we're dividing by 3 as x increases by 1. -6 divided by 3 is -2. -2 times 1/3 is -2/3. And then -2/9, and then I'm kind of good. -6 divided by 1/3 is -6 times 3. That's -18. So if I went to the left, 1, I would be going down 18. Not down 18, but at y is -18. And I can't fit that, and I'm not going to. So I'm just going to plot those ones and go to work. By the way, I don't know how to help myself best with these. And what I mean by that is I went over these quizzes with my students every Monday. Maybe they weren't there, maybe they weren't listening, things like that. But I wonder if it's worth my time at the time to go over them knowing I'd do this video later, or if this video is worth it if they've heard it the first time going through. I hope both are helpful. I hope you guys are enjoying this, whoever's watching, including my own students. Skill number 19. Let's go ahead and solve exponential equations. Let's do number 1. 64 equals... Okay, what are we doing here? So 64 equals 2 to the 9x minus 3 power. Step 1, isolate your exponential term. Boom, it's isolated. All right, good. Step 2, try and match your bases. Rewrite 64 as 2 to some power, if possible. And we can. This is 2 to the 6th power. 64 is 2 to the 6th. Does x equal 6? No, because this is 9x minus 3 in this exponent. Step 3, now that the bases match, set the exponents equal to each other and solve, which I'll do. Add 3 to both sides. Divide both sides by 9. You get x equals 1. Second problem. Let me rewrite this. 1/2 times 4 to the x power equals 8. Now, Now, I cannot multiply the 1/2 and the 4 the same way as I couldn't multiply the -6 and 1/3 and turn it into -2 to the x power. It's not the same thing. Order of operations, PEMDAS, applies. No matter how many times I've said this to my students, I'm not saying everyone, but to several students who I've told, some just haven't picked it up. You have to raise 4 to whatever power this is going to be. It's an unknown for us. You have to raise 4 to that power first before you multiply by 1/2. 2 to the x equals 8 is not the same answer to the question as this one, basically. This is x equals 3. This will not be x equals 3. Unless it's a false positive, it will not be. So we don't do that. So we got to isolate this thing. 1/2 is being multiplied by it. Let's divide both sides by 1/2. That sounds weird. What is 8 divided by 1/2? Well, we did practice it with the graphing thing, so I can tell you it's the same as 8 times 2. So it is 16. So this is 4 to the x power equals 16. What's a better way than saying times 1/2 though? I would do times 2, right? 1/2 means dividing this thing by 2. So let's multiply both sides by 2 instead. This is probably something you want to be familiar with. 2 divided by 2 is 1. This goes away. 8 times 2 is 16. I mean, either or is fine. You just got to find a way to do it. Just don't divide both sides by 2. And don't multiply 4 by 1/2. Just make sure you do that. 4 to what power is 16? We can all say that that's 2. I'm just going to go ahead and do that, right? Matching base. 4 to the x equals 4 squared. And that's it. X equals 2. See, I told you it's not x equals 3. So there it is. All right, there's a skill 20 to add to this thing. Now this, I'm going to go on a case-by-case basis for the most part. I'm going to have to write I have to introduce you to the skill. So let's go ahead and work that introduction right now. I always kind of, when I'm very consciously aware how many problems I have to do, I always kind of fret the first time I teach a problem, going like, I already taught it to my kids. Why am I doing it here? Sorry for the side commentary. This is my way of coping. And it's hot in this room. All right. Distance formula, midpoint formula. Straight up, these are about graphs, points on graphs. The distance formula is for something like this. If I have some points on the graph, x1, comma y1, and x2, comma y2, and you may be familiar with this kind of thing for slope and things like that, I want to find the distance between them. Let's call that d. There's a formula for this which looks like this. D equals, it's kind of complex, d equals the square root of x2 minus x1 quantity squared plus y2 minus y1 quantity squared. Now, for the sake of this problem, I'm going to substitute them into this formula. In the future, I'm not going to do it exactly like this. I'll let you know right now, I'm going to use something called Pythagorean theorem. Distance formula is, in a way, a rewrite of Pythagorean theorem. I'll show you it after the problem. But that's where we begin. On each of these problems, you're often going to find the distance, find the midpoint. Some problems, they'll be graphed. These ones, they're written. What's the distance between 4, 0 and 6, negative 8? Let's call this our x1, y1, and this our x2, y2. So d equals the square root of x2 minus x1 squared, 6 minus 4 quantity squared, plus y2 minus y1 squared, negative 8 minus 0 quantity squared. So d is the square root of 2 squared plus negative 8 squared. Now, parentheses are important for the same reasons as before. 2 squared is 4. Negative 8 quantity squared. It's not negative 64, but positive 64, right? These will always turn positive. So we're always going to be adding these in these kinds of ways. We're going to get the square root of 68. Now, there's a rounded version of this answer. 68 is not a perfect square. If I went to the calculator, square root of 68 is around 8.2. Great. Okay, it's around 8.2. 8 1/4. If you want to round it, that's fine. It's not an exact answer. I asked my students to leave them as exact answers, so square root of 68. I said if it said square root of 64, I'd say put 8. The square root of 64 is 8. But don't round otherwise, unless I asked them for some reason, and I didn't. Now, if some of you guys, I will do this for you guys each time. My students weren't doing this. I wish we were. If you've been learning how to simplify radicals, I'm not going to teach you how. I'm just going to say the answer. If you're practicing doing it, you should get 2 root 17. That's another form of the answer. That's a better answer than square root of 68, but they're both exact. All right. Now, before I move on to midpoint, let's talk more about this distance formula, because I'm going to use Pythagorean theorem in the future. And let's use this graph to kind of recognize it. Pythagorean theorem is, sorry, I'm coming up with a tool. Pythagorean theorem is a way of relating the sides in a right triangle together. If you had lengths A, B, and C in a triangle, in a right triangle, where A and B are the legs and C is the hypotenuse, then A squared plus B squared equals C squared. That's just the relationship. Thank Pythagoras for figuring that out. Uncle Pythagoras. Distance formula does this. It uses Pythagorean theorem. Check this out. This distance is diagonal. There are distances here that are horizontal and vertical. Horizontal and vertical lines are perpendicular with each other. The distance between these x values, like say it was 3 and 5. What's the distance between 3 and 5? 2. How do you get 2? You do 5 minus 3. Or 3 minus 5 is negative 2, whatever. But you subtract the x values, x2 minus x1. The distance between the y values, y1 and y2, is y2, is y sub 2 minus y sub 1, y2 minus y1. The d is the distance between. So, x2 minus x1 could be like your a. Here, let me put the a on the bottom. It doesn't matter which one is a, but I just want to kind of tie them in. The x2 minus x1 is like your a. x2 minus x1 is being squared. Where's my formula? x2 minus x1 is squared. A is squared. Plus b. B is like your y2 minus y1. That's being squared. That's being squared. B is squared. Equals c squared. Now here's that one difference. C is like your d here. D is like c, right? Now how come this says d equals square root of and this says c squared? Well, if you take the square root of both sides, the square root of c squared is c, and you get the square root of a squared plus b squared. So voila. So it looks like it, right? It's a rewrite of Pythagorean theorem. It's a rewrite of Pythagorean theorem. That's what distance formula is. So as weird looking as it is, as much as people screw up substituting things in, they shouldn't, right? Follow your math correctly, know your order of operations, let things work out. I tend to use Pythagorean theorem more often, especially when I'm given the graph. Now this problem I wasn't given the graph, so I get it. On future problems when I'm using Pythagorean theorem. So I'm not touching distance formula. You'll likely not see me touch distance formula for a lot of the problems. I mean, it is Pythagorean theorem, but you'll see me think about it in Pythagorean theorem ways. Now, the last thing I want to mention here is that whole 2 is the distance between my x values. What are my numbers? 4 and 6? What's the distance from 4 to 6? How far do you have to go? You have to go over 2. That's what that 2 is. That's the a squared. So when I do Pythagorean theorem in the future and I answer these, I'm saying how far is it from one to the other? You do subtract them to figure it out. It's going to be tougher when there are negatives involved. But I'll make do what I can. What's the distance between 0 and negative 8? Well, it's 8. I mean, I put negative 8. It doesn't matter. We're going to square the answer. Squaring that, you get positive 64, just like you would positive 8. So anyway, that's what you get from those. That's what distance formula is. That answers that one portion of it. Like I said, slow the first time, speed up as I go. Number 2, find the midpoint between 10, negative 2, and negative 2, 9. Let me actually undo the delete. Let's look now at midpoint. Not distance, but midpoint. Okay. It's probably easier to just redraw that. I want to find the midpoint of that segment here. Some x1, y1, and x2, y2. This middle value m. M is a location on a graph, which means I need an x and a y. So when you find midpoint, it's a formula of sorts. It's not really an equation, but it's an ordered pair. In order to find that midpoint, what you do, it's between two values. You average your values. My x's and my y's separately. If you average your x's, you get the middle value between them. Like you say, oh, you got a 70 on a test and a 90 on a test. What's your average? It's 80. It's the middle value between them. How do you get the average? You add them and you divide by how many there are. There are two values, x1, x2. Add them and divide by 2. The y values, add them and divide by 2. You find the midpoints of the x's, find the midpoints of your y's. It's an ordered pair. It's not a single value like distance formula. That's not the length between them. It's the location of the ordered pairs between them. That's midpoint formula. Now this one, maybe kind of still weird to like memorize. Like distance formula is kind of like a weird like memorize thing. I'm not a big memorizing guy. Distance formula is just Pythagorean theorem. Midpoint is just averaging your values. And average is adding. Notice how this does have subtraction between your values in addition. It's something that my students would screw up all the time. It's what people screw up in general. But you average them. It's what you do. If you actually had the graph, you could also kind of work that slope. You know, we kind of just did that run and that rise like that. Whatever that distance is, you could take half of it. Whatever that distance is, you could take half of it and like boom, you landed on it, or go down and over this way. It's kind of a thing you can also do with the graphs. I'm not really going to go about it that way very often. Maybe sometimes I will. The reason why I might is I know there are some quiz questions where I say find the distance and the midpoint of between these 2 points. And I can kind of kill 2 birds with 1 stone by finding that length. So I can do that. Let's do this one. Find the midpoint between 10, -2 and -2, 9. And it's a little, it's a lot of work over here. All right. 10 is my x1. -2 is my y1. -2 is my x1. 9 is my x2 and y2. We're going to do 10 plus -2 over 2 for x's. And -2 plus 9 over 2 for y's. 10 plus -2 is 10 minus 2, which is 8. -2 plus 9 is 7. 8 divided by 2 is 4. And 7 divided by 2 is 3.5. And I'm totally fine putting 3.5 on these because all these answers will either be integers or 0.5s. That's kind of how I'm going to leave it. It is an ordered pair, though. An ordered pair needs parentheses, comma, x, and x, comma, y, all that kind of stuff. So that's the answer. That's where we go with it. You know, a lot of these you can probably too. I can do in my head, like what's the middle value between 10 and -2. Maybe not as easy for that number as like what's the middle value between 3 and 5. And the 9 and -2 even harder. So I think it's worth doing these for problems like that. But that's the answer. All right, let's do the next week of skills. 16, write the explicit rule for the below sequence. So this is where I'm going to start doing a lot more speeding up. My first term is, at least for this skill, -1024. It's dividing by 2, but we're multiplying not by 2, but by 1/2. So the common ratio is 1/2. So there's your explicit rule, done with 1. You can see the speed up. Find a sub 11 in the above sequence. So for my students, I would have just said, use your previous answer to get it. Because if they got the first one wrong, they'll get the second one wrong. You know what I mean? But with the correct answer, let's substitute 11 into there. -1024 times 1/2 to the 11 minus 1. That's the 10th power. I think this answer is 1. 1/2 to the, yeah, so -1. So this answer is going to be -1. And you can compute it, but that's what it should be. All right, Last of Us. Here we go, going back. The HBO series The Last of Us has seen a steady increase in viewership ratings since its premiere. The model y equals 4.1 times 1.16. The t-power is used to predict the number of millions of viewers the show will have on episode T. So there's the model for it. It's given. How many millions of viewers are expected to watch the 9th episode, its finale? Round your answer to 1 decimal place. For example, that. Okay, first of all, I extrapolated this incorrectly for a lot of reasons. So the answer you see here is not going to be close to what the actual value was, I'm sure, for a lot of reasons. Exponential curves aren't always best. You know, we're talking about skill 18 where you graph these things, and that's what these models do. All these graphs do this kind of thing. And you know what they do? They keep taking off like that more and more. Never fully vertical, but they do that. You know what real life does? Real life probably has a takeoff point and also has a converging point like that. These kinds of graphs, even with asymptotes like that, these are known as logistic functions. And that's probably what The Last of Us likely did. You get a boom in viewership. You only get so many people that have HBO Max, what's now called Max. You only have so many people that can spread word of mouth and so many people that watch the show, you know, like the show and things like that. And eventually you kind of run out of people, or they run out of interest, or, you know, whatever it is. Also, the finale, sorry about this. Also, the finale came on the same day as, was it the Super Bowl? Or the Oscars? I think the Oscars. So, you know, you're going to lose some people. I think an episode was supposed to air the same day as the Super Bowl, so they aired it on Friday instead and put it up on HBO Max same day as the Super Bowl. So things like that. Anyway, let's go on to the problem. 9th episode. We substitute 9 into here. So the question is, can they do the rounding and write this correctly? And I gave them a lot of hints for this. So 4.1 times 1.16 to the 9th power. Sorry, you can't see this. Let me show you what I'm looking at. 15.59. So I said round to one decimal place. So I'm going to round it to 15.6. Now the example that I gave said 13.6 million viewers. So I'm going to write 15.6 million viewers. I mean, I gave them every bit of recipe that they needed for this answer. That's all they needed. Now you guys can look up what the let me look that up really fast. I'm actually intrigued by this. The Last of Us season finale ratings. 8.2 million viewers. It's about half of it. So, clearly it was, it didn't quite work that way. Anyway, so I was trying to extrapolate. It didn't work. All right. A runner plans to improve her mile time by 0.5% every week during the school year, meaning her time will decrease. When you improve a time, the time's going to go down, right? At least for running a mile. So I gave that. If her mile time at the beginning of the school year was 430 seconds, what will her mile time be after 36 weeks end of the school year? So we're going to plug in 36 to this if we work this stuff out. The equation, y equals, 430 seconds. We're going to do 1 minus, this isn't 0.5, it's not even 0.05, it's 0.005. 1% is 0.01, so this is 0.5%. It's less than 1 that's happening here. So that's kind of the model. This is 430 times 0.995 to the t power. Now so there's the model. You might not think that improving by 0.5% every week is a thing, but keep in mind, you are improving every week. You're doing it for 36 weeks. You try and do that. We're going to see what her mile time goes to. 430 seconds is 7 minutes, 10 seconds. So what does she get to at the end of the school year? Let's see how good this is. Let's do 430 times 0.995 to the 36th power. 430 times 0.995 to the 36th power. 359.004. So I'll just do 359 seconds. All right, what is that? It's a 5-minute, 59-second mile. She broke 6 minutes. She was at 7:10 to begin with. She's at 5:59. That's good. I mean, this is also one of those things where this won't go correctly over time like this. That's why these models tend to have different kinds of shifts and things like that, or the logistic kind of thing that I mentioned. Maybe she has a burst where she gets really strong and starts to gas out and things like that. But eventually that's got to stop. So the 0.5%. I don't know. That'd be cool to do, though. That'd be cool to track it like that. Like, hey, this time I want to get another second faster or whatever. It doesn't quite work as easily as that once you start to get too fast. All right, skill 18. Let's graph. Can we do this fast? We'll find out. I got to kind of shrink it this time, though, if you don't mind. This room's going to get cluttered, and we'll see what we have to do at some point. All right, -1 times 4 to the x power. So -1's the y-intercept. Let's multiply that by 4 as we increase x by 1. Times 4 again would be -16. Now, I can't actually fit it, but I'm going to kind of plot it down there just to get the idea of where I need to go with my curve so I don't go vertical and I don't pass this point. I want to make us think about that in a second. -1 divided by 4 is -1/4, and I'm just going to go ahead and only graph those. So let's try and kind of graph this. This is a lot harder than to do on a paper, I can assure you. Okay. Now, I don't even mind cutting it off right here, ultimately. I just wanted to kind of get that to talk about one thing. And this is something I do with my students, too. Remember, this graph cannot go vertical because it still goes on. It can also not cross this prematurely. And here's what I mean. What if the graph did this? Excuse me. What if I drew my curve like this? Well, I would mark it wrong. How come? Because I'd say this to my students. I'd say, hey, you crossed x equals 2. They go, yeah. What y value did you cross? I don't know. Did you, can you find a y value? Can you find out what the y value is when x equals 2? Yeah, it's 16. I'm just making up a student. It's 16. All right, well, then you shouldn't have crossed it at, 7.5, negative 7.5. Like, you know what I mean? If you're going to cross a value, then plot its point. If a point doesn't exist there, then don't cross the value there. That's my big thing. Now, I did want them to draw asymptotes on theirs, but it's always on the x-axis. So when it's not on the x-axis in the future, I guess they'll have to know to do that. And the paper tended to be pretty thick, and they had pencils. So if they didn't draw it, that's fine. They just can't cross it. They can't cross the asymptote. All right, 2 times 1/2 to the x power. Let's do that one. So blue and green. All right, 2 is the y-intercept. Times 1/2 is 1. Times 1/2 is a half. Times 1/2 is a quarter. Great. Let's go to the left. Let's get these points. 2 divided by 1/2 is 2 times 2, which is 4. 4 times 2 is 8. 8 times 2 is 16. You get where that's going. So there's the graph. You can see I'm doing that without a table. You can see where I'm doing that without a table. I'll only go back to a table again if I feel it's a must with the numbers that we have. Negative exponential decay, negative exponential growth, positive exponential decay. All right, skill 19. Solve 2 times 4 to the x power minus 12 equals 500. Do the same thing as you would if it said 4x to begin with. Isolate the term. Add 12 to both sides. 2 times 4 to the x power is 512. Divide both sides by 2. No, we cannot multiply those. Divide both sides by 2. 4 to the x power equals 256. And 256 happens to be 4 to the, I think, the 4th power. So x is 4. That's number 1. Number 2, 3 to the 3x power equals 9. Well, 9 is 3 squared. I have matched bases. Set the exponents equal. 3x equals 2. Divide both sides by 3. X equals 2/3. Don't round it. Don't stop and say no solution and things like that. It's 2/3. All right, skill 20 is right here. Find the distance between the 2 points below. This is where Pythagorean theorem would be best. Instead of trying to figure out what the points are and do all that stuff, kind of use that right triangle. I mean, actually work it out and say, you can even count these distances. That's why I kind of like to do this. 1, 2, 3, 4, 5. That distance is 5. 1, 2, 3, 4, 5. Okay. And this is your D or your C, if we say more Pythagorean theorem. It's A squared plus B squared equals C squared. Those are the distances. I'm not going to really speak more on that. That's what we're doing. 25 plus 25 and C squared equals 50. Now the answer is not 50. I have to solve for C or X or D or whatever you put for them. You have to take the square root of both sides. So C equals the square root of 50. That's an exact answer. Not my favorite one, but it is an exact answer. Approximated. The square root of 49 is 7. So this is just, it's like 7.1-ish. It's irrational, so I'm not going to say what that is, but 7.1-ish. If you simplify your radical, if your group's doing that, that is 5 root 2. That's the best answer. Square root of 50. My students are root of 50. I hope next year my students are simplifying radicals. If so, they can watch this video. And they'll go, hey, I got 5 root 2. My students, my 2023 kiddos, where I make this video, which will probably be obsolete when we start doing other things. We're getting a new textbook. Find the midpoint between 1, 0, and 1, negative 16. Let's see if we can do this in our heads first. What's the middle value of 1 and 1? Don't overthink it. It's 1. All right, the x value is 1. What's the middle? What's halfway between 0 and negative 16? Let's say, what's halfway between 0 and 16? 8. What's halfway between 0 and negative 16? Negative 8. So that's the answer. So you can see how that works out. Let's go ahead and do the averaging. Let's see how that works. I won't do the averaging every time. A problem like this in the future, I ain't gonna. This is showing that it works out the way we want it to. 1 plus 1 is 2. 2 over 2 is 1. 0 plus negative 16 is negative 16. Negative 16 over 2 is negative 8. And that's the answer, x comma y. Okay, skill number 21. Here's the new one. Let me move myself back. An hour and a half in. Having done half the skills, which means I've done close to half the problems. Find the length of segment PR. That's actually what that means, if we're going in geometric terms, in the figure to the right. So PR is this entire thing. It's represented with 10x minus 11. That means we have to solve for x first, and then do this. The segment addition postulate is a way of stating that when you have collinear points represented by segments, the lengths of their segments can be added to represent the length of the entire thing. I can take the length of segment PQ and the length of segment QR and add them, and I get the length of segment PR. PQ is expressed as 2x minus 3, so I can add 2x minus 3 with QR's expression of 5x plus 7, and I will get 10x minus 11. I can solve for x. 7x plus 4 equals 10x minus 11. And I know I'm going to run out of room. I'm going to have cramped room on a lot of these problems in the future, so I apologize for that. I'm going to have to just work my way around. 3x equals 15, and x equals 5. Okay, I'm not done. I need to find the length of PR. PR is represented by 10x minus 11, or 7x plus 4, right? Because we added those in. But I'm going to use the original PR, just to, no mistakes. 10 times 5 minus 11, 50 minus 11 is 39. The length of segment PR is 39. If I did do 7 times 5, 35, plus 4, I still get 39. It should work out. B is the midpoint of segment AC. Now, that's not drawn. We can draw it. Here's AC. I say when in doubt, draw it out, right? It's going to be very helpful, especially when they give you information. Now, B is the midpoint. Midpoint means not only does it divide this into half, but it divides into two congruent parts. So this guy is equal to this guy. So we got to work off the information you're given now. Length of segment AB is 6x plus 12. The length of segment BC is 48. Solve for x. These two segments are equal to each other. The little tick mark that I put is an indicator of congruence. Congruence, segment AB congruent to segment BC, that's the symbol for congruence. You're going to see this a lot later when we start talking about triangle proofs, is saying that these two are equal in size and shape. That's congruent to that. They're equal in size and shape. So segment AB equals segment BC. That is to say 6x plus 12 equals 48. And we solve for x. Now, I'm not going to spend a long time doing this algebra. X equals 6. The algebra was semester 1. You saw me at the end of the quiz. If you saw my quiz video thing, I started just zooming through those parts after. That part, I'm letting you, like even right here. I'm going to go through that part fast. I'm teaching the geometry aspect, whatever it is, because all the rest is pretty much geometry, right? There's algebra within, but setting something up geometrically, and then we move on from there. And that is skill 21. You're going to see it, obviously, in the next ones. Let's keep going. All right, from here on out, the skill 18 graphs, I think, are mostly up here because they're part of the first page of problems that we see and, things like that. So I'll go back up to these to draw those graphs, if that's cool. Let me just write their equations. Y equals 2 to the x. And then y equals negative 1/2 times 12 to the x. Okay, let's start with skill 16. Write the explicit rule for this guy, negative 0.38, negative 1.14, negative 3.42. I don't know. My students did this. I don't know if they tried numbers until they worked. It's not going to be hard. But you don't have to use trial and error. Remember, you can divide one value by the one before it, like negative 1.14 over negative 0.38. Should be the same thing as dividing that by that as well. You're going to get 3. You can try it. You're going to get 3. It's a positive 3. You have to write the explicit rule. So that's common ratio. And here is your a sub 1. So what's the rule? A sub n is negative 0.38 times 3 to the n minus 1 power. That's the rule. Find the 12th term in 3, 6, 12, etc. It's a geometric sequence. You can tell once you get to that, we are multiplying by 2 each time. So the value of the nth term is 3 times 2 to the n minus 1 power. That is the explicit rule. The 12th term, a sub 12, is 3 times 2 to the 11th power. I should know that on top of my head. 7,144. Let's see if I got that right. 3 times 2 to the 11th power. 6144. Oh, I don't know what I did. I carried over O. I was thinking 2,408. Shut up. I was wrong. Okay. A mountain in Jackson County is eroding and losing elevation at a rate of 5% every millennium. 1,000 years. Which doesn't matter for the problem. You'll see that we're talking about millennia the whole time. If the current elevation is 1,300 meters, how tall will the mountain be in 8 millennia? As for 0 decimals, I start to improve my quizzes later where I start to do things like this. Not all the time. Sometimes I'm forgetful. But sometimes you'll see things like this. All right. So the model, we're doing 1,300. I'm going to just kind of not do models unless they ask me to. Losing elevation at a rate of 5%. R is 0.05. And we're going to subtract 0.05 from 1. We'll get 0.95. You're getting 95% of what you previously had. 8 millennia later, we are actually substituting 8. We're not plugging in 8,000 because it loses 5% every millennium. So that's what we plug in. So 0 decimal places, let's approximately get that. That's 1300 times 0.95 to the 8th power. 862. It says 0 decimals. So we're going to round to 862 meters. Mountain's eroding. It's getting smaller. Better go sightseeing in the next couple 100 years. In 1995, there were 275 cell phone subscribers in Aiken. The number of subscribers increased by 75% per year after 1995. How many were there in 2004? Okay, 275 initial. 75% increase, 1 plus 0.75 is 1.75. We're going from 1995 to 2004. That is 9 years later. So let's go and check that out. 275, not 175. 275 times 1.75 raised to the 9th power. 0 decimals asked for because you're people. 42332.6. I'll just go and round it up. If, I accept either answer from my students. That's kind of the idea I was saying before. That many subscribers in good old Aiken. I bet there aren't that many people in Aiken. That's okay. All right. So, word gets out. People need cell phones. All right, graph. I wrote the equations up here. So, 2 to the x power. Now, here's one we got to be careful with it because the form is y equals a times b to the x power. A is the y-intercept, b is the growth factor, or decay factor. Is 2 the a or the b or both? How does that work? 2 is what's being raised to the x power. 2 is the b. All right, so what's the a? The a is 1. How do I get 2 to the x? You multiply it by 1. 1 is your y-intercept. So that's what I'm doing. 1's the y-intercept. Times 2 is 2. As x increases, times 2 is 4, and times 2 is 8. So that's what you do. You got to figure that out. Divide by 2 is 1/2. Take half of that, you get a quarter, and it looks like that. So determine what your a and b are, and then you draw the graph. So I'm not going to draw the asymptote there. You can see this is what my students had to work with. That's why like a thick line. I just said I'm not going to, and I did. But a thick line's hard to do in pencil and hard to see, so they don't do it. It's fine. Negative 1/2 times 12 to the x power. Now this one, negative 1/2 is the a value. This isn't your growth decay factor. Negative 1/2 is the y-intercept. We're actually starting at a decimal fraction. Negative 1/2. Now we're going to multiply it by 12. Negative 1/2 as x increases by 1. Negative 1/2 times 12 is negative 6. So when x is 1, we get negative 6. When x is 2, you get negative 72. Forget about it. Negative 1/2 divided by 12 is negative 1 over 24. Honestly, forget about it. This thing is sharp. It starts at a fraction, but that is a sharp increase. And remember what I said about the, if you listened, we shouldn't cross at x equals 2 yet. Remember, that's got to hit negative 72 before we cross x equals 2. So, and don't go vertical. It's going to go pretty sharp. There's the graph. All right, skill 19. 4 to the x equals 1/4. Now this one gets a little tough as far as matching base, but we've seen some of the fraction bits with exponents. Fractions come from negative exponents. If I'm going to match a base, can I raise 4 to a power to get 1/4? Yeah. It's 4 to the negative first power. Remember, 4 is 4 to the first power. 4 to the negative first power is 1 over 4 to the positive first power. That's what it is. X is -1. Kind of a test for them to see if they remembered that over the few weeks since they first learned skill 19. Solve 81 to the 4x minus 2 equals 9 to the 2x plus 8 power. 81 is 9 squared. So I'm going to rewrite that as 9 squared. So this to the 4x minus 2. 9 to the 2x plus 8. This is where we multiply 2 with 4x minus 2. You have to remember, though, that's a distribution. 2 times that, 2 times that. So when it comes, because my base isn't quite matched yet, when I distribute the 2, 2 times 4x is 8x. 2 times negative 2 is -4. And now my bases match. So now I can set the exponents equal to each other. So I'm going to have 8x minus 4 equals 2x plus 8. And by the way, mathematically, like these, magically, I'm making them go away. Mathematically, I'm not dividing by 9. I'm doing something using logarithms, something you won't learn until integrated math 3. So don't try and make something happen that's not there. We are doing something based on a property that makes sense. The bases are the same. I can set the exponents equal. Just go with that for now. Subtract 2x from both sides, add 4 to both sides. What is that, 12? Divide both sides by 6, you get x equals 2. All right, there's no skill 20. Great. Oh, there it is. All right, skill 20. Find the distance between 3, -7, and -1, -10. Here's where I'm going to try and make use of Pythagorean theorem with the points by trying to ask out loud something and see if it'll make sense to you. I don't have much room, but let's see. What's the distance between 3 and -1? Not the distance between 3 and +1. The distance between 3 and 1 is 2. The distance between 3 and -1, 3 is 3 away from 0, -1 is 1 away from 0. That's 4. They're 4 away. I don't care if I write positive or -4. Remember, I will square those values. What's the distance between -7 and -10? It's the same as the distance between 7 and 10. It's 3. That's 3. Those distances are what we're squaring. 4 squared plus 3 squared equals c squared, right? That's the idea. That's where distance formula would be used. I'm using Pythagorean theorem as a form of that, though. 4 squared is 16, 3 squared is 9. C squared equals 25. You take the square root of both sides. 25 is a perfect square. That is 5. The distance is 5. I don't really need the c, but the distance is 5. Exactly. The midpoint of a segment is 7, 9, and one endpoint is 5, 8. Find the other endpoint. Ooh, okay. So we're not averaging this value and that value. This is the midpoint. This is M. Remember, midpoint formula is you average 2 x's to get the 2 x values to get this number. You average 2 y values to get this number. So that midpoint formula, it's like I said, it's not an equation. It's a formula, but it's not an equation. You can make 2 separate equations out of these, though. This is the x midpoint and the y midpoint. This is some x1 or y1, whatever. We need the x2 and y2. The other x's for the other endpoint. Let's start with x's. 7 is the average of 5 and some other x value. And then y's, 9 is the average of 8 and some other y value. Remember, averages, you add them, divide by 2. These are part of the midpoint formula. We have midpoint. We're trying to find the other ones. These things do the same thing as far as solving. You multiply both sides by 2, and then you kind of move that thing over, because 2 over 2 is 1. 7 times 2 is 14. Subtract 5 from both sides, you get 9. And then multiply both sides by 2 here, you get 18. Subtract 8, you get 10. So it's still not the answer. I need the ordered pair. This other endpoint is 9, 10. I'm going to go ahead and box that one. Boom, 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 boom. Now, I don't have the graph version of this. I'm so short on room. I obviously want to move on. But let's think of this practically. From 5, I go to some other endpoint, and in the middle is 7. What's the distance from 5 to 7? Well, that's 2. Let's go another 2 from there. Well, that's 9. Right? That's where it goes. 7 is the midpoint of 5 and what number? That's what's being asked. 7 is the midpoint of 5 and 9. 8 is the midpoint of, 9 is the midpoint of 8 and 10. 8, 9, 10. Right? And that's what those numbers are. So there are a lot of logic ways to do this. I don't beg my students to use formulas. God, no. Use logic. Use whatever you do to get it right. Make sure you write it correctly as well. All right. Very small on room. I got to figure out how to do this with you guys on these because I really need the space. Points E, F, and G are collinear with E and G as the endpoints. So you really want to draw this, right? You want to get this like idea. It never said F is the midpoint. It just says they're collinear though. E, F, and G. So I don't know what it looks like. EF is 3x, FG is x plus 5, and EG is 9. So I like to do that for that. Solve for x. So you want to draw it out. You want to know what plus what is what, right? 3x plus x plus 5 equals 9. 3x plus x is 4x, not 3x. A lot of my students do that. 3x plus x is 3x. 4x plus 5 is 9. Excuse me. I went ahead of myself. 4x equals 4 and x equals 1. Okay, hopefully that's okay that I fit it that small. I'm just doing what I can. V is the midpoint of segment UW. What is the length of segment UV? That's what that's asking. Now, V is the midpoint. That does mean that these two parts are congruent to each other here and here. So there are a couple ways you can do this problem. You notice what they express is the length of UV is x plus 2. And we don't have a length for VW. They do give us a length for all of UW. So what do I set x plus 2 equal to 3x plus 1? No. X plus 2 is half of this whole. No, half is not equal to the whole. So there are a couple ways you can think about this. I really want to think about going bigger though. This is half of this whole, right? So I could double this. I could do 2 times that, and that would equal it. I could divide this by 2. I don't think I want to divide the odd numbers by 2, though, so I'm not going to do that. What you could also do is these are equal. So even though I don't have a length for this, I could express it as x plus 2. X plus 2 plus x plus 2, or doubling x plus 2. So you're going to see a lot of problems that do that over time. This is one of them. So if I distribute the 2, I get 2x plus 4. Subtract 2x, subtract 1, I get x equals 3. Now they need the length of UV. UV, segment UV, has the length of x plus 2. 3 plus 2 is 5. That's the final answer. Now there are a lot of times I really, again, so for my students to get a 2, they need to get everything exactly right for both problems. For the number of students that would get x equals 3 with x equals 1, they feel accomplished. They forgot they had to answer the question. What is the length of UV? So they can't get a 2 until then. It's the nature of the beast. It's a problem. Find the measure of angle GHK given the diagram to the right. So I need to find the measure of GHK here. It's represented with 4x, which means I need to solve for x. So what you notice here is this is the new skill, but this is a lot like the last skill. Skill 21 was segment addition postulate with midpoints and segment bisectors whenever they show up. Skill 22 is angle addition postulate with angle bisectors. So you're going to see the same kind of thing. These angles are what are called adjacent to each other. They're right next to each other. They share a common vertex, this point right here, this H. They share a common side, this ray HK. You can add up the measure of this angle with the measure of this angle, and it'll equal the measure of the entire thing. That's what we're going to do. Just like the collinear segments and segment addition postulate. This plus this equals whole thing. Angle addition postulate, this plus this equals whole thing. As long as they're adjacent, works out. Now this says the measure of angle GHK. GHK. Notice that navigation there? They're referring to this angle here, that 4x. I forgot this was a new skill for us. Sorry about that. So that's what we're going to find. So here we go. 4x plus 12x equals 112. You see that? 4x plus 12x equals 112. That's our setup. 16x equals 112. Divide by 16. I hope that's 7. X equals 7. we got to find the measure of angle GHK. Now the measure of angle GHK is 4 times that, 7, which is 28. The important part here is, we need degrees. The segments that we've done in skill 21, and I don't think there's a time that I ever give units. In a context-less environment, the units are just simply length units. I don't know what they are. Angles, very specifically, are in degrees. There's radian measures that exist, but we're not in radians, we're in degrees. So whenever they ask for the measure of an angle, we are going to put degrees, and you have to. That is the measurement that's used. That is different than just saying 28. 28 what? It is degrees. All right, number 2. No drawing, but it says ray BD is a bisector of angle ABC. So imagine you had some angle ABC. Now here's what that means. A and C are points on the rays that make the angle, and B is the vertex of it. Now they stated ray BD, that means from B out to D, say like that. BD is a bisector of the angle. Just like midpoints are halfway between your 2 points and make them congruent parts, angle bisectors cut this angle in half into 2 congruent parts. This angle is congruent to this angle. They are the same measure. Solve for x. If measure of angle ABD is 3x plus 5, and measure of angle DBC is 15x minus 1. These are the same. Same. We set them equal. 3x plus 5 equals 15x minus 1. And then we solve. Subtract 3x from both sides. Add 1 to both sides. Divide both sides not by 6, but by 12. And you get 6 over 12, which reduces to 1/2. I will accept 1/2 or 0.5. Those are exact. Not 6 over 12. That's not reduced. And obviously you divide by 12, not 6. So 6 divided by 12 is not 2. 1/2. There it is. All right, we go to week 9. Scale 18 is up top. We'll get to that when we get it. All right, write the first 4 terms for a sub n equals 4 times negative 4 to the n minus 1 power. I'm going to go fast. First term is 4. Then you multiply by negative 4 for the next 4. Times negative 4 is negative 16. Times negative 4 is positive 64. Times negative 4 is negative 256. And there are times where my students don't use the first, like the negative 4 is the first term. The 4, I should say, as the first term. They skip it and say that's the first term, I guess, or whatever. Or they do the next 4 terms after that. No, I want 4 is the first term. I want you to write it. Write the explicit rule for the sequence 8, 12, 18, 12, 8, etc. This was a little trickier. Even some people won't even know what to divide by. Now I'll tell you, you're dividing by 1.5, but that's not very helpful here. It's what you're multiplying by. Multiplying by some r, right? Let's remind you how this works. It's the same thing for both. Let's do it with 12. 12 times some r is 8. What is r? You divide both sides by 12. Apparently r is 8/12. Don't go to the calculator. Reduce the fraction. You can divide these by 2. You can divide them by 4. R is 2/3. 2/3 is what you're multiplying by from one value to the next. As a decimal, that's 0.6 repeating. I'm not using that. It's also dividing by 1.5. It's not what we're dividing by that matters. It's what we're multiplying by what matters. So your rule, a sub n equals a sub 1 times r to the n minus 1 power. You can see the trickiness in the problem. There it is. All right, skill 17. Every year, the cost of solar panels drops by roughly 6%. Decrease. If solar panels currently cost $5,918 per kilowatt, write an equation modeling the per kilowatt cost in T years. So we're not solving. We're just coming up with a model. Remember, model, simplify the inside part. So $5,918 currently, that's our times 0. We're going to subtract 6% from 100%. So 1 minus 0.06, that's 0.94 to the t power. That's 1 minus 0.06. Right there. There's the model. Done. If they asked for 10 years, we plug in 10. They didn't ask, so we're not doing it. In 1982, there were only 5 Starbucks shops in existence. It has exponentially grown by 24.1% yearly, I bet. Determine the number of Starbucks shops in the year 2023. Okay. 5. Initial. Growing 24.1%. Move it 2 decimal places over. That's 0.241. We're going to do 1 plus 0.241, which is 1.241. The year 2023 is how many years after 1982? 41? 41 years later, how many Starbucks shops are there? I'm going to Google this after as well. Remember, I do the problems by doing research. I forget if this research is as accurate as I wanted it to be. 5 times 1.241. And by the way, remember, I gave this a few months ago. Who knows how many Starbucks shops were made since then? I also need to make sure that it's not going to be exact because I need to make sure the number, 24.1%, it's probably more like 24.076, like that. Anyway, this is 0 decimals, right? This should be in terms of shops. 34963. I'm looking at my calculator. Starbucks shops in the year 2023. Hello, Google. How many Starbucks shops are there in the... Oops, I just typed US in the world. It says today with nearly 35,000 stores worldwide. 35,711 in 2022. So, yeah. Right. So anyway, sure. All right. Skill 18. 9 times 1/3 to the x power. Let's do that up here. Y equals 9 times 1/3 to the x power. 9 is the y-intercept. We're going to multiply by 1/3 as x increases by 1. That means dividing by 3. 9 times 1/3 is 3. 3 times 1/3 is 1. 1 times 1/3 is 1/3. 1/3 times 1/3 is 1/9. 9 divided by 1/3 is 9 times 3, which is 27, which cannot fit on here. And that is your graph. You can see the speed at which I'll be going with those when I'm able to. I got to sneeze. I feel like I got to sneeze, so apologize if I do. Maybe I beat it. Y equals -2 times 4 to the x power. -2 is the y-intercept. As x increases, we multiply by 4. -2 times 4 is -8. Remember, it's like sequences. Write the next 4 terms. Times -4, times -4, times 4, times 4. You just got to go over. Now we're going to go to the left and divide by 4. -2 divided by 4 is -1/2. And then -1/8. Because it's times a quarter, right? Dividing by 4 is also times a quarter. Approach the asymptote. And go. All right. There they are. Skill 19. Let's see what room I can use. Let's isolate 3 to the x plus 2 power by subtracting 5 over. We'll get 81. Okay. 81 is 3 to the 4th power. X plus 2 equals 4. Set the exponents equal. Subtract 2, you get x equals 2. -2 times 6 to the 6x power equals -72. Remember, isolate the exponential term first. Just like we subtracted this 5 over, we also got to divide this -2 over. So 6 to the 6x equals, that's positive 36. And 36 is 6 squared. So 6 to the 6x equals 6 squared. Bases equal to each other. Set the exponents equal to each other. 6x equals 2. Divide by 6. X equals 2 over 6. That reduces to 1 over 3. X equals 1/3. Okay. Skill 20. Find the distance between 3, -7 and -1, -10. That's the same question as last time. So, 3, -7, -1, -10. Hey, the answer is 5. I'm telling you right now, the answer is 5. I think 5. I think this was an accident. When I was changing other values, I forgot to change it. But I'm testing my students to see if they're listening from last time. It's the same problem. What if I gave my students the same quiz questions every time? Would they get them right the next time? That's always a good question too, right? How many got it right? Some still got it wrong. Some forget to take the square root. Some leave the square. You know, when I say square root of 25, it's not enough. I do need to simplify to 5 because it's a perfect square. So that might be what they did. The midpoint problem is different. Find the midpoint of -3, 0, and 8, 2. Okay, I'm going to do a hybrid on this one. I think we know the midpoint between 0 and 2 is 1. I think we can do that one. -13 to 8, even I would prefer to average those. I don't know that half distance so fast. I know it's a decimal. So, -13 plus 8 over 2. -13 plus 8 is -5. And -5 over 2 is -2.5, -2.5. Now, don't get me wrong. -5 over 2 is a perfect answer. For all the times that you hear me talk about improper fractions are the way of the future, if you ever hear me talk about these things, improper fractions are the way of the future, man. They're the way to talk about them. For graph's sake, I kind of like seeing the decimals sometimes more because it's something that I'd actually plot on a graph. And I'm just saying I'm accepting of this answer. It's kind of why I put it in. I allow it. -5 halves. That is perfect. Leave it like that as much as you want. Totally. All right, skill 21. Find the length of UW given the diagram below. Let's solve for x first. I guess I'm dropping a hint for them so they don't just say, oh, UW is 9x minus 20. Okay, so this plus this equals whole thing. So x minus 1, let's do this above. I think I have some room there. X minus 1 plus 5 equals 9x minus 20. -1 plus 5 is 4. I'm going to subtract x and add 20 and divide by 8. We get x equals 3. The length of UW is 9 times 3 minus 20, which is 27 minus 20, which is 7. You could plug in 3 into here as well. 3 minus 1 is 2, and 2 plus 5 is 7. It should work. I mean, it's not like you could do it this way. You can double check your answer and see if it works that way. All right, Q is the midpoint of segment PR. Once again, not drawn. Might help to draw it. Q is the midpoint of PR. So there's PR, Q is in the middle, like that. PQ is 2x. QR is x plus 1. Solve for x. Midpoint sets these equal. 2x plus 1, 2x equals x plus 1. Subtract x from both sides, x equals 1. I mean, that's a much easier problem than the one before it that we had to do. The half and the whole, and I think we had to maybe plug something in afterward and all that. I don't know. But, yeah, can you do it, right? So make the drawing. All right. Drawing isn't on number 1 here. Angle ABC is a straight angle containing segment BD. Now, we haven't gone over that together, so let's go and do that. A straight angle looks like it sounds straight. Now, there's something you have to know about that. So, angle ABC, you know, a 90-degree angle is a right angle, and then another 90 degrees, I can't bend my arm that way, another 90 degrees is 180. So, a straight angle has a 180-degree angle measure. That's the whole thing. 180 is the whole thing. It contains some segment BD. Boom, like that. I don't know how it's drawn, but it's like that. The whole thing's 180. The measure of angle ABD is 8x, and the measure of angle DBC is 60 degrees. Clearly, I drew it the wrong way, but that's okay. Solve for x. So when you add 8x with 60, because these are parts of the whole, you get all of the 180. And that's that part you have to do, right? There's kind of a lot of setup with that. Subtract 60 and divide by x, and you get, I think it's 15. All right, solve for x. Next one's drawn. This is not a part of what that other question was. Now, that's ironic because you're going to be doing a lot of things later where the thing is drawn for both problems, and you have to use it for both. That's in the future. All right. Ray, I hope it's in the near future. Ray AB bisects angle CAD here in the figure to the right. Now, you might want to mark that up for yourself and go like, all right, let's do that. Find the measure of angle CAD. Solve for x first. So, here's the thing. Because you can solve for this measure without doing that. If this bisects, if this is 33, then this is 33 as well. 33 plus 33 is 66. Boom, you're done. My goal is you can use that double checking measure to see did you do the equation right to begin with. All right. But they are equal. 33 equals 4x plus 1. Subtract 1. Divide by 4, you get x equals 8. So I did ask solve for x first, which means give me the x. Right? Give me the x. And I think on this last one, no, I think it was on the last page, solve for x first. Yeah, actually solve for x. Like, come up with it. So x equals 8 is what I wanted. Measure of angle CAD. Now, how do you do this? You do 33 plus, I mean, look, the other thing's 33, but 4 times 8 plus 1. 32 plus 1 is 33, and you get 66. This is degrees, though. It's kind of a lot to do. Okay, skill 23. Now, this is with parallel and perpendicular lines. There are two kinds of questions I tend to ask. Are a set of lines parallel or perpendicular, and then write the equation of a line parallel or perpendicular to some other line passing through this point, blah, blah, blah. So the first one, given these points A, B, C, and D, are lines A, B, and C, D parallel, perpendicular, or neither? No credit will be earned on a blind guess, as you must present the slopes you obtained for each line. Basically, they can't just say, oh, it's parallel, and then maybe be right? They have to show me what makes it parallel. So let's first talk about slopes. The equation for a slope, this is a last semester thing. y2 minus y1 over x2 minus x1. Change in y over change in x. Rise over run. However you want to put it. Right? You divide those. Find the difference. Kind of the same thing as you, like Pythagorean theorem, find the distance between the two. Only it's just that fraction. We want to find the slope of line AB. So I'm going to go kind of fast on the slope configuring things. x1, y1, x2, y2. Right? 12 minus 7 over 6 minus 10. Now, it is important on the signs here. I want to write this as often as I can because I want to make sure I have the right sign. Whether it's positive or negative will make a massive difference in your answer. 12 minus 7 is 5. 6 minus 10 is negative 4. This slope is negative 5/4. Doesn't answer the question in whole, but it got me the slope of line AB. The slope of line CD is 4 minus 8 over 2 minus 7. 4 minus 8 is negative 4. 2 minus 7 is negative 5. Negative 4 over negative 5 is positive 4 over 5. And there's its slope. Now, are these slopes parallel, perpendicular, or neither? Parallel lines have what is known as a same slope. Parallel lines are two lines that never intersect, right? So they rise and run the exact same amount with each other, same slope. These are not the same slope. If one was negative 5/4, the other would have to be negative 5/4. Or if one was 4/5, the other would have to be 4/5. These are not the same slope. These are not parallel. Perpendicular lines, lines that intersect at 90-degree angles, they actually have what's known as an opposite reciprocal slope. Opposite reciprocal. I should really spell it out. Someday I will. In some slide I probably will. Opposite meaning alternating signs, one positive, one negative. Reciprocal meaning flipping your fraction. You really want fractions for slopes in general, and you really want improper fractions for these. I don't want to write negative 1 1/4. Negative 5/4 is perfect. These are opposite reciprocal slopes. Negative 5/4. Positive 4/5. 4/5 flips to 5/4. Positive turns to negative, whatever. These are opposite reciprocal slopes. These are perpendicular. And that's why they are. Calculating the slope kind of guarantees that we see that. That is the answer to number 1. Neither would be a case where they're neither parallel nor perpendicular, neither same slope nor opposite reciprocal slopes. You could have 5/4 and negative 5/4 and positive 5/4. It's cool. They look the same. They're not parallel. They're not perpendicular. They're neither. They just intersect. So just be careful. All right, write an equation for the line in slope-intercept form parallel to y equals 1/2 x minus 4 and containing negative 8, negative 5. So I'm not going to spend a long time teaching these ones. I'm just going to mention the parallel aspect of it as much as I need to. If you want to see more problems along the lines of these, no pun intended, you would look to the previous video. I really got to link the previous video stuff, but you want to find skill number 9. I think skills 9 and 11 are where I do those back when. You're going to see questions somewhat like this. More so 9, Write the equation in slope-intercept form. I'll tell you slope-intercept form. It's y equals mx plus b. The point is I don't want to get too deep in the teaching of what happens with these. At the time, I would say write the equation of a line with this slope and going through this point, like containing this point like that. Well, you already had the slope at the time. Our goal is to use this to find the slope and use the word parallel to do it, or perpendicular, or whatever. There were other kinds of ways that I'd ask different questions, but because I've done those before, that's not what I'm going to spend a lot of time on. I'll do the problem, but I'm just going from there. This is y equals mx plus b form right here. The m is 1/2, and that's what I care about. I don't care about b in the way that I need to. The slope is 1/2. Parallel lines have the same slope. So I'm going to use this slope. The reason I'm not going to spend a long time on this problem, and where I said that this acts like those other questions, let me kind of fix this thing, is this would be the equivalent to a skill number 9 question asking, write the equation of a line with a slope of 1/2 passing through the point -8, -5. Now we're at that stage. We're there. So now we just got to use that. So what we're going to do, basically, our equation looks like y equals 1/2 x plus b. We need the b. We need the b. We have an xy right here. This is a solution to this equation. Let's substitute those in. -5 for y, -8 for x, and let's solve for b, and then we'll write an equation in that format. 1/2 of -8 is -4. You add 4 to both sides, and you get b equals -1. So this equation to this line is y equals 1/2 x minus 1. That is parallel to 1/2 x minus 4, and it goes through that point. Now, the reason I said the y-intercept really doesn't matter is because because it doesn't. The only reason that it might matter, and this is only if I made a bad problem, is if my answer was y equals -1/2 x minus 4. Excuse me, 1/2 x minus 4. And then I had the exact same line. Guess what? Parallel lines have the same slope, but they're not the same line. If you have one line on top of the other, then they intersect everywhere. They're not parallel, technically. So if I gave you that means that's a bad answer because that's not parallel to it. So that's the only reason that you might want to know the y-intercept, just to say, oh, I shouldn't have the same y-intercept. That's a problem. You can be perpendicular and have the same y-intercept, by the way. They cross at the same y-intercept, that's fine. They just got to intersect at 90 degrees. Parallel, different y-intercept because they got to be a different line. All right, that's skill 23. Now, let me check. Okay, week 10 has both skills 24 and 25. And the reason, I mentioned this at the beginning of my video, the reason is because they are really part of the same thing. Angle relationships. Skill 25 just uses the algebra. Now, I'll get to those when I get to those, but I'm just letting you know that's what's building. And the next thing is the midterm, which is going to still be up to skills 24, 25 only. No skill 26 yet. All right, find the fifth term of this. Now, I probably want an exact number. So let's see what happens when we first plug this into the calculator. A sub 5 equals 162 times 2/3 to the 5 minus 1 power, or to the 4th power. So let's first go to the calculator and see what happens. 162 times 2/3 to the 4th power. Excuse me, not the 5th power, to the 4th power. Oh, never mind. It's 32. Never mind. I was going to say if it's a fraction, we're going to have to do some work. All right, 32. Done. Notice I had to use parentheses, though, for the 2/3. If you don't, it's going to be a problem. All right, let's go back. 32. All right, write the explicit rule for this sequence here. So it's going to be a sub n equals, we need our first term, negative, 0.25 times, can you tell what we're multiplying by? You might be able to tell it's 2. If you can't tell, again, divide a value by the one before it, -1 over -0.5. Don't struggle, go use the calculator, you're going to get 2. Times 2 to the n minus 1 power. There's the rule. We're done. Skill 16. Like I said, this is where it goes a little faster. Unless I have something to talk about. Skill 17. You have inherited land that was purchased for $30,000 in 1960. That's good. The value of the land increased by approximately 5% per year. What is the approximate value of the land of the year 2023? Down to the cent. Down to the nearest cent. So y equals $30,000 initial. 1 plus 100% plus 5%. 1.05. 1 plus 0.05. So 1.05. The trick of the problem, of course, is the year difference, 1960 to 2023. That is 63 years later. So raise to the 63rd power. And that is 30,000. Forgive me. 1 plus. I wish I had just my hand calculator so I don't have to do this each time because I have to click each individual number. Okay. So 6, hold on, with dollars, 648,704.78. It says 7771. So I'm going to round up to the 78th cent. They want that 78th cent. Why not? All right. During normal breathing, about 12% of the air in the lungs is replaced after one breath. Okay. Write an exponential decay model for the amount of the original air left in the lungs after t seconds if the initial amount of air in the lungs is 500 milliliters. That means, so let's see. I have, if I breathe in, I got 500 milliliters of air in my lungs. So if I breathe out and breathe back in, 12% of the air in the lungs is replaced. So I lost 12. I didn't lose 12% of air, but the air that I had in my lungs, in my breath, in my original breath, still, I only lost 12% of the original air. There's still another, this number is important, 88% of the original air that is still there. Okay, 12% is replaced, 12% is lost. So as a model for t seconds later, I start with 500. And this is the 1 minus 0.12. I now have 0.88. 88% still remains of the original air. By the way, this wasn't supposed to be t seconds. This was supposed to be t breaths. There's one of those little mistakes. So it actually isn't time. So if I did just normal breathing, like if I'm sleeping, right? After like 10 breaths, let's see this. 500 times 0.88 to the 10th power. After 10 breaths, I now have about 140 milliliters left, so whatever. It's not that I'm losing air, it's that original air, I still have some of the original air left. Anyway, let's keep moving forward. This is where clearly I had to get a little creative with word problems as I try to be different each time. 4 times 1/4 to the x power. Oh, I don't have a graph this time. Oh, boo hickey. Yes, I do. I might have to move this later. Let me just move it up here because we've now done these problems. All right, 4 times 1/4 to the x power. 4 is the y-intercept. Times 1/4 is divided by 4. Take a quarter of that. Right? Divided by 4 is 1 and then a quarter. Divided by 1/4 would be 16. Way up there. Remember, I shouldn't pass x equals -1 if I didn't yet hit 16, so I'm not going to. So that graph is going to look like that. All right. -8 times 2 to the x power. It's one of those ones where I feel like I've done it before. Maybe I have, maybe I haven't. I don't know. -8 times 2 is -16. I can't fit it. So I'm going to divide by 2. I'm going to go backwards. Now, what a lot of my students would do is they'd multiply by 2 here, say -16, I can't fit it, so let's divide by 2. Great. They'd divide by 2 going to the right. No, it multiplies by 2 going to the right. It divides by 2 going to the left. So divide by 2 is -4, -2, -1, -1/2, -1/4, etc. They have the right idea of the graph everywhere. They just went the wrong direction. Because, and I see that with slopes a lot too. It's like, let's go up 3/5. Oh, I can't go up 3. It's too far. So let's just go down 3/5. Yeah, that works. Yeah, that's fine. Just go 5 the other direction. Because you got to maintain that course of what you do. Anyway, those are the 2 graphs. All right, skill 19, 12 to the 3x minus 5 power equals 144 to the x power. Now, 144 is 12 squared. So I'm going to keep this 12 the same. And 144 turns into 12 squared. That's still to the x power. Another student mistake that often happens, even if someone knows that and does all that stuff, what tends to happen is they get rid of their x. Like that. They just write it as 12 squared. What happened with x? It's still there. See, when you do an equation, unless you're moving terms over, you're only simplifying a side of the expression. You're rewriting how it looks. It didn't change. This is still identical to this in every which way. They just wrote how it looked differently. So that's what you got to do. Make sure, like, don't lose the x. Where did the x go? It shouldn't go anywhere. This is even the same. 2 times x is 2x, so 12 to the 2x power. Now I've truly matched my bases. I set the exponents equal. 3x minus 5 equals 2x. I'm going to subtract 2x and add 5. X equals positive 5. Number 2. 1/2, we've seen that before, times 2 to the x minus 1 equals 3. Let's isolate this. That includes getting rid of that 1/2. Don't multiply 1/2 with 2. I'm going to add 1 to both sides. Multiply both sides by 2. That's what that's for. 4 times 2 is 8. And 2 cubed is 8. So x is 3. I could do the match base thing, but if it's that obvious in one step, I'm going to do that. I don't have much room. Find the distance between the two endpoints of the segment on the graph. Find the midpoint of the two endpoints of the segment on the graph. All right, we can kind of kill 2 birds with 1 stone in this drawing. Let's go ahead and do that. How far do we go over and up? That'll help for both parts. Remember, it's a right triangle. 1, 2, 3, 4, 5. 5 over. 1, 2, up. Let's start with distance. C, if you will. A squared plus B squared equals C squared. 25 plus 4 equals C squared. C squared equals 29. C is the square root of 29. So that's distance. Hope you're good with that. Midpoint. I could tell you where it's supposed to be. It's there. It looks like it's going to be at 3.5, 3. Great. Couple ways we could do it. Now, using these numbers kind of helps. 5 is the whole way over. What's halfway? Midway. 2.5. What's halfway from 2? 1. It's not 2.5, 1. And I'm not doing this distance from here or anything. I'm not doing anything like that. But what's 2.5 away from 1? 3.5. What's 1 away from 2? 3. All right, that's the exact. I mean, you could see the point, but that's if you knew exactly where it would be. So 3.5, 3. Yeah, I can average those, but I have to come up with what these are. This is like 1, 2, and this is 6, 4, and average 1 and 6. So you can do all that. I'm just showing you what I want to do, and that's what I prefer to do, and that's it. There's something else I was going to say about these. Oh, it wasn't anything about this problem in particular. I was just thinking about, as I'm getting into weeks that are more recent, I'm remembering these problems more. Like even me going over it and stuff like that. Not that I don't remember the problems of the past, but some are so maybe not as substantial or not as recent. So like I'm seeing these and going like, yeah, I remember actually talking about these to my class when I did. All right, skill 21. Find length LM, solve for x first. Same kind of thing as before. So it's this plus this equals whole thing, right? So let's just set it up and go. 6x minus 8 plus 16x minus 2 equals 20x plus 16. Combine like terms, I get 22x minus 10 equals 20x plus 16. Subtract 20x from both sides and add 10 to both sides. And then divide by 2, I get x equals 13. So I solve for that. Solve for x first. Boom, we get 13. Find the length of LM. The length of LM equals 6 times 13 minus 8. Ooh. I just want to make sure I got that right answer. Just be sure. It looks good. Just because the number's big. 6 times 13 is, I think, 78. And 78 minus 8 is 70. It's one of those things where that number sounds familiar, but I'm sure we'll get a 70 as an answer in the future. So maybe that's not what I'm talking about. We'll see. All right. Line DE bisects segment AB at point C. This is weird. This is a little different. We haven't seen a problem like this before. So what the heck are we talking about? I got a segment AB that looks like this. We haven't talked about segment bisectors yet. I did with my students, but we did more midpoints. What's the difference? Not really anything. Line DE bisects this thing at point C. Now, point C is technically a midpoint. We kind of talk about this. Point C is technically a midpoint. How do I know that? Because DE is a bisector. Not an angle bisector, but a segment bisector. A segment bisector is a line, ray, or segment, this one's a line, that intersects a segment at its midpoint. It, just like a midpoint, divides the thing into 2 congruent parts. So here's a version of that drawing. Here could be line DE which is going through segment AB at point C. Point C happens to be the midpoint of this. Therefore, DE bisects segment AB. It's basically the same way of saying C is the midpoint of segment AB. So, AB is 10. AB is the whole thing, 10. AC is X. Solve for X. X does not equal 10. No, it's not X equals 10. X is half. 10 is whole. If this is X, so is that. X plus X equals 10. 2X equals 10. X equals 5. Now, you'll get some students that were able to draw that, understand that, but a lot would say X equals 10. You got to be careful. Half, whole. X equals 5. All right, skill 22. So little room. Let's see what we can do. Solve for X in the diagram to the right. All right. This plus this equals whole thing, right? So 2X minus 5 plus 31 equals 74. Negative 5 plus 31 is 26. Plus 26 equals 74. Subtract 26. 2X equals 48. Divide by 2. X equals 24. Solve for X. We did it. Not drawn. Ray BD bisects angle ABC. So let's draw some good old ABC. I'll just do it like that. Ray BD. Sure, looks like that. It bisects it. These are congruent. Find measure of angle ABC if measure of angle ABD is 5x and measure of angle DBC is x plus 20. So we got to solve for x first. 5x equals x plus 20. Subtract x, you get 4x equals 20, and you get x equals 5. Now we got to find the measure of angle DBC. DBC and ABD have the same angle measure, so you could plug it into either. Would you rather do 5 times 5 or 5 plus 20? They both seem pretty straightforward. Let's just do 5 plus 20 because that's actually DBC. 5 plus 20, which is 25 degrees. So I keep calling out those things like degrees because like that's the one part students could have gotten that part right and that part right, but then not let the degree symbol, boom, cost you 2. I think that's a little controversial. Some people don't really love it, but you know what? Learn from it and do it. You may wonder why I'm not putting the degree symbol for the x, because it's already provided in its expression. 2 times 24 is 48. 48 minus 5 is 43. 43 degrees is already represented. X doesn't need to be in degrees for those. It's already in there. I basically ask my students, if you're finding the measure of if you're solving for a variable, I don't need it. If you're finding the measure of an angle, that's context. I need degrees. Okay, we saw these before. Really low on room. I got to find a way to do this that's going to be conducive to you guys, so you're not lost on what I'm writing. Just hopefully you can follow me, okay? Are A, B, and CD parallel perpendicular? Neither. It's the same kind of thing as last time. So the slope of line AB, y2 minus y1 over x2 minus x1. 4 minus 3, 2 minus 1 is 1 over 1, which is 1. You might want to write 1 over 1, though. That might be helpful for this. Let's find out. Slope of line CD. I didn't, but let's see. CD, negative 6 minus negative 2. That becomes negative 6 plus 2. And negative 4 minus 0. That's negative 4 over negative 4, which is also 1. Okay. So 1 and 1, same slope. That makes them parallel. Okay. Write an equation for the line in slope-intercept form perpendicular to y equals 1/3 x plus 6 and containing 2, 7. So here's the thing. The slope of the line we're referring to right here, this is slope-intercept form. That slope is 1/3. I'm not going to use 1/3. They asked for the line perpendicular. That means I need the opposite reciprocal slope. The slope of the perpendicular line, opposite means turn positive to negative or negative to positive. This is positive to negative. Reciprocal is flip your fraction. 1/3 becomes 3 over 1. 3 over 1 is 3. The opposite reciprocal slope is negative 3. It's not the answer. But in y equals mx plus b form, I'm going to have y equals negative 3x plus b. So what is b? Let's substitute this for x and this for y. So 7 equals negative 3 times 2 plus b. 7 equals negative 6 plus b. And b equals 13. I got to add 6 over to both sides. So slope is negative 3, b is 13. That is y equals negative 3x plus 13. Okay. That's how we do that. What I'm sure happens a lot, it's not all the time. You can count on your hand, you can tally and see how often it happens. So oftentimes, whatever this answer is, parallel, perpendicular, neither, whatever, this one I ask for the other thing. So you notice how this said parallel? Then we treat perpendicular, or perpendicular parallel. I think it happened on the last one. It's not always going to be the case, because there's a neither case, I'm sure, that happens some here or there. Some questions can be different as well. And the other thing is, even if you knew that this answer was parallel, you still got to show me the slopes. So that's still a part of it. Okay, skill 24 and 25. Okay, so I got to kind of do some teachings on this. I'm going to write some terms. And I got to move my face. All right. Let me get these terms out first. Then I'll bring them up. Okay. There are 7 angle pair relationships that we kind of need to know about. I'm not going to spend a lot of time labeling them and such. You can look up lecture videos that I have. You can look up diagrams that I have for these. But these are names you're going to want to know. Vertical angles in linear pairs are both kind of part of the same. In fact, let me kind of tie these together. I don't want any space here. Vertical angles in linear pairs are kind of part of the same system. These have to do with angles that are formed from 2 intersecting lines. Line, line. Vertical angles are the angles that are opposite each other when 2 lines intersect. A way to remember them is they can be vertically on top of each other in this way. It's not always the case, because these are also vertical angles. They're not suddenly called horizontal angles. They're still called vertical angles. But I'm just saying a way to remember them is one can be literally right on top of the other. Just something to know. Excuse me. Now, that's when 2 lines intersect. You'll see this diagram over here. This has 3 different lines, one which is intersecting the other 2. We'll talk about that later. But these 2 lines intersect, and these 2 lines intersect. So when you're looking for vertical angle pairs, when these 2 lines intersect, let me do that a little better. 2 and 4 are vertical angles. 1 and 3 are vertical angles. When these 2 lines intersect, 6 and 8 are vertical angles. 5 and 7 are vertical angles. Something that's true about all vertical angles pairs is they are always congruent with each other. When 2 lines intersect, that's just the nature of what happens to them. They just end up being congruent. Congruent means equal in size and shape. 2 and 4 have the same angle measure. 1 and 3 have the same angle measure. That's what vertical angles are. A linear pair is in the name. It's a pair of angles that form to make a straight angle. They are adjacent, like this one and this one. They're not congruent. They could be if they're both 90 degrees, but rather they're supplementary. You have to remember, a straight angle is a 180 degree angle measure. Linear pairs are supplementary, supplementary meaning 2 angles that add to 180. It's exactly what they are. They have to be adjacent to each other as well. Linear pair. 1 and 2 are a linear pair. 2 and 3 are a linear pair. 3 and 4 are a linear pair. 1 and 4 are a linear pair. Those are 2 lines that intersect. Boom. 5 and 6 are a linear pair. 6 and 7 are a linear pair. 7 and 8 are a linear pair. 8 and 5 are a linear pair. Those are our 4. Or 8 different linear pairs on those. Now notice, it had nothing to do with like an angle here and an angle here. Those weren't related in that way. These other sets, however, are related in that way. So vertical angles in linear pairs only have to do with 2 intersecting lines. You could have a diagram that has a bunch of different lines. It doesn't have to be these ones. I could make another, hey, here's another set of lines. 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 that doesn't take away from the fact that, well, here, let me move this a little bit because otherwise it gets a little weird looking. It doesn't take away from the fact that 5 and 7 are still vertical angles. You know what I mean? So that's just the thing. You can have a bunch of lines, but establish the two intersecting lines that form that bond. Okay, corresponding angles. Okay, what are these? These have to do with relationships between two sets of angles where two different lines are cut by what's called a transversal. This N represents currently the transversal for these two lines. A transversal is a line that intersects two other lines at two distinct points. This line intersected this line here and here. Because what it does is it forms different sets of angles together. And now there are relationships among, say, remember when I mentioned 2 and 8? There's a relationship name among those two angles. It's an angle formed by these lines and an angle formed by these lines, and they share this line together. They share a transversal. That is a requirement for this thing to have these angle names. Let's name them. Corresponding angles. Corresponding angles are two sets of angles that, if you will, flow in the same direction. They're on the same side of the transversal, and you can see how these two just go, 2 and 6 go in the same direction there. 1 and 5, corresponding angles. 3 and 7. 4 and 8. Their angles form from the two different sets of lines sharing the transversal. They go in the same direction on the same side of the transversal. Those are corresponding angles. These lines are not known to be parallel. Actually, they are. It says line L is parallel to line M. Corresponding angles do not have to have parallel lines to be true. I could have had this line, and this transversal, and these are still corresponding angles right here. They're not congruent, but they're corresponding angles. Corresponding angles are not necessarily congruent, but there's a postulate, which is a way of saying something fancy. There's a truth in math that if your lines are parallel, and here's the marking for parallel lines, a set of arrows or something like that. If your lines are parallel, then corresponding angles are congruent. Corresponding angles are congruent. Angle 3 is congruent to angle 7 if these lines are parallel. These lines actually do happen to be parallel. It kind of says right there, and I make the marking. 4 and 8 would be congruent to each other, congruent corresponding angles. So they're congruent only if lines are parallel. So I'm going to kind of put this if parallel. You can see why the parallel perpendicular lines thing kind of has to happen first. So congruent, if that's the case. Alternate interior angles. I'm going to start going a lot faster now. The interior is when we're talking about in between the two lines that are cut by the transversal. This here is known as the interior. This is the interior right there. Sorry about the little overlap. That's the interior. The exterior, in case you're curious, is right there and right there. Interior, exterior. Inside the lines, outside the lines that make the transversal. Alternate versus same side. You can see those words. These wordings can help you understand what we're talking about for these things. Alternate means opposite sides of the transversal. This is the transversal. Here are angles on one side of the transversal. Here are angles on the other side of the transversal. I want to find an angle pair that are alternate interior angles. 4 and 6 are alternate interior angles. They are on opposite sides of the transversal, and they are in the interior of those two lines that are cut by the transversal. 3 and 5 are alternate interior angles for the same reason. When lines are parallel, alternate interior angles are also congruent. 3 and 5 are congruent if lines are parallel. Now, there are ways that I can kind of prove that. Check this out. 3 and 7 are congruent by the corresponding angles postulate, right? We learned that. 7 and 5 are congruent by the vertical angles theorem. Boom, boom. Vertical angles are congruent, corresponding angles are congruent. If these are congruent and these are congruent, by the transitive property of congruence, 3 and 5 are congruent. You'll learn that in IM 2. Actually, maybe IM 1. It might have been a proof I did in IM 1. Anyway, alternate interior angles are congruent. Alternate exterior angles. Angles in the exterior of different exteriors on opposite sides of the transversal. 1 and 7 are alternate exterior angles. 2 and 8 are alternate exterior angles. Alternate exterior angles are also congruent when lines are parallel. Same side interior angles would be 3 and 6. They are supplementary when lines are parallel. I should probably, let me do something. Color scheme this properly. All right. Same side interior are supplementary when lines are parallel. Same side exterior, like 1 and 8. Oh, by the way, 4 and 5 are same side interior. 1 and 8, 2 and 7, same side exterior. They are also supplementary when lines are parallel. Now, those are a lot of names. Some of the names are like in the name, if that makes sense. Like corresponding's not. Vertical angles, yeah, it can be. Linear pairs kind of in the name. Alternate interior, exterior, same side interior, exterior. I'd say those are kind of in the name, so I think that helps. The congruent versus supplementary part. Argumentatively, how are you to remember one versus the other? Well, good news is the alternates are both congruent. The same sides are both supplementary. That's kind of nice. But honestly, to me, it's in the drawings. This is, I don't want to overstress this. I stress it to my students too much, but they need to understand it. Remember, this is if lines are, these don't require parallel lines. These have nothing to do with parallel lines. It just has to do with two intersecting lines. Boom. Vertical angles are always congruent. Linear pairs are always supplementary. These need parallel lines. Okay, keep that in mind. Parallel lines, I mean, visually will be striking, right? Parallel lines will look parallel. That being said, if I go by an extreme like this, and I ask you, are these angles congruent? Are these angles equal in size and shape? You can easily answer no. This angle is clearly much larger than this one. This angle is clearly acute. This angle is clearly obtuse. There's no way those are at all even close to congruent. What if I compared these two? Are these potentially congruent? I can see a reason to say that those are potentially congruent to each other, both very acute with each other and all that. By looks alone, if I told you that with parallel lines, if I told you that your angles either had to be congruent or supplementary and asked you which ones they were, you should be able to go by looks alone, even if you couldn't memorize this thing. These are alternate interior angles. These are congruent. They look congruent. To be supplementary, they'd have to add to 180. These angles are very acute. By acute, I mean less than 90. They're like 30 degrees. There's no way that 30 plus 30 would give you 180. You'd have to have one acute, one obtuse, or both right angles. To be congruent, they'd have to both be acute together, or both obtuse together, or both right angles. Right angles are both congruent and supplementary to each other. But, and I'm sorry I still haven't done these. I'm going to speed up on these after. These are clearly congruent if lines are parallel, not supplementary. So if I gave you the option, don't go, again, some of my students, it's like they ask as in, let me tell you yes or no. Like congruent, like supplementary, just to guess. And if one person guesses, the other people follow the same saying. Look at them. Look at them. Look at what they look like. So anyway, I just wanted to kind of bring that up. It's going to happen for all these. Let's move forward. Okay. Skill 24. What is the name of the angle pair relationship for angles 1 and 8? Here they are. Those are same side exterior angles. Now what I'm going to do is I'm going to write abbreviated versions of these. SSEA. They're same side exterior angles. Measure of angle 1 is 72 degrees. What is measure of angle 8? Keep in mind, these lines are parallel. Line M is parallel to line L. Same side exterior angles. They're either congruent or supplementary. Can you tell me which one they are? Without looking at this list? I can look at the list and say they're supplementary. Let's look at them. 1 looks acute, 8 looks obtuse. Clearly they're not congruent. They must be supplementary. They're supplementary. That means they add to 180. So 72 plus the measure of angle 8 is 180 degrees. Subtract 72 from both sides. The measure of angle 8 is 108 degrees. You need the degrees. That's the answer. It's not 72. All right, skill 25 is skill 24. So the reason I spent a lot of time on this is because 25 is 24, just with algebra. I'm not going to ask what's the name of the pair. I'm going to ask you to solve for variables. But you set it up. You either set them equal to each other or add them to 180. And that's it. Maybe you have to find the measure of an angle, but it's with algebra. That's all. Measure of angle 5, let's identify them. And by the way, when I do markings here, I'm not saying they're congruent. I'm just showing where they are. Measure of angle 5 is 3x plus 50. Measure of angle 7 is 65. Solve for x. These are vertical angles. There's no alternate nothing. That has nothing to do with this line. This line is irrelevant. Parallel lines is irrelevant, although they're parallel. Just these two. Opposite each other when two lines intersect. When line N intersects with line L. Vertical angles. Vertical angles are congruent. Solve for x, set these equal to each other. This is where the algebra goes fast. 3x is 15, divided by 3, x is 5. There it is. Measure of angle 3 equals 2x degrees, this guy. Measure of angle 6 equals 3x minus 20 degrees. Find measure of angle 3, solve for x first. These are same side interior angles. By the way, these were vertical angles. You don't have to identify them, but it helps. Because if you know same side is supplementary, then you wouldn't set these equal to each other. You would add them up and set them equal to 180. And that's what we do here. 5x minus 20 equals 180. Add 20 to both sides. 5x is 200. X equals 40. Not done. Solve measure of angle 3. 2 times 40. 2 times 40 is 80. Not done. Degrees. I'm done. All right. There's skill 25. Okay, let's put these to the test, the midterm, if you will. These ones actually have the labels and all that, which is good too. All right, geometric sequences, right? The first 4 terms of this guy. So the 1/2 means we'll divide our numbers by 2, go half of what we had before. So the first term is 200, half of 200 is 100, half of 100 is 50, half of 50 is 25. I'm going to go faster if I can on skills we've done. Find the 9th term for this. It'll help if you get the explicit rule, or if you multiply by your common ratio over and over. 10 is the first term. -2 looks to be the common ratio. So let's find a sub 9 by doing 10 times -2 to the 9 minus 1 power. I think 256. -2 to the 8th power. So, well, positive 256, right? Because the -2, yeah. Times 10 is 2,560. Now, if you get negative 2,560, let me state this. If you get negative, what probably happened was you didn't use parentheses in your calculator for -2. But if you want to know what sign you should get, I could ask you right now, the 1,406th term should be positive or negative? You tell me. Go by the things. Positive, negative, positive. First, second, third. The odd terms are positive, like the 9th term. Positive. The even terms are negative. So the, what I say, 1,406th term, even number, negative. So you could even just go based off that, right? You don't really need... So you should know it's positive anyway. All right, skill 17. Rio Americano High School, that's my school, has 1,945 students and is expected to increase its total enrollment by 2% each year. Not true this next year. It's going to decrease. How many students will Rio Americano have in 10 years? All right, so y equals 1945 times the 2% increase. So 1.02, 1 plus 0.02, raised to the 10th power. So, and remember, this is people. So 1945 times 1.02 to the 10th power. So when we see a decimal, we're going to cut off that decimal. I'm getting 2370.94. I'll just go and round that up. 2371 students in that year. Hey, if we build enough buildings, then it can work. If not, we're going to have to just keep enrollment the same. I don't know. It's just a made-up problem. All right, a certain forest covers an area of 2,500 square kilometers. Suppose that each year this area decreases by 4%. Sad. What will the area be after 7 years? So 2,500 times 1 minus 0.04. 0.96. That's 1 minus 0.04. Hopefully we're good on that now. 7 years later. I didn't ask for a certain decimal amount, so let's just see what the number looks like, then I'll tell you. 0.96 to the... My neck is kind of... to the 7th power. Probably not even halfway done. Although I'm about 3 hours in. 1878.61. I'll just do 1878.6. square kilometers. Fine. It's good. All right, 16, 17. At least I have space on these. I like these. And big graphs. -6 times 3 to the x power. I think I said, yeah, let's go big. -6 times 3 is -18. Times 3 is -54. Ain't going to fit that. Divided by 3 is -2. Divided by 3 is -2/3 and -2/9 and yada yada. Asymptote and all. Let's just do an asymptote. Oops. That looks good. 12 times 1/2 to the x power. 12. Half of 12 is 6. Half of 6 is 3. Half of 3 is 1.5. And then 3/4. And then 3/8. And you don't care. I can fit one to the left. I'm going to divide 12 by 1/2 or multiply it by 2 and I get 24. I can fit that. I'm going to. And I did. Haha. And this is not going to be a good looking curve. Or it is. It's going to be okay at the out. No, it's not. Sorry. Okay. There's graphs. Skill 19, solving exponential equations. Okay, here we go. Ugh. Solve 10 to the x plus 4 minus 20 equals 80. Add 20 to both sides, we get 100. 100 is 10 squared. Not done. Set the exponents equal to each other. Subtract 4 from both sides. We get -2. 49 is 7 squared. I can match bases there. Raise the x power, don't forget that. 2 times x is 2x. 7 and 2x power. Set the exponents equal to each other. Let me scroll down. I'm going to subtract 2x and add 6. Divide by 2, you get x equals 3. All right, I like the speed. Skill 20. Find the length of segment AB graph below. Down 2 right there, and 1, 2, 3, 4, 5, 6 over. Let's do 2 squared plus 6 squared equals c squared. 4 plus 36 is c squared. C squared equals 40. If you take the square root of both sides, c is the square root of 40. It's exact. Somewhere between 6 and 7. Like 6.3 something. I don't really know. The simplified radical version is 2 root 10. Square root of 40. Find the midpoint of -10, 1 and 0, 2. We could probably do this in our head. What's halfway between -10 and 0? -5. What's halfway between 1 and 2? 1.5. If you'd like to average them, -10 plus 0 over 2 and 1 plus 2 over 2. You can get there. All right, A, B, and C are collinear points with B on segment AC. Let's go and draw that. It's always nicest to do that. The length of segment AB is 20. AC is the whole thing. 36 minus x. That's why it's good to draw it. Some people just assume this plus this equals that. Nope. That's not the case. BC is 3x minus 8. Solve for x. All right. 20 plus 3x minus 8 equals 36 minus x. Not 36x. Oh, my neck. 20 minus 8 is 12. Simplify sides first. Simplify sides. Add x over, subtract 12 over, divide by 4. You get x equals 6. That's all I needed. M is the midpoint of segment LN, so these two are congruent. Find the length of MN. So we're going to set these equal because they are equal. That's what a midpoint does. I wonder why that got blurry. Subtract 8x from both sides. Add 21 to both sides. Divide both sides by 3, and you get x equals 12. We've got to find the length of MN. It's going to be the same length as LM. So you can do, whatever substitution. Let's do MN. The length of MN is 8 times 12 plus 15. 8 times 12 is 96. Plus 15 is, I was going to say 101, is 111 units. Not degrees. It's not an angle. Next set is angles. That's skill 21. Let's go to skill 22. In the figure below, the measure of angle IJB is x minus 6 degrees. It's drawn but not labeled, right? Measure of angle BJK is 2x plus 73 degrees. And measure of angle IJK is 172. Find the measure of angle IJB. So we got to solve for x. So x minus 6 plus 2x plus 73 equals 172. X plus 2x is 3x. Negative 6 plus 73 is 67. You know what I'm getting flashbacks of is not just these problems, but my grading of these problems when the students did them and the mistakes that would be made. Right? It's hard for me to remember if someone gets something right because it's a 2 and move on or whatever. It's when they get it wrong that I'm remembering. I'm flashing back to what would have caused it, and for a lot of people, it was like negative 6 plus 73, they'd put 79, or negative 67, or, something. It's just like, ooh, I just wish I could, help them. Did I do that right as I spoke? I think so, 35. So now I got to find the measure of angle IJB, or they got 35 and stopped, right? Measure of angle IJB is 35 minus 6, which is 29, and then the degree symbol. So it's all those little things. It's like, you got a lot to do for a problem. But you know what? You got to get it right. At some point, partial credit's great. I guess that's what the 1 is for. At some point, you got to get a problem right. You know what I mean? All right. Segment AB bisects angle CAD as shown. That means this is congruent to that. Solve for x. I drop a hint. What is the measure of a right angle? Why do I ask that? Because I got a right angle symbol right there. The right angle is the whole thing, DAC. Measure of angle DAC is 90 degrees. The whole thing's 90. The little guy, this guy is 7x minus 4. So you got a couple ways of doing this. 7x minus 4, again, if that is, then so is this. So you can double it up and get 90. And then distribute, that's great. Or, the whole thing's 90. So this not only makes these congruent, it also divides it in half. So one of these angles is 45. 7x minus 4 doesn't equal 90. 2 7x minus 4 is equals 90. If you divide by 2, there are a lot of ways you can do this problem. Just saying 7x minus 4 equals 45. Whatever you do, you can solve for x. 7x is 49. If you add 4 and then divide by 7, x equals 7. Okay, it's a lot of blue. All right. Are A, B, and C, D parallel, perpendicular, or neither? The lines. Slope of line AB, y2 minus y1 over x2 minus x1. I'm getting negative 1 over 4. Slope of line CD, I love this room. I'm just exploring the space. 1 minus negative 3 over 0 minus negative 1. 1 plus 3 is 4. 0 plus 1 is 1. 4 over 1. Opposite reciprocal slopes. They're perpendicular, which means, and I haven't looked at the next problem yet. Does the next one ask about parallel? We'll see. I have no idea. Perpendicular. All right, there we go. Write an equation for the line. Hey, parallel. For the line parallel to y equals negative 2x plus 1, passing through negative 5, comma 3. All right, we're going to use the slope, negative 2, parallel, same slope. Let's do y equals negative 2x plus b. Let's find some other b that hopefully isn't just a 1. It shouldn't be. I've done these problems before. 3 for y. Negative 5 for x. 3 equals negative 10 plus b. And that's a b of 13. So this is going to be y equals negative 2x plus 13. That is our equation. All right, skills 24 and 25. That's all that's for the midterm. We're not done for this whole thing. That's all that's for the midterm. So I got a diagram. What is the angle pair relationship called for angles 1 and 5? These guys. You guys know? Oh, something just popped up. Corresponding angles. Not same side, nothing. They may be on the same side of each other. It's not the name of it. All right? Suppose the lines cut by the transversal are parallel, and measure of angle 1 is 142 degrees. What's the measure of angle 5? Corresponding angles are congruent when lines are parallel. It's 142 degrees. They're the same. They look the same. If I asked you, again, congruent or supplementary, and you said supplementary, and you say it's 38 degrees, look at it. I'm just like, these look parallel. These look big and obtuse. Look at it, right? Make sure you know. I don't want to keep saying that kind of thing, but just, be careful. All right, skill 25. Solve for x in the diagram below. You are looking at an alternate exterior angle pair. The markings show that the lines are parallel. So we are going to set these equal to each other. -1 plus 14x equals 12x plus 17. I'm going to subtract 12x from both sides, add 1 to both sides, and divide by 2. I get 9. Was that it? Yep. Okay. Find the measure of the angle in bold. So this guy's in bold. You're looking at same side interior angles. Now these are close to looking congruent, but one is still clearly obtuse and one is still clearly acute. Acute and obtuse. They're same side interior angles. They're supplementary, not congruent. I don't set them equal to each other. I add them to 180. 20x plus 5 equals 24x minus 1. What did I just say? I set them equal to 180. Good thing I caught myself. Plus 24. I don't want to type anything. Plus 24x minus 1 equals 180. That's 44x. 5 minus 1 plus 4 is 180. Subtract 4. And divide by 44. I believe that's going to be 4. Not done. We're going to solve for the angle measure in bold. That is 20 times 4 plus 5, which is 80 plus 5, which is 85 degrees. Slightly acute. Now I'm going to move forward, but just before you submit is things that my students had for the midterm. Make sure you have proper units, including degrees for the measures of angles. Literally the problem right above was doing that. So for those who got that right answer and didn't put the degrees, I can't help you. You double check, you put arrows, square roots, things like that. I gave them a good heads up on that. And I kind of do each time when I pass it out. All right, moving on to week 12. So it wasn't really a week 11, like I said. The midterm was week 11. But here's where we're going to build into skill 26. You're going to see problems on the other page. So skill 26 will pop up next, which I get to teach you. Let's go before that. Write the next three terms here, 1/2, 1/4, 1/8. You can see what's kind of just happening is the bottom is doubling, and unless I ask for, I didn't ask for common ratio or anything, but let's write these next three. Times 2, times 2, times 2. Now, the ratio isn't 2. The common ratio is 1/2, but the bottom's being doubled. The top is staying the same. That's actually what they are. Write the explicit rule for 4, -4, 4, -4, etc. It's a different kind of geometric sequence. I mean, it's a geometric sequence, but it's not growing or shrinking, or it's not growing or decaying. It's just oscillating. 4, -4, 4, -4. Does it follow the patterns of geometric sequence? It has a common ratio. Common ratio is -1. See how it works? Write the explicit rule. A sub n is 4, first term, times -1 to the n minus 1 power. Geometric sequences can do that. And it did. All right, round to the nearest whole number for each problem and indicate units of measure. All right, nearest whole number. In the early stages of the COVID-19 outbreak, there were 22 new cases reported. I remember when I wrote this, it was supposed to be in the UK. In the UK. 22 new cases in the UK reported on March 1st, 2020, and the number of new cases increased on average by about 22% per day. How many new cases were expected to be reported on March 21st, 2020? So a lot of 20s, like 22, 22, 2020, 21, a lot of things. And the difference between these 2 days is 20, so you have to be careful. What's a 20? What's a 22? All right, y equals initial 22 cases increased by 20%. 1.22. 20 days later, from the 1st to the 21st, that's a 20. Boom. Round to the nearest whole number and indicate units of measure. So 22 times 1.22 to the 20th. 1173.86. So I'll do 1173.86. 174 new cases. Now, I don't want to scare you about COVID stuff again, but this doesn't mean this is how many people had it in the UK on this day. This is how many new cases were reported on that day. So you add it with the 22 on March 1st and the 24 on March 2nd. You add all those, right? So just, that's, hope you wore your mask. All right, a total of 50,000 contestants participate in an internet online survivor game. The game randomly kills off 20% of the contestants each day. About how many contestants remain in the game after 1 month. Now, when I made this, I don't really get my own question. If you're surviving, I guess you just die. You don't have to do anything to survive. You're just randomly killed. Anyway, 50,000 contestants kills off 20%. So 1 minus 0.2. That's going to be 0.8. About how many contestants remain after 1 month. Now, if my students showed work and they said if we were in February or something and they put 28, then that's fine. I assume a month is 30 days. I mean, but aren't there more 31-day months? Anyway, 30 days. I'm going to use 30. You can make your choice on what you choose. But whatever they chose, I gave it to them if they didn't put 1. 28, 29, 30, or 31. I accept it. They just got to show the work. 30 days, 61.897. I'll say 62. 62 contestants remain after a month. I don't know. If I'm a contestant, I'm probably sick of that game. Hope I died early. Maybe after 6 days. All right. Let's graph these. 3 times 3 to the x power and negative 2 times 5 to the x power. 3 times 3 to the x and negative 2 times 5 to the x. All right. 3 times 3 divided by 3 divided by 3. 1/3. Are you getting those? You see why I'm not doing a table for these right now? See why it's faster to get that? Negative 2 times 5 to the x power. Now, I have a lot of videos on these things as well, too. It's not just for you guys in IM1, but also in IM3, where we do shifts. So I have to go kind of fast over time. Times 5 is negative 10. It goes kind of fast. Divided by 5 is negative 2/5. It's kind of near negative 1/2. It's not a great number, but I can use it. And approaching the asymptote. These are both exponential growth. One's negative, one's positive. There they are. Skill 19. 9 equals 3 to the 4x power. 9 is 3 squared, so that's going to match the base. Set the exponents equal. 2 is 4x. Divide by 4, not 2. X is 2/4 or 1/2 or 0.5. I actually don't want 2/4 as the answer. Okay, let's get 5 to the x power by itself. Don't multiply the 2 with it. Let's subtract 25 first. 2 times 5 to the x power equals 50. Divide by 2, 5 to the x power equals 25. That's 5 squared, so x is 2. Okay. Okay, not much room. Oh, I remember there's a mistake here. I think it's a 0. I'm going to remember that. Okay. Find the distance between the points 2, negative 10, and 7, negative 5. So let's try this. The distance between 2 and 7 is 5, so a squared, plus the distance between negative 10 and negative 5 is 5, b squared, equals c squared. Remember, even if you got negatives for these, you will square them. They will turn positive. 25 plus 25 is c squared. C squared is 50, so c is the square root of 50. We've had that answer before, but obviously it's a different set of points. Not obviously, I repeated a problem once by accident, but I believe that was a mistake. All right, if a segment on a graph contains the midpoint 4,2 and an endpoint of 7,4, what is the other endpoint? So we changed this on the quiz. I think B is the answer. That's why I'm trying to remember that. We'll see if that was the right one. This is the one with the endpoint. Like, let me kind of give you a visual. 4,2 is the midpoint, and endpoint is 7,4. So somewhere on the other side, boom, whatever, is some other thing, right? We're going down from 4 to 2. We're going down 2. And we're going left from 7 to 4. We're going left 3. Let's go down another 2 and left another 3. Oh, it wasn't 0, -1. It was 1, 0. There we go. Down 2 and left 3. Boom. That's at 1, 0. So like that's the thing. I'm not going to do it like that way, but that's a visual. That's a visual. You can do it that way. You can do it that way. From 7 to 4 is 3 away, and another 3 away is 1. And from 4 to 2 is 2 away, another 2 away is 0. Remember, 4, 2 is the average of these xy values. 4 is the average of 7 and another x value times 2 to both sides. Sorry. Times 2 to both sides. And subtract 7. You get x equals 1. The only answer with 1 for x is B. 0, if you believe that's supposed to be a 0. Oh, excuse me. 2 is the average of 4 and some other y value. Multiply both sides by 2. Did I say that right? 2 is the average. Oh, excuse me, times 2. I looked at 2 times 4. Subtract 4, you get y equals 0. Sorry about that. And then you get 1, 0. 1, 0. So multiple choice and the only wrong answer. The right answer is the only one that's wrong. All right, skill 21. All right, this is going to happen a lot later. This was so I could fit some stuff the way I wanted it to. And I don't know, maybe I got a little lack of creation. Treat both problems independently of each other. Now, I don't know if that makes everything perfect here. I think this is where I had some mistakes. But here's the diagram that's used for both problems. And that information is now supposed to be used for both problems. But treat the problems independently. So here it says AC equals 39, right? That's just for the first problem. Here it says B is the midpoint of AC. That's just for that problem. Does that make sense? Okay, cool. All right, AC is 39. B isn't the midpoint, but AC is 39. So I'm going to add those. 9x plus 7 plus 3x minus 20. So I'll put minus 3x plus 20 equals 39. 9x minus 3x is 6x. 7 plus 20 is 27. Subtract 27. Divide by 6. You get 2. That's that. Now, B is the midpoint of segment AC. Solve for x. Congruent. 9x plus 7 is negative 3x plus 20. Add 3x. Subtract 7. Divide by 12. 13 over 12. It's a weird number, but it's the answer. That's it, right? Kind of hard to now come up with problems that way and like make them all clean numbers. So, all right, same thing. Treat both problems independently of each other. So, measure of angle ABC. The whole thing is 94 degrees. So this plus this will equal the whole. So 3x plus 15 plus x plus 7 equals 94. Let's solve for x. 3x plus x is 4x. 15 plus 7 is 22. Subtract 22 from both sides and divide both sides by 4. 18. I don't really remember that problem. BD bisects angle ABC. Now look, it doesn't look like it, but I told you that it does. So listen to me. Find measure of angle ABD. Remember, the 94 is not relevant, so you can't divide it by 2 and say it's 47, unless that's the answer. But these two guys are equal now. 3x plus 15 and x plus 7 are the same. Subtract x from both sides. Subtract 15 from both sides. You get negative 8. Divide both sides by 2. You get negative 4. Now, we're not done. We got to find the measure of angle ABD. Negative values are weird for measures because you can't have negative angle measures, negative segment lengths. And this isn't an angle measure, though. This is just x. So you can have negative x values as long as you plug it in. 3 times negative 4, ABD is that guy. 3 times negative 4 is negative 12. Negative 12 plus 15, whoops, plus 15, that's positive 3. 3 degrees. Obviously, it doesn't look like 3 degrees. It's just the problem. Negative 4 plus 7 is 3 degrees. They are the same. They should be, and that's the answer. So you should still get that. Now, I know there's a problem later that I messed up on. It's sometimes, I make these quizzes and I save them and I forget to go back to problems and I change things. So there are times where that's my excuse that I forget to go back and change a problem. And there's a problem later where it has like a weird fraction that gets a negative measure, and I don't know what to do with it. I'm just going to treat it as it is and just say, I screwed up. That's all I can do. All right, are the lines y equals 2x minus 7 and 2x plus 4y equals 20 parallel, perpendicular, or neither? So from the onset, you look at the, some people call the slope 2x. First of all, it's not 2x, it's 2. The m is 2. M is multiplied by x. X is a value that goes with y and all this stuff. But the slope is 2. This is y equals mx plus b form, however, and it is a slope of 2. Now, the slope isn't just the value that's multiplied by x. That's when you're in slope-intercept form. The slope of this line is not 2, because this, or it's not necessarily 2, because this is not in slope-intercept form. You have to get y by itself. You have to make it say y equals mx plus b. So that's what we have to do. So there are kind of 2 steps. Subtract 2x over 4y equals negative 2x plus 20, and divide both sides by 4. And you divide everything by 4. And remember, I don't really care about this unless it was the same slope and they had the same y-intercept. Then I'd say, oh, that's a trick question. Neither. But not here. Well, maybe. Let's see. Y equals negative 2/4 reduces to negative 1/2 x plus 5. And honestly, I don't care if I have that 5 or not. But a negative 1/2 slope is negative 1/2. I got a slope of 2, which means 2 over 1. I got a slope of negative 1/2. Opposite reciprocals. These have, I'm going to write out the phrase. I said I would later. Here it is. Opposite reciprocals. They're perpendicular. Let me circle perpendicular. They are perpendicular. That must mean these are parallel. Write an equation for the line parallel to y equals 1/4 x minus 3 and containing 8, 0. Okay, so let's use a different color. 8, the slope is going to be 1/4, same slope. So y equals 1/4 x plus b. We're going to have that form. Plug in 0 for y and 8 for x. 1/4 of 8 is on the menu. That is 2. 0 equals 2 plus b. Subtract 2 from both sides. B is negative 2. I'm sorry that you can't see that. You probably didn't see me write opposite reciprocals. I forgot my picture was in the way. I'm so sorry. Could you see that before? My bad. I'll give you that. Can you see that? Yes, you can. All right, this is y equals 1/4 x minus 2. And I am flashing back to some answers that students got where they even put b as negative 2, and then they put plus 2. It's like that stuff. It's like, oh, man. You're supposed to be right. I guess that's it. You're supposed to be right. Sorry, not sorry, right? All right, refer for skills 24-25. L is parallel to M. Kind of the same diagram as that one, but different questions. What is the name of the angle pair relationship for angles 2 and 4? Those are known as vertical angles. Measure of angle 1 is 72 degrees. What is measure of angle 8? All right, well, that seems like a question we had. It does. I probably ran out of creativity. Sorry, I'm going to go back. Did I ask that? Oh my gosh. It's that same question. Maybe I forgot. Maybe it was just maybe I forgot to rehash it because this is the quiz after the midterm, right? So I forgot to. Sorry, that's an exterior angles, by the way. I forgot to change that. It's 108 degrees. We did that before. Okay. That's one of those things of me not changing something. All right. Measure of angle 4 equals x plus 84 degrees. Measure of angle 6 is 5x degrees. Find the measure of angle 6. Alternate interior angles, those are congruent. All right, so we're going to do x plus 84 equals 5x. I'm going to subtract x from both sides. And I'm going to divide both sides by 4. I get x is 21. We need to find the measure of angle 6. Now, 4 and 6 are the same. So you can either do 5 times 21 or 21 plus 84. Measure of angle 6 is 5 times 21, which is 105 degrees. Measure of angle 7 is 78 degrees. It's this. There's that sneeze. And 8 is 3x plus 21. They're a linear pair. Linear pairs are supplementary. So these will add to 180. Solve for x. 78 plus 21 is 99. Subtract 99, I think it's 81, and x is 27. Okay. Okay, skill 26. I'm gonna draw an octagon. Actually, they're asking about a certain thing, a decagon. Okay, skill 26 is about interior and exterior angles, polygons, triangles, quadrilaterals, pentagons, hexagons, heptagons, octagons, nonagons, decagons. I don't know a 11-sided shape called dodecagon. It's a 12-sided shape. Let's talk. These are known as interior angles right here. I'm marking them with eyes. Okay? In this particular problem, a decagon, a 10-sided shape, they talked about a regular decagon. A regular decagon, a regular polygon, is a polygon with all congruent sides and all congruent angles. If one of these is eye, all of them are eye. You're going to see problems that are not regular, and they might be different measures. But this is with all of them being the same. So when I answer this question, it might be different from some others. But those are known as interior angles. Okay? First thing I want to bring up. This is just vocab right now, not solving the problem yet. Exterior angles. This is not an exterior angle. Sort of, but that's not the actual thing. These, I don't know if this is going to look good. These are exterior angles right here. Exterior angles they are outside the polygon, sure, but they are the measures. I'm not going to do them all. They are the measures of the angles from one extended side, and it forms a linear pair with the interior angle. So the interior and exterior should make a 180-degree angle. Boom, like that. So these are the exterior angles, okay? There's a formula for finding the interior angle sum of any polygon. If D was the interior angle sum and N was the number of sides and angles of any polygon, D equals 180 times N minus 2. The interior angle sum is 180 times N minus 2. Now that comes from the fact that the interior angle sum of any triangle is 180 degrees, and you have 2 less triangles in any polygon than you have number of sides if you draw diagonals connecting from one vertex to all the other non-adjacent vertices of your triangle, or of your polygon. There are 8 triangles in a 10-sided shape. Their interior angle sum of all these is 180 degrees. I do 180 times 8. 8 is 10 minus 2. That's where that comes from. So the sum, if I add all of these, boom, plus boom, plus boom, plus boom, these measures right here, I'm going to get the interior angle sum for this triangle, for this decagon. So D is 180 times 10 minus 2, which is 180 times 8, which is 1440 degrees. We need to find the interior angle measure of one angle, a single eye in here, in this decagon. The interior angle measure of one of them is you take the interior angle sum and divide by the number of sides or angles. There are 10 of these. They're all the same. So I is 1440 over 10. This is 144 degrees. There are a lot of different ways we can answer these questions. excuse me, there are a lot of different questions I can ask in this skill set. This is among one of them. The 180 times n minus 2 thing is big. That's going to happen a lot. By the way, remember those exterior angles? I did state that they are supplementary to their interior angle counterpart. You know what an exterior angle sum is? It's 360 degrees every time. There's no 180 times this and that. You can notice that interior angles get larger as you get more sides, and there are more of them. That's why the amount gets bigger over time. Triangle is 180 degrees. A decagon is 1440 degrees. Exterior angles, although there are more of them as time goes on, they actually get smaller. You can see this triangle right here. There's an exterior angle of a triangle. It's huge. These ones are tiny. The exterior angle sum is always 360 degrees. So the measure of any one exterior angle in a regular polygon, you take 360, its sum, and divide by the number of sides. Or E is 180 minus I, and I is 180 minus E. A lot of different kinds of ways we can do these problems, and a lot of different questions I can ask. All right. Solve for x in the diagram below. Now, here you have two interior angle measures of a triangle and a third that's unknown, and you have one of the exterior angle measures of the triangle. Practically, we could say all three interior angles of a triangle add to 180 degrees, this plus that. If we found out what this was, then we could add them up, set them equal to 180. And you could find what this is by doing 180 minus that to get that. But here's the thing. If I do 180 minus that angle to get that measure, and then I add all three of those angles up to get 180, to solve for x, I'm actually doing some redundancy. I subtracted from 180 to add something up to get to 180 in a way that I didn't need to. This setup in particular is something known as the remote exterior angle theorem. I believe it's also just known as the exterior angle theorem. I might say it incorrectly, but that's okay. The idea is in place. Angle theorem. The theorem states that two interior angles of a triangle remote to this exterior angle have a relationship. These two add to this. And there's a big reason for that. These three add to 180. These two add to 180. And that's a shared angle in that relationship. So these two add to that. I mean, there's a proof idea. I have it in a video. I'm not going to point to it. Point is, this plus this equals that. X minus 65 plus 92 equals 5x minus 1. More than one way to solve it. This is the way. Probably expected to solve it. Negative 65 plus 92. 27. Subtract x, add 1. And x is 7. Is that all? Solve for x. Yes. All right. 144 degrees and 7. Okay. Moving forward. Week 13. We still have a lot of weeks to go, guys. And we're in 3.5 hour mark. This will probably hit 5 hours. All right. Write the explicit rule for this guy. Negative 0.1, negative 0.01, negative 0.001, etc. Now, the numbers are shrinking, but how? This is one of those things where you might want to practice that division thing, right? Divide 1 by the one before it. Now, you're going to get 0.1 in your calculator. That's also 1/10. I'll stick to the decimal. These are decimals. So your rule is a sub n is, first term is negative 0.1. Common ratio is 0.1 to the n minus 1 power. Okay, write the first four terms for a sub n equals 12 times 2 to the n minus 1. Start with 12 and start doubling. 12, 24, 48, 96. All right. A new laptop battery with 100% max charging capacity begins to degrade over time and loses about 20% of its capacity every year with regular use. So it starts at 100% when you first bought it, and it loses 20% every year. Meanwhile, a user on Reddit claims their old laptop battery has 75% max charging capacity, like now, like it's an older laptop. So it's less than. And with proper charging techniques, it only loses 10% of its capacity a year. Let's pretend like he knows what he's talking about, and it's all good. Write a model for both laptop battery scenarios in this form. Simplify the inner quantity. Basically, the 1 plus or the 1 minus actually confine it. So this first one, new, I'll call this the new model. We're going to do y equals, we're at 100. We're going to lose 20% every year. 1 minus 0.2, that's 0.8 raised to the t power. There's one. Let's go to the Reddit person. Reddit. That's y equals, he's at 75%, or she. Loses 10% every year. 1 minus 0.1, that's 0.9. So those are the two models. Okay, which laptop battery would have a greater maximum charging capacity after 3 years? New or Reddit? So we're going to substitute 3 for T in both of these. So let's do, for new, y equals 100 times 0.8 to the third power. That's going to be, I think it's 51.2 if I know my stuff. 51.2. I won't know the other one. 51.2%. Reddit, it's because 8 cubed is 512, so it's a thing. Reddit, y equals 75 times 0.9 cubed. 75 times 0.9 cubed. 54.675. 54.675%. So, who has a greater maximum charging capacity? Reddit. So their battery, and their battery's going to win over time if they keep doing things properly, like that, because they're just, it's 90% versus whatever. So they had less for the first 2 years, but their laptop's older, and that makes sense. All right, graph. Okay, I have them right here. Y equals 9 times 2/3 the x power. So y equals 9 times 2/3 the x power. This one might be nicer for me to kind of make a table for, because I just want to show you. So xy. Ooh, there's just not much room. Let's kind of let's just do this. 0, 1. 0, 9. All right, 2/3. 9 times 2/3 is 6. 9 times 2 is 18. Divided by 3 is 6. That's a 1. 6 times 2/3. 6 times 2 is 12. Divided by 3 is 4. 4 times 2/3. I'll do this a couple more times. 3 and 4. And that times 2/3. 4 times 2/3. 4 times 2 is 8. Divided by 3 is 8/3. 8 times 2/3 is 16/9. Kind of weird numbers, right? And I actually don't need to do the negative ones. That's not going to fit anything substantial that I can fit. So 9, 6, 4. Where the heck is 8/3? That's 2 and 2/3. So 2 and 2/3. But notice how the improper fraction helps me get the other. 16/9 is 1 and 7/9. 1 and 7/9. And the next one would be 32 over 27, which is 1 and 5/27. You can see that it's kind of a cooler looking one. And, at what point should my students stop? I kind of let them go with the flow. It's okay if they stopped a little early. The 2/3 was punishing enough. Negative 2 times 4 to the x power. That sounds like one I've done before. It's not an intentional repeat. It's not like I didn't change the problem. It's just I run out of problems to do. Negative 2 times 4 to the x power. Yeah, that looks kind of familiar. We talked about that negative 16 and stuff. Maybe it didn't start at negative 2, though. Anyway. There it is. I didn't even talk about it. All right. All right. Skill 19. 16 to the x plus 2 equals 32 to the x minus 1. All right, this one's a little different. I can't raise 16 to a power to get 32. Not as an integer, though, at least. This time, you need to find a base for both of them that would work. Like, can I raise 4 to a power to get 16 and 32? Yes for 16, no for 32. Can I raise 2 to a power to get 16 and 32? Yes. So this problem's tough. 16 is 2 to the 4th power. 32 is 2 to the 5th power. We're still not done, but that's where it starts. 4 distributes into these. 5 distributes into these. Now the bases match. Now you can set them equal. So 4x plus 8 equals 5x minus 5. So hopefully you saw what I did. Your goal is to match bases. I mean, most of the time you get to say, like, oh, this side with the exponential term, you just got to find to raise it to whatever. It doesn't always work that way. Subtract 4x, add 5, you get 13. Okay. All right, solve 6 to the x plus 7 equals 8. Subtract 7 from both sides, 6 to the x equals 1. Don't divide by 6. What can I raise 6 to a power 2 to get 1? The same thing as any of them. 0. Now that's something that, again, I might not have asked a question like that. But what are all these y-intercepts about right here? Raising to the 0 power for this to become 1 and go away, right? So that's really important that you know that, you know? Anyway, this x is 0. X equals 0. Okay, let me change the colors on that and stuff. Actually, let me move that, because let's do this next one. I think I gotta use the bathroom soon. All right, find the length of AB and find the midpoint of AB. All right, I'm totally gonna use the graph for this one here. Let's go. Whoa, I used the wrong. I must have hit a different button. What am I doing? All right, let's do that. Little dotted lines. Okay, let's find those distances. They look like even distances. I can't tell. 1, 2, 3, 4, 5, 6, 7, 8, 9. And 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Oh, no, they're not the same. All right, 9 and 10. Let's make this all green. Okay. Did you find the distance? So 9 squared, so like a C. 9 squared plus 10 squared. That's 81 plus 100. So that's 181. And the square root of that's just whatever. It's irrational. I don't... Probably a prime number, too. I don't know. I'm not going to try. But I don't know if there's a perfect square factor. 9's not. I don't think there's a perfect square factor that exists, even if it wasn't prime. Because I don't think 49 works or anything like that. All right, let's find the midpoint. Now, midpoint for me, I'm going to do half the distances. So what's half of 9? 4.5. 1, 2, 3, 4.5. Now let's go over 1, 2, 3, 4, 5, which is half of 10. And boom, I land on that point. That's 1 comma negative 0.5. I'm going to be done with the problem. I'm good there. So, you know, you can use graphs to help you out. You can average your two values. I gave them to you. Half of negative 4. Yeah, that works out. All right. Okay. What's kind of nice was I didn't have to count how far to go over, you know, because it's going to hit the spot, but it confirmed that it hit the spot at the same time. Oh, my back. This reminds me. Oh, if you find this exact gesture that I'm doing right now, this reminds me of, I probably will take a break and use the bathroom. This reminds me of we did finals last year, final review, and I was teaching these long review things, and in my IM3 final review, I was doing that. This thing is gripping. It's like there's something in my nerves that when I'm doing this position all the time, use this muscle, I'm getting grip. It was first my neck, and then it's just like the shoulder blade area. So it's happening again. Oh, so I'm probably gonna take a 3-minute whatever bathroom break and then come back in. I'm gonna feel this though. For a while. You're going to see me do that gesture again when I feel that. All right, treat both problems independently of each other. Now, I remember this problem suddenly because it's more recent. This, okay, x plus 3. Okay, I'm going to write these down. X plus 3 and 2x minus 19. Okay, that information was meant to be on the diagram so it could work for both problems, meaning I'm going to completely take out that information. So number 1, use the diagram and this information to solve for x. Okay, so nk is 23. This is for number 1. X plus 3 plus 2x minus 19 equals 23. You know what else hurts is this this guy on my finger. I probably did this last year too. This all now sounds familiar. That dent on my finger. Just from writing on this thing the whole time. I haven't done videos in a while. I don't know what my last video was. I think the last video I did is actually private. It's a Q&A for my students. 3x minus 16 equals 23. Add 16 and divide by 3, you get 13. Okay, solve for x. Okay, that was number 1. Now I'm going to erase the 23 because that only applied to number 1. This information still applies to number 2. L is the midpoint of nk. I don't care if it looks like it or not. It is. So congruent, congruent, find nk. X plus 3 equals 2x minus 19. Subtract x. Add 19. X is 22. Find nk. Nk is the whole thing. So I could plug 22 into this and add them, or plug 22 in just one of them and double it, because it's being the midpoint isn't just about these being congruent, it's about being half of it. So nk, so check this out. Nk, let's do 22 plus 3, and let's double that. Take that, because I'd rather not do 22 times 2 minus 19, all that. 22 plus 3 is 25. 25 times 2 is 50. And that is the length of nk. Okay? Okay. All right, treat both problems independently. Same thing, use the diagram. Measure of angle ABC, the whole thing is 60 degrees. Find the measure of angle DBC. Oh, okay, yeah. I was going to say, if it's a bisector. No, it's not. So, 4x, let's change colors. I'm getting blue blind. 4x plus 10 plus 12x plus 2 equals 60. 4x plus 12x is 16x plus 12 is 60. Subtract 12, 16x is 48. Divide by 16x is twee. Not done. Measure of angle DBC is, here's DBC. So we're going to do 12 times 3 plus 2, which is 36 plus 2, which is 38 degrees. Ah, hurt my finger. 38 degrees. All right. Now BD bisects angle ABC, and it looks it as well. I'm glad, because I don't like when they don't look it, because people don't like it when it doesn't look it. So, all right. Solve for x. So these are now the same. 4x, and you got to ignore this 60 now for this next, question, right? The 60 was just for the first one. 4x plus 10 equals 12x plus 2. Subtract 4x, you get 8x. Subtract 2, you get 8. And x equals 1. And that's it. You can double check. 4 times 1 plus 10 is 14. 12 times 1 plus 2 is 14. They should be the same. All right. Skill 23. Are the lines to the right perpendicular? Compare slopes. Now, perpendicular means they intersect at a 90-degree angle. I'll be honest. You look at this thing, they look like they do. You can't go by looks. They might not. I honestly don't even remember the answer. But they might and they might not. So you got to compare. So I say compare slopes. Literally, we got to do that. So let's find the slope between these two. And it's by counting. We're going to make it a rise over run. We're looking for opposite reciprocal slopes, though. So this is a rise and a run to the right. So it runs 2, whereas it rises 1, 2, 3, 4, 5, 6, 7, 8, 9. Rise of 9, run of 2 for one of them. The other one falls 2. That's a good start. And let's check that run. Down 2 as it runs to the right. 1, 2, 3, 4, 5, 6, 7, 8. So it runs 8. Now, it looks like it's not going to be the same, but I did want to state that, one is positive, one is negative. You are going to have to know in that scenario, this is a negative slope and a positive slope. That's how it works. Now, it also reduces to negative 1/4. Regardless, that's a 9 over 2 and a negative 2 over 8. If that was a 9, great. It's not. And they're not the same. So I was looking for, well, it doesn't matter. It's not, is it parallel, perpendicular, or neither? Is it perpendicular? No. No. Comparing the slopes. Obviously not parallel. All right. Write an equation for the line in slope-intercept form parallel to this and containing that point. So to be parallel, we need to find its slope. And we said this in the last thing. The slope is not 3. We have to get this in slope-intercept form first. Divide everything by 2. We get negative 3 halves x plus 3. And again, the plus 3 part doesn't matter, but the slope does. This slope is negative 3 halves. We need to use that. Y equals negative 3 halves x plus b. So we're going to use that. We're going to substitute negative 4 for x, excuse me, 4 for x, negative 1 for y. Negative 1 equals 4 times negative 3, excuse me. It is that. I'm just going to write it differently. Negative 3 halves times 4 plus b. 4 times 3 is negative 12. Divided by 2 is negative 6. Negative 1 is negative 6 plus, yikes, plus b. That's a 6. Let's do that again. Is negative 6 plus b. Much better looking. Add 6, you get b is 5. So this equation will be y equals negative 3 halves x plus 5. Here's the thing. We needed to get it in slope-intercept form anyway. So you might as well get the other one in it as your working slopes. But the slope was not 3. It was negative 3 halves. Okay, we're not done with the quiz, though. We still, and skill 27 is coming up. I keep forgetting, new skill. All right, 24. What is the name of the angle pair relationship for angles 2 and 7? Those are alternate exterior angles. If the lines are parallel and measure of angle 7 is 57 degrees, what is measure of angle 2 plus measure of angle 7? Well, alternate exterior angles are congruent as they look it. One's 57, the other's 57. 57 plus 57 is 114 degrees. Skill 25. Lines M and N are parallel. Solve for x. And then solve for y. Now, x, I'm not going to use y to solve for x because I can't. But, and I don't know if the marking helps, whatever, these are congruent. 2x minus 10, 6, or whatever. So I'm going to set those equal and solve. Okay, now I'm not treating these problems independently of each other. What I got for x, I can use to solve for y. So x is 25, not degrees, but 25. So I plug in 25, and here I'm going to get 40, which also means this is 40. 2 times 25 is 50 minus 10 is 40. All right, so solve for y. Now y is a linear pair with this angle, which means they're supplementary. It's the same side interior angle with this angle, which means they're supplementary. These are supplementary. I need to make an equation that says y plus 40 equals 180. So y is 140, like that. Mistakes that are made with that, generally, you know, some people would set them equal. They say y is 40. Some people would, they'd get 25, right? But they'd say 25 plus y is 180. Ooh, you got to plug in 25 for x and then evaluate that, right? So, got to be careful. Okay. Skill 26. This is the one that we did before. It's a different kind of question now, though. Or these questions are a little bit different. Solve for x in both of these. This is a pentagon, 5-sided shape. Got to solve for x. Now, these all add to a certain angle measure. All pentagons add to the same sum for its interior angles. They might not all be the same measures, but they all add to the same amount. D equals 180 times n minus 2. In this case, 5 minus 2. D is 180 times 3, which is 540 degrees. That is not x. That is what these all add to. So x plus 120 plus 95 plus 96 plus 120 equals 540, right? That's its interior angle sum. It's an irregular pentagon, but it still adds to 540. All right, 240 plus 191, 431. If I did this right, it's one of those things where if I get it wrong, super apologies. But once you know the setup, you can try and find it on your own. Even if I'm wrong. You can double check, and if you go, nah, Mr. Robinson, you computed something wrong. I just did that in my head. I might be wrong. I hope I'm not. All right, solve for x here. It's another pentagon. See? 1, 2, 3, 4, 5. Well, what the heck else are we looking at? We're looking at 5 different exterior angles for this pentagon. What do the exterior angles add to a pentagon? Is it 540? No, in fact, it's 360. It's always 360. Exterior angles always add to 360. So, what's x? You add x with these. set it equal to 360. 70 plus 60, 130, 235. X plus 235 equals 360. I hope that's right once again. X is, subtract 235 is 125. Does it look like 125 maybe? Something else you could do. I wouldn't, but 70's supplement is 110, 60's supplement is 120, 65's supplement is 125. You can basically get all the interior angles, and then this is 180 minus x, and then add those and set it equal to 540. You should get the same answer for x, but I wouldn't do that. But if you knew nothing about exterior angles, then I would do that, right? You need to know what you know. All right, new skill, 27. Now, 27 will also apply with 29, triangle congruence things. I want to find ways to kind of go quickly with this, but also make sense of it. First of all, triangle congruence is a massive part of geometry and proofs. If you find out triangles are congruent within figures and objects and things like that, it can open up so many possibilities and properties. So many things exist as a result of it. This is one thing I just want to make mention of. So when you hear proofs and you're like, why do we do these, whatever, you're practicing good math skills, but there are also math skills that apply heavily to geometry. That's the first thing. Second thing, congruence. You've heard them for angles and segments, right? We said this segment is congruent to this segment. This angle is congruent to this angle. Congruence is equal in size and shape. Those were for individual parts, though. A segment congruent to another segment. And we see, just in the individual markings right now, I can see that this segment is congruent to this segment. They're equal in size and shape. That's fantastic, right? This angle, and you can tell by the arc marks, double arc mark, double arc mark. These are congruent to each other. And then these are separately congruent to each other, right? But they're talking about triangles being congruent to each other. If congruency is all about equal in size and shape, it's not just a segment that needs to be congruent to another segment or an angle to an angle. If a triangle is congruent to another triangle, then that means that their triangles are congruent. Every part of them. Not that they're equilateral triangles or anything, but there's a part in one triangle that's going to be congruent to another part in another triangle for all 6 parts. For these two angles, heck, these two angles, these two sides, and heck, these two sides and these two sides. If the triangles are congruent to each other, all 6 parts are congruent. Because they're identical triangles. They might have different names, though. So, are these triangles congruent? Well, you only see 3 sets of parts that are congruent. These 2 sets of angles, these 2 sets of angles, and these 2 sets of sides. So are the triangles congruent? You might say, well, no, because these aren't shown to be congruent, and I get you. I see where you're going with it. But the cool thing about triangles is you don't need to know all 6 parts are congruent to know they're congruent. That doesn't mean that just because one set is congruent, they're all congruent, but there's a bare minimum amount that you need. And I'm going to write these 5 things down. It's going to look weird. I mean, hopefully if this is a final review, sort of quiz things. Hopefully you've seen these before, so it's not like I'm teaching it to you for the first time, I hope. But hopefully you're hearing it out in case you don't understand this. What the heck did I just write out here? This stands for side, 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 angle, side, angle, side, angle, 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 side, and HL. Honestly, I'm not going to talk very much about HL with you guys. I'm going to talk about the first 4. A lot more. HL only exists in right triangles, and it doesn't always even apply to right triangles. So let's bother with the first 4. If you knew that all 3 sets of sides were congruent in in 2 triangles, then both triangles are congruent. You don't even need to know the angles are congruent. It's enough information. It's convincing evidence. I'm not going to talk about why it is. It's just believe it. Trust it. It's true. If only 2 sets of sides were known to be congruent, these 2 and these 2 right here, that's not a guarantee that those 2 triangles are congruent. You need the 3rd set of sides. If 2 sides are congruent and the angle in between those 2 sets are congruent, those triangles are congruent. If 2 sets of angles are congruent and the side in between is congruent, then they're both congruent. If 2 sets of angles are congruent and the side outside of those angles are congruent, is true. And for right triangles, if the hypotenuses are congruent and a set of legs are congruent, then they're both congruent. This is a case of angle, angle, side. The two sets of angles here are congruent. The two sets of angles here are congruent. The two sets of sides outside of those angles are congruent is an angle side case verifying that these two triangles are absolutely 100% congruent to each other. These are the bits of enough information. Notice that angle is not on here. Notice that angle side is not on here. Notice that no two-part ones are on here. HL is an exception, but that's for right triangles, so it's technically 3 parts. That's not on here. Those don't work. Not enough information. These are. These are. If you ever see my video things, if you're one of my students, you always hear me equate things to murder. What do I mean by that? I mean that if in a court case, and you need a lot of evidence, you absolutely do. It's not just 3 things, unless like a confession's one of them, whatever. But you need enough information to convict somebody of murder. Maybe it's not everything. Maybe you don't have video of it, but you need enough of it. This is enough of it, okay? Are these two triangles congruent? Yes. They're congruent by angle side. Now, a triangle congruency statement is another thing entirely. It's important. This is going to be important for later. Corresponding certain parts. Triangle WXY. WXY. This is the first letter, second letter, third letter right here. Triangle FHG. Excuse me. I'm jumping ahead of this. I need to write this other triangle in a very specific order that corresponds parts to each other. The triangle congruency. I can't just use any old order. I can't just say, oh, this was alphabetical. Let's go alphabetical, FGH. That's actually going to be incorrect. W clearly corresponds with F. They're congruent parts. You look at segment FH and segment WX are congruent. So you go to H next with X and H are corresponding. Then up to Y, that single Y is with G. You can tell by the arc marks. They correspond in this way. W corresponds with F. W is the first letter. F needs to be the first letter. X is the second letter. H needs to be the second letter. Y is the third letter. G needs to be the third letter. 1, 2, 3 like that, right? You don't need to write the 1, 2, 3s. That's the triangle congruency statement. That's the reason. These triangles are congruent. This is how. They're guilty by that, all right? All right. Triangles are congruent for those reasons, right? Sometimes you need to prove that. Sometimes you need to make 2-column proofs. That'll be skill 29. That'll be down the line. We'll get to those. Select what additional information is needed in order to know that triangle PRQ is congruent to triangle YWQ by side angle side. So they're giving us a reason to make this work. Now this one, this quiz came in with my students having practiced this beforehand. So let's say this. You see a set of sides congruent, PQ and YQ. That's given information. There's other information you can explore and find to be congruent. Remember vertical angles? 2 angles that are opposite each other when 2 lines intersect, such as these two. These 2 angles are congruent to each other. I found that information for them, right? I discovered it. It's like me finding the gun in the house. I found that. That's not needed information. That's me finding information. You know what I mean? There's a difference. Oh, my TV turned off. You're not watching baseball. Let me turn that back on again for you. I'm sorry. That was probably a long time ago, or maybe just recently. Anyway, those are congruent. This is still not enough information for the triangles to be congruent. This is, I need more information. I can't find any more information than this. That's all I could find. What else do I need? For side angle side, I have side, angle. I'm going to need the angle to be in between the congruent sides, which means I need these to be congruent right here. I need segment RQ to be congruent to segment WQ. That's what I need. That's A. That's what I need for side angle side to work. I don't have it, but that's what I would need. Hopefully that makes sense. And that is the beginning of skill 27. Okay, I'm going to take a quick bathroom break. Hold tight for the 1 second that I'm paused. All right, I'll be back. Okay, I took a slightly longer break, so it was a little hot in my room, so I just like air it out. All right, it doesn't matter for you guys. Let's just keep going. Week 14. So let me quickly see. Let me think. I got 14, 15, I think 16, 17, and 18. So I have several more still. 18 only does 5 skills 26 to 30. So I have a few more to go. All right, determine which of the following sequences are geometric. If so, state the common ratio. I remember there's a mistake on one of these. I think it's C. I think I meant for this to be true. You know, my goal isn't to trick people with these problems. So, like, on C, you know, it's not like, hey, this one works, this one works, this one works. Oh, it doesn't work there. That would kind of suck. All right, which of the following sequences are geometric? Now, you're looking for a common ratio. Doesn't matter what other kind of pattern this has. Like, this has like a +2, +3, +4. Great. There's no common ratio. Not geometric. Times -2 each time. Yeah, yes. R is -2. And then right here, if that's 1/8, it divides by 4 each time, or times 1/4 is really what we need. Yes. R is 1/4. Obviously, if it still said 1/16, then I guess it's not technically geometric because it breaks, which is not what we want. State the first term in common ratio for a sub n equals -11 to the n minus 1 power. This one's tricky. This one's really tricky because, first of all, there's only one number. We've talked about that. The real question, though, is what is being raised to the n minus 1 power? Because it's not -11. For order of operations to make sense, this is why parentheses always matter, right? There's a difference between -11 to the n minus 1 power and, excuse me, not that, and -11 in parentheses to the n minus 1 power. And this is not that. This is that one, which means if I put parentheses, it would look like that. So the tricky part about, and listen, you can plug in numbers and use the calculator and figure out what happens. Your sequence will do this. -1, -11, -121, -1331. Now can you tell me what the first term in common ratio is? The first term is -1 and the common ratio is +11. This looks like that. And the number in front of this is a -1. I think I've brought up some of those before, but that's what this is. That's kind of all I want to say. I don't want to spend a long time on the skill, so that's what I want to bring up. Tricky, but that's what we're doing. The equation y equals 350 times 1.017 models the value y in dollars of a comic book T years after its purchase. What is the yearly rate of appreciation of the comic book? How much is it increasing by each year? So this is that 1 plus 0.017. And that's your R value. You shift it 2 decimal places over. That's 1.7% appreciation. It's B. What is the value of the comic book after 30 years? Let's do money, 2 decimal places, all that. So y is 350 times 1.017 to the 30th power. So 350 times 1.017. 580.36. Did you get that? 580.36. Okay. Skill 18, graph y equals 6 to the x power. So this goes right back to what we were saying on this, like this one right here. And a problem that we've done like this before. This is 1 times 6 to the x power. So 1 is the y-intercept, and 6 is your growth factor. Times 6 is 36, divide by 6 like that. So, you know, when I run out of kinds of problems that I can do, you start to get problems like these. At least without repeating, because I only have so many points in my window range. -8 times 2 to the x power. That looks like something we've done. But that's okay. Let's do it again. Times 2. It's just a matter of the students who do it here. If they did it before and got it wrong, can they build off of it next time? Do they learn the material? So it's no intent to keep repeating it over and over. If this is a problem we've done, I don't actually know. But there it is. All right. Okay. Skill 19. Solve 100 to the x equals 1000 to the 2x minus 1. This one does go back kind of like to the thing that I think it was the last skill, the last quiz, where we have to find a matching base for both parts. We can do 10 squared over here and 10 cubed over here. You know? 2 times x, that's what we do here. 2 times x is 2x. 3 distributes into the 2x and the negative 1. Like that. Set the exponents equal. 2x equals 6x minus 3. I'm going to subtract 2x. I'm going to add 3 and divide by 4. You get x equals 3/4. Not an easy problem, especially with a fraction at the end, but can you do it? Okay. Subtract 1 from both sides. Negative 3 times 2 to the x power equals negative 48. Divide both sides by negative 3. 2 to what power is 16? 4. I'll leave it. All right, skill 20. Find the distance between the points 8, 0, and 0, 15. Well, what's the distance between 8 and 0? 8. The distance between 0 and 15? 15. 8 squared plus 15 squared equals c squared. That's going to be 64 plus 225, which is 289. Now, the square root of 289 is exactly 17. So c is 17. Find the midpoint between the points negative 520 and 510. I'll tell you what, I was throwing them a bone this week. Maybe I felt a little flustered over some of the ones that they had before. What's halfway between negative 5 and 5? You can tell me. 0? Yeah. What's the distance? I can make this ASMR. I'm not going to try, but I'm going to just like ask you like that. What's the distance between 20 and 10? Oh, did you say 5? Sorry, 5 is half the distance. Oh, did you say 15? 15? 15. 0, 15. Now you have to write as an ordered pair, all that kind of stuff, but hey, I need the answers. Negative 5 plus 5 over 2. 20 plus 10 over 2. Good. Skill 21. Now, honestly, when I go over the quiz with my students like that, that's the kind of thing I do as well. I just ask them at that point. I'm like, look, we're averaging. We're finding middle values. We're finding middle values. That's what we're doing. G is a point on segment FH. It's not drawn. Let me draw it. That was weird. G is a point on segment FH. If FG is 2x, it's the length, GH is 9x minus 9, and FH is 13, what is the length of GH? All right, 2x plus 9x minus, equals 13. Combine like terms. I'm going to add the 9 over right now. And I get x equals 2. GH is 9 times 2 minus 9, which is 9. All right, K is the midpoint of segment JL. Okay, congruent. JL is 2x minus 4. That's the whole thing. Careful there. 2x minus 4. KL is 2x minus 8. That's one of them. Solve for x. So this is 2x minus 8. I guess so is that, right? Two of them add to the whole. So 2x minus 8 plus 2x minus 8, or double it, equals 2x minus 4. That's 4x minus 16 equals 2x minus 4. I'm going to subtract 2x, add 16, and divide by 2. I get x equals 6. All right. Skill 22, treat both problems independently. Measure of angle MAR, whole thing is 124. I'm just going to put it right here, 124. Find x in that figure. So I'm going to go 6x minus 11 plus 4x minus 25. And that's going to equal the 124, which only applies to the first part of the problem. These apply to both parts, I guess. 10x minus 36 equals 124. I'm going to add 36 and divide by 10. Okay, the next part, if AD, so AD is not drawn, A is there. AD bisects measure of angle MAC. So let's get rid of this 124 guy. This gets bisected. That's not really well done, and there's blue. Okay, so let's say that's AD, right? It bisects measure of angle MAC, and measure of angle MAD, this guy is 43 degrees. Now, 6x minus 11 is still all of MAC. You have to remember that. Solve for x. So this bisecting means this and this are congruent. This is pretty much irrelevant. I don't need that anymore for this problem. 6x minus 11 is the whole. 43 is half. So if I double 43, I get 6x minus 11. 86. Oh, this isn't a clean number. This is 97. So x is 97 over 6. All right. Funny. Still the answer. But that's it. Maybe at one point I imagined it was going to be 43. Then it'll make 54, and x would be 9. But that's not it. Oh, I just felt that pinch. But x would be 9. Not it here. All right. Line B has a slope of -3/7. Line C is perpendicular to line B. What is the slope of line C? Well, we need the opposite reciprocal. It's 7/3. Write the equation of the line passing through 0, -4, and is parallel to another line passing through the points 5, 10, and 9, 1. Okay, so this time I don't have the equation of the other line to find the slope, but all I need to do is find the slope. So for these ones right here, and I'll tell you something in a moment. These ones right here, what I do is I find the slope. y2 minus y1 over x2 minus x1. 1 minus 10 over 9 minus 5. What I was going to say was I distinctly remember, I don't remember this the first question that I asked it. No, I think I did something for, okay. So this was around, so ChatGPT had already come out. I knew nothing about it. I just heard that it existed. People had talked about it. I never searched it up, never knew it was an app or website. Still don't know if it's an app. I know it's a website. Anyway, this is -9/4. And it was on this day that I tried it for the first time. I was testing its limits of what it could do. Not like write me an essay, but questions I could ask it in math. So I wanted to ask it a question about proofs, triangle proofs, or something, triangle congruence. And I copied and pasted this question into here, and it got it right. It explained everything, but I just remembered distinctly, like saying, like, first thing you got to do is find the slope. To get the slope, you got to do the slope form. And I remembered that's the first thing ChatGPT told me as well. So it was just anyway, I just wanted to bring it up. So first thing we found was the slope. We need the line parallel to this, so we are going to use this slope. So in y equals mx plus b form, we have this. Now here's the other part that I'm going to call attention to, because you know you can plug in 0 for x, -4 for y. But if you also know that the y-intercept is the value of y when x equals 0, -4 is your y-intercept because x equals 0. So y-intercept is -4. We need the equation slope-intercept form. That's it. I mean, if you plug in 0 for x, you're going to get -4 for b. In -4 for y, I should say. You're going to get that. But I don't need to do more. That's it. All right, skill 24. Name a pair of corresponding angles in the diagram to the right. This is there are 4 different options. There's angle 1 and angle 5. Take a look at where they are when I say them. Or angle 2 and angle 6. Or angle 3 and angle 7. Or angle 4 and angle 8. If line A is parallel to line M and measure of angle 4 is 131 degrees, what is measure of angle 6? These are same side interior angles. That makes them supplementary. So 4 is 131. The measure of angle 6 with it adds to 180. Subtract 131. Measure of angle 6 equals 49 degrees. All right, solve for x in the figure to the right. So we have this figure. We have alternate exterior angles in this guy and this guy. So alternate exterior angles are congruent when these lines are parallel. So we're going to say 8x minus 12 equals 5x plus 18. I can subtract 5x and add 12 and divide. Yeah, 10. All right, find the measure of angle GKL. Now that is, oh boy, that is this GKL. Measure of angle GKL is right there. It's unmarked. I marked it, but it doesn't have an expression on it in the figures right after solving for x. So no matter what you solve for x, you can plug it in and do the right thing. How do you plug in x to do this is the next question. So GKL is a linear pair with GKE. So whatever GKE is, like this guy right here, you got to do the 180 minus thing. So measure of angle GKE, got to kind of be inventive on that problem. So 68 degrees. But again, it's the thing, you have to use your answer. So maybe you get a weird answer, whatever. You got to use it. I mean, you got to use your x. So 68 degrees. So measure of angle GKL plus 68 is 180. Right? They're supplementary. Linear pair. They're supplementary. And that's 112 degrees. I hope I got 68 and stuff correctly. That seems right. Okay, skill 26. This goes back to our polygons. Solve for x. This is a quadrilateral. It's a four-sided shape. Now, all quadrilaterals add to 360 degrees. D equals 180 times 4 minus 2. You might know that rectangles and squares do because they're all 90-degree angles and there are 4 of them, which means so does this trapezoid-looking thing. And actually, it is a trapezoid based on these numbers. But solve for x. So we're going to add those. X plus 2x plus 2x equals 360. 2x, what is it? 6x. So x is 60. Technically, I should be 60 degrees because they don't give the degree symbol, but I didn't say find a measure. So I'm good if they didn't. I didn't mark them wrong. These have the degree measures. Solve for y. This is the remote exterior angle theorem. If you recall, this plus this equals that. The outside exterior angle that's remote to those two. Remote means distant. This one's adjacent. These ones are remote. So 4y plus 7y plus 6 equals 116. I got 11y plus 6. I'm getting 10. You feel it? I'm kind of keeping the algebra there so you can see it. All right. Skill 27. This goes back to the triangle congruent stuff. Then I'll teach you 28. 28 can kind of do a lot of different things. If triangle GTA is congruent to triangle SMK, Grand Theft Auto, Super Mario Kart, what segment is congruent to segment KS? Now, this diagram doesn't have to do with it. This is different. This is just its own thing. Remember, the letter order matters. 1, 2, 3, 1, 2, 3. The triangles are congruent, therefore their corresponding parts are congruent. You're going to hear a lot about that later. But you're going to hear about it right now as well. Without me drawing, I could draw the triangles, but without having the triangle drawn, I can determine what's going to correspond based on the congruent statement. KS, K is the third letter, S is the second letter. In this triangle, A is the third letter, G is the second letter. You know what segment is congruent to this one? Segment AG. By the way, you can put segment GA and you're fine. You can reverse a segment order letter, GA, segment AG, and that's fine. I'd rather write things in congruent in corresponding part form, but that totally works right there. So that is the answer without drawing it. Now you can make your own drawing, but that's where they would correspond. Okay, make a triangle congruent statement for the figures to the right and support it by a theorem. So you can kind of make your choice on how you do this. It's a little open-ended. Let's say I said triangle ABC for the first one. I go alphabetical. Okay, now let's correspond this. ABC starts with A, goes across the single tick mark, and then the third tick mark as far as ABC goes. Obviously, it comes back the 2, but as far as writing this goes, let's start for one that goes across the single and then the triple. That's from L to M to K. Triangle L, M, K. That is the congruent statement. That is one of them. I can say triangle ABC congruent to triangle LMK. Ready for 5 others? I can do triangle ACB is congruent to triangle LKM. Triangle BAC is congruent to triangle MLK. Triangle BCA is congruent to triangle MKL. Triangle CBA is congruent to triangle KML. And triangle CAB is congruent to triangle KLM. any of those work. Those are the only 6 that are good. Now, what reason? Side, 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 side. Side, side, side. 3 sets of corresponding sides are congruent to each other. That is a reason to know those triangles are indeed congruent. That's one of the 5 triangle congruence theorems we can use. Okay. Skill 28. This is logic and properties of congruence. I don't know how many properties of congruence there are, but logic statements. Where you have a statement, it can be math-based, it can be English-based, what have you, and we can work its conditional statement. It's an if-then thing. You can see this one, if, then. There's a hypothesis and a conclusion. Hypothesis and a conclusion. And there are ways that you can, they're not always true. They're not always true. They can absolutely be false. And so can their converse, and their inverse, and their contrapositive. What the heck are those things? Let's say that this was P represents your hypothesis. Q represents your conclusion in an original conditional statement. Meaning, if P, then Q. Hold on. Let's do that again. If P, then Q. If P is Q, then Q is true. If P is true, then Q is true. I don't know if that's a true statement. If I hypothesize P, then I arrive at Q. If you take the converse of this statement, what you do is you reverse the Q and P, the hypothesis and conclusion. Now your conclusion becomes your hypothesis. If Q, then P. Inverse is if you negate the statements. If not P, then not Q. If P is not true, then Q, or if P is not met, or whatever, sorry. If not P is true, then not Q is true. And then something called the contrapositive. If not Q, then not P. I want to do an example that's not this one. Okay. If it is a fire truck, then it is red. Let's say that was actually true, just for the sake of argument. I know a lot of blue fire trucks, whatever. If it is a fire truck, then it is red. All right, that can be the conditional statement. Let's take the converse. If it is red, then it is a fire truck. Sorry, let's say a red vehicle. If it's a red vehicle, then it's a fire truck. Not necessarily true, right? You can use a little sports car. You can do something else. Inverse. If it is not a fire truck, then it is not red. No. And then contrapositive. If it is not red, then it's not a fire truck. If all fire trucks are red, then that would be a true statement, right? Because if it's not red, it couldn't be a fire truck. Fire truck has to be red. So anyway, that's what those mean. That's one part of the logic stuff, the conditional statements and the way that you can flip them and negating them and contrapositives. And counterexamples. When I said sports car, a sports car is a counterexample to the statement if it is, what is it? If it is red, then it is a fire truck. No, not necessarily. Something can still be red and not be a fire truck. Counterexample, some good old sports car. Sorry, I think I just ripped the microphone thing when I was trying to move this. Some good old sports car, right? That's what's known as a counterexample. All right, something else that we talk about are patterns and sequences, not just geometric and arithmetic. We could do that, but also things like strings. Let's look at this number 1 and start talking about these problems. Refer to the following pattern. Monday, Tuesday, Wednesday, Thursday, Friday. Monday, Tuesday, that should say ... And it keeps going. And ask, what is the 102nd term of the sequence? Well, I could keep counting. Monday, Tuesday, Wednesday, Thursday, Friday. 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 But eventually, hopefully, you pick up a pattern. 5, 10, 15, 20. Every 5, I'm repeating this pattern again. So on the 5th day, it's always Friday. 5, 10, 15, 20, 25, 30, 35, 40. That's always a Friday. You keep doing multiples of 5 up to 100. The 100th day is Friday. The 101st day is Monday. The 102nd day is Tuesday. That's kind of one way of thinking about it. I mean, that is the way of thinking about it. But the way to mathematically do that is we divide 102 by 5 because we do multiples of 5 up to 102. So 102 divided by 5, if you work it, you get 25 with a remainder of 2. Now, what does 25 tell you? 25 tells you how many times you cycled through. I'm sorry, that's 20 with a remainder of 2. What does 20 tell you? 20 tells you how many times you iterated through that sequence, that cycle, repeated over and over. You did it 20 times. That number actually isn't that relevant. The 2 is relevant. That remainder states what value you end up on after that. Monday would be a remainder of 1, Tuesday is a remainder of 2, Wednesday 3, Thursday 4, Friday 5. This is where I asked ChatGPT. It actually told me everything about this. Do 102 divided by 5, blah, 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 get a remainder of 2. So it's going to be the second day after Friday in the sequence, which is Wednesday. And it messed up and it was wrong, and I corrected it. And that was my first time going like, I can correct ChatGPT. Anyway, so the answer is Tuesday. The answer is Tuesday because this sequence loops through a cycle of 5 terms over and over. And every 5th term is Friday. So 100 is a 5th term, which ends on Friday. And then 101st is Monday, 102nd is Tuesday. Okay, number 2, write the contrapositive of the following statement, and if it is false, provide a counterexample. All right, here's the original statement. If it is a triangle, then it has 3 sides, which is true, by the way. The counterexample would be, let me type it. My finger's bothering me from being wedged. If it has 3 sides, like a polygon, if it has 3 sides, then it is a triangle. Also true. So there's no counterexample which you can provide. If there was, I can't do an example of a counterexample with this because it's true. But if it were false, then you would provide a counterexample, which you don't. I'll go ahead and state this right now. If you don't know this, if you hadn't understood it, anytime your original statement is true, the contrapositive is always true. Anytime your original statement's false, the contrapositive is always false. Converses and inverses also have equivalent truth logic to them, too. Always. There's never a time they don't. Never. Never a time that they don't. A conditional may be true and converse may be false, that's fine. But if converse is false, so is inverse. If converse is true, so is inverse. Conditional, contrapositive, etc. Just so you know. All right, let's keep going. I'm at 4.5 hour mark. I'm going to be beyond 5 hours for this thing. It is 12:40 in the morning. So here we go. This stuff is going to pop up for me later. I have to do a proof. This is going to be skill 29 where we have to do 2-column proofs. So we'll get there. Let's build into that. Let's go a little fast. Write the explicit rule here. This is where I get to speed up. First term, common ratio, done. Find a sub 10 in the above sequence. Let's go ahead and substitute 10 into that. 9, 10 minus 1 is 9. So that's not an A, that is a 9. Oh, whoopsie, hold on. Going a little fast. Would have been a little better if I was going a little more slowly. All right, negative 7, 8, 6, 4, 3, 2. It'd be cool if I got it to go 8, 7, 6, 5, 4, 3, 2. All right, a metal object cools down at a rate of 10% per minute. The object's temperature is initially 200 degrees Celsius. Write an equation that models the metal object's temperature after T minutes. So 200 degrees Celsius, 1 minus 0.1 is 0.9, raised to the T power. Done. What will be its temperature? What will its temperature be after 1 half hour? The T is in minutes, half hour is 30 minutes. So T is going to be 30. So let's do 200 times 0.9 raised to the 30th power. 1 decimal. This is what I'm asking for. So 200 times 0.9 to the 30th. 8.478. So let's go 8.5. 8.5 degrees Celsius. That thing is cooling. Hold on. Okay. All right, skill 18. Y equals 3 times 1/2 to the x power. Got that back pinch. I was hoping that break would have helped, but it was like a 6-minute break. Half of 3 is 1.5, and then half of that is, where am I? 3 halves, 3/4, and then 3/8. Divide by 1/2, I get 6, and then 12, which I guess would be up here. Try that again. Little precision drawing. Boom. Actually, this is my best one to me. Y equals negative 2, negative 1/2 times 2 to the x power. All right, negative 1/2. We saw one of these before. Like that. Let's do a lot of times 2's. Negative 1, negative 2, negative 4, negative 8, and something. Negative, I guess, a quarter right there. Not one of my best drawings. Actually, it's not bad. All right. Skill 19. Solve. We got to multiply both sides by 2. I'm going to start just by putting that there. Boom, boom. Actually, let's just do this. 8 to the x equals 64. X equals 2, right? 8 squared is 64. But we've got to multiply by 1/2 to start. Or by 2 to start with. All right, solve 9 to the 2x equals 9 to the x plus 5. It's been a minute since we've seen a matching thing to start with. This actually might be the first one. So 2 to the x equals x plus 5. Subtract x, you get x equals 5. I threw him a bone. Tried to give him an easy one. Had to multiply by 2 to start. Boom, boom. But you know what? After that, it's all good. All right, this one was a scan. Use the picture to the right. Find the length of segment BD. So BD's right here. Well, I'm drawing the triangle for it. 1, 2, 3, 4. 4 squared plus 1, 2, 3, 4, 5, 6. 6 squared. So let's go here. 4 squared plus 6 squared equals, that's a good old c squared. 16 plus 36, which is 52. So c is the square root of 52, or 2 root 13, if you are a simplifying folk. Not a perfect square. Find the midpoint of segment AC. I can tell you right now it's going to be right there, because that's, instead of 4 over and 1 up, it's 2 over and halfway up, and that's kind of the logic I'm going with. If you have the graph, work it. That's at 1 comma 1.5. 1 comma 1.5. There it is. Okay. That's all I'm going to do. Skill 21. HJ is 10x minus 2. 10x minus 2. Find the length of IJ. So 20, let's use green. 20 plus 8x minus 6 equals 10x minus 2. All right, 20 minus 6 is 14. Oh, not much room. Subtract 8x, I get 2x. Add 2, I get 16. Divide by 2, I get 8. Find the length of IJ. IJ equals 8 times 8 minus 6, which is 58 units. Okay. B is the midpoint of segment AC. Boom, boom. AC equals 40. One of those, half versus whole. Solve for x. So 2 of these, 2x plus 2's. 2x plus 2's equals 40. You know, I'm going to divide by 2 here. If 40 is the whole, then 20 is half, right? So 2x plus 2 equals 20. And subtract 2 and then divide by 2. We're going to get 9. And they only ask for x, so I'm good. Okay? Skill 22. Treat both problems independently. This might be... it looks familiar. This gave me nightmares. This might be the one that had the negative thing. I don't know if it is or not. Let's see. I think I started the problem some way, and then I didn't finish changing the numbers. All right, measure of angle BAC equals 70 degrees. Clearly doesn't look like 70. That's part of the conundrum. Measure of angle BAD, that's the whole thing. So BAD is 12x plus 6. Yeah, this problem's bad. And then CAD is 20x plus 10. All right, let's see how bad this thing is. 70 plus 20x plus 10. You know, maybe this isn't the problem. 12x plus 6. We'll see. 20x plus 80 equals 12x plus 6. Oh, this is the problem. Subtract 20, you get 8x, or 12, you get 8x equals negative 74. Okay, so x is Negative 74 over 8. Now, this can reduce to negative 37 over 4. Listen, that's the answer. I mean, it's negative 9.25, I think. And this has to find the measure of angle CAD. So now you got to plug in, so measure of angle CAD. Now again, there's nothing inherently wrong with a negative x value. The problem is a negative angle measure, which you shouldn't get in these. You will here. And it's a fraction decimal, whatever, so that sucks too. 20 times negative 37 fourths. I think at this point, one of my students solved for that and kind of gave up, like, whatever, because we didn't change the problem. I was just going to, like, hopefully they just don't do it. Let's see. Let me just compute this. 20, and I'm going to write the decimal version because it's exact. Actually, I don't know if it won't be a decimal. Negative 175. Negative 175 degrees. There's your answer. That was the big, like, ugh. That was the big problem that I just botched and did not go back to. Maybe if this was supposed to be a 10, whatever. But I just messed up. Whatever it was. All right, segment AC, treat them independently, right? Segment AC bisects. So let me get rid of that. I don't know if this is any better. Segment AC bisects angle BAD, or ray AC. Measure of angle BAC is 12 degrees. Measure of angle CAD is 6x minus 4. Solve for x. Yeah, so this one's like, they're equal. X is 16 over 6, which reduces to 8/3. I think I did intend on that one being a fraction. Said, can you reduce it? Like, that's all you're doing. You're done. But this was clearly not someone's forte for their skill. All right. Are these lines parallel, perpendicular, or neither? We have the 4x and the 4x. We've seen this kind of thing before. Which one are they? Remember, this is slope-intercept forms. That guy's slope is actually indeed 4. This one, not so. We got to subtract 4x and then divide by 9. We get negative 4/9. This plus 2, who cares? That slope is negative 4/9. That slope is 4. No relationship. It's just a neither. Neither. Nothing. All right. Write an equation in slope-intercept form perpendicular to this that passes through the point 0, 2. Once again, you have another y-intercept. Your b is 2. Your slope, the original slope is 4. The perpendicular slope is opposite reciprocal, negative 1/4. We have our information. You need m, you need b. You got them. Y equals negative 1/4 x plus 2. That's it. Skill 24. Name a same side exterior angle. I don't know why I hyphenate those. I don't think that's right. Same side exterior angle with angle 2. The same side of the transversal, T, is on this side. The exterior is 8. They're not congruent, but 2 and 8. So angle 8. It's really the only answer on here that works. If measure of angle 2 equals 38, what are measure of angle 3 and measure of angle 4? All right, measure of angle 2, 38 degrees. 3 is a vertical angle pair with it. That'll be congruent. That's 38. 4 is a linear pair with either of those. 180 minus 38 is 142. So measure of angle 4 is 142 degrees. So bim, bim. Neither degrees and all. Both answers. All right, skill number 25, assume A is parallel to M. By the way, vertical angles and linear pairs are always congruent and supplementary without parallel lines. Now, we need them for skill 25. Measure of angle 3 equals 6x plus 42. It's this. Measure of angle 5 is 133 minus 5x, solve for x. These are same side interior angles. Lines are parallel. So angles are supplementary. So 6x plus 42 plus 133 minus 5x equals 180. 6x minus 5x is x. 42 plus 133 is 175. So x is 5. Use your solution to find, use your solution in, solution in to find measure of angle 5. Where's 5? Okay, so 133 minus 5 times 5. 133 minus 25. 108 degrees. It's kind of a nice problem for me to ask you to do, so you don't have to do more of it. All right, skill 26. What is the measure of one interior angle in a regular hexagon? A hexagon has 6 sides. So D is 180 times n minus 2. Oh, excuse me, 6 minus 2. Which is 720 degrees. And that is the interior angle sum of any hexagon. We need the measure of one interior angle in a regular hexagon. So we're going to take 720 and divide by 6 and get 120. What is the measure of one exterior angle in an equilateral triangle? So equilateral triangle, it's basically a regular triangle, if you will. So kind of like that. But we need the exteriors. So like boom, boom, boom. Now they're all the same. So there are a couple ways you can do this. An equilateral triangle has all 60-degree interior angle measures, and each exterior angle is a supplement of the 60, which means they're 120 each. So that's the answer, 120. Also the same as that one before. That was by intent. However, also, the exterior angle sum of any polygon is 360 degrees, and you divide by the number of sides or angles 3, and you also get 120 degrees. So either or. All right, find the lengths of WX and SR in the diagram to the right. In this diagram below, quadrilateral PQRS is congruent to quadrilateral WXYZ. Now this is the congruent, the letter order that matters. The whole 1, 2, 3, 4 bit. 1, 2, 3, 4, 1, 2, 3, 4. Corresponding parts of congruent figures are congruent. They don't just have to be triangles. You just have to know what corresponds. And they look like they correspond. I need the length of WX. WX is the first two letters, WX. So we need to find PQ. PQ is a length of 5. WX is a length of 5. SR. SR is 4.3. ZY. ZY is 8.6. SR is 8.6. Those are side lengths of segments. Find the measure of angle P and measure of angle Z in the diagram to the right. Measure of angle P. P is 1. W is 1. W is 80 degrees. P is 80 degrees. Z, 4S, 35 degrees. Z is 35 degrees. I could have been a lot harsher with these questions and said quadrilaterals add to 360 and that stuff, but it's not really a skill 26 question, so I just wanted to work out those. All right, give a counterexample to the following statement. If a noun is plural, then it ends in the letter S. Fish, deer, men, women, people, bacteria, alumni. See what we're doing? We're moose, geese. We are finding counterexamples to that claim. If a noun is plural, let's assume we're talking about plural nouns. Okay, boom. Then it ends in the letter S. No, let me tell you about other ones that do not, right? So that's kind of where we're going with that. So no, just give one, and then it breaks it, right? Identify which is the converse, inverse, and contrapositive for the following conditional statement. So if a triangle has a right angle, then it is a right triangle, which is true. Remember, this is the if P, then Q. Converse is if Q, then P. Inverse is if not P, then not Q. Contrapositive is if not Q, then not P. So let's see. Right angle, right triangle. So if a triangle does not have a right angle, then it is not a right triangle. That is a not P, then not Q. That is the inverse. So inverse is A. If the triangle is a right triangle, then it has a right angle. That's if Q, then P. That is the converse. And then must be contrapositive. If a triangle is not a right triangle, then it does not have a right angle. That's if not Q, then not P. That is the contrapositive. Whee! Okay. All right. Skill 29. Now this is 2-column proofs for triangle congruence. So We began skill 27 by talking about those things. Now we got to kind of document evidence of them. So I'm really just going to go as much as I can with it. If we're asked to do this, question 1, we're not asked to do that. What does CPCTC stand for? Remember, the words of and are also used. If you don't know the exact phrasing, explain its purpose. All right, well, I'll do both. All right, well, first of all, CPCTC stands for, corresponding parts of congruent triangles are congruent. Corresponding parts of congruent triangles are congruent. Its function is something we've already used. If the triangles are congruent, their corresponding parts are congruent. Parts correspond because the triangle might not be like isosceles or equilateral or whatever. It might be a scalene and very unique looking one, but then their parts, if the triangles are congruent, then they're identical to each other. So I can find one angle here that's congruent to another angle there, this segment that's congruent to this segment, and all that stuff. Somewhere they're in line, even if it's reflected and rotated and all that kind of stuff, it's there. And that's what that whole 1, 2, 3, 1, 2, 3 thing is for, finding the parts that correspond. Now this is used for some 2-column proofs that we do to prove that this part is congruent to this part. First, we prove the triangles are congruent using other means to prove this other thing. I got to get better with my murder analogy things, because I don't prep them beforehand and I don't really think about it. But the murder analogy thing is like, okay, I want to really prove that he was in this location at the time that he murdered her, or whatever. Like, I wanted to know this information. I can't prove it, right? There's something I can't prove with that. Somehow we can still convict him of guilty of murder using all this other evidence, right? But I found all this other evidence that says he is guilty. The jury finds him guilty. It's a slam dunk conviction, right? We find out he's guilty. I guess, therefore, that means that other thing was true. I couldn't prove it myself. I couldn't find it. It wasn't given to me, nothing like that. But I found out that he did murder her. So you know what? He must have been there. He must have been there. And that's weird. I don't know if that evidence stacks up that way, but that's how I'm going to go with it. Anyway, that's CPCTC. Complete the triangle congruence proof on the back of the answer sheet. Now, for them, it was an answer sheet that looks like that. Here's the back. Here's the proof. Given this, prove that. All right, so here's how this works. Now, I'm not going to spend too long. I might, but I'm going to try not to. What's given is also marked. That's not always the case. Generally, you'd have to mark things for yourself. I'm going to pretend like it wasn't there, so I'll mark it for myself. Given angle A is, these should all say congruent. Given angle A is congruent to angle D. Now, these are things that you would document. Even if it's given, you document it. This is like an official, formal writing thing that leads a flow to your proof that you're trying to make happen. Okay, you're writing it down. You're marking it, you're writing it down. It's given that angle A is congruent to angle D. We're going to fill that part out. Angle A is congruent to angle D. That is given. That's the reason that we know this is true. Every statement we make has to be an undeniable proof statement. And sometimes some statements are led from other statements that we have. You'll see those cases if they show up. My students saw a lot of them. Segment AC is congruent to segment DC. How do we know that that's true? Oh, that was also given. Segment AC is congruent to segment DC. So we mark that just like they did. How do we know that? It is given. Those are the only two things that are given. We have to prove the triangle ABC is congruent to triangle DEC. ABC with DEC. Now, this isn't enough information in and of itself. If you remember skill 27, this is all a part of this. We need to do a side, angle, side, angle, angle, side, angle, side, or HL proof with this thing. We're just building up that case and writing it down. Now, the next statement's given to you. Let's see if we can identify as to why that's true. Angle BCA is congruent to angle DCE. I don't like how I corresponded those two things, but yeah, those are also congruent to each other. How come? Is that given? No, they didn't tell us that. We could find that out for ourselves. Those are vertical angles, baby. That's the vertical angle theorem. Vertical angle theorem. Vertical angles are always congruent to each other. That's a slam dunk thing, right? Hey guys, these triangles are congruent to each other. This is an angle side angle case. Angle side angle, angle side angle. I don't just look at these and go angle, side, angle. I got to make sure the parts that correspond are also congruent, and they are. Triangle ABC is congruent to triangle DEC by angle, side, angle congruence theorem. So I know I just walked through this one proof. Let me say some more things. First of all, when they ask you to prove something, that means it can be proven. Like, it's going to be true. They're not going, trick question, you can't actually prove this, you're an idiot, what's wrong with you? Unless they faulted the problem. Their intent is not to trick you on it. You can actually prove it. Second thing, and your intent is to be able to do this on your own completely free of, like, things pre-given. So could you do this for step one on your own? This is one of the more basic ones. Yeah, you had to find the vertical angle thing, but, they told us which ones are congruent. Our proving statement is always the final statement, right? Prove this. All right, I will make that declarative statement. You can't have made it from the beginning. We needed to build into it. Even if you were given all three parts, you still need to lay them out. They still need to be previous statements before. So it's not like you can just say it, like, prove he's guilty of murder. Okay, he's guilty of murder. That's not proof. Right? So, build the case and then make the declarative statement. And there's a reason behind that statement, but that statement was built upon the previous parts. We look at the diagram and we see that angle, side angle case was from this set of angles that led to here, this set of sides that led to here, and this set of angles that led to here in that specific flow. Triangles can be congruent based on these reasons, and the reasons need to be supported. Right? You can't make a statement without a valid reason, and you need to be able to validate that statement with a reason, if that makes sense. Some statements are made out of thin air, if you will. 1, 2, and 3 were all made out of thin air. These were givens. This was vertical angles. These weren't led from previous statements. Statement 4 was made off the backbone of statements 1 through 3. All three of these led to it. I'm going to make that proof. All right, that's our first one in skill 29. I think we only get a couple more because we're moving on forward. So week 16, let me see how many more pages. Yeah, week 16 and then a week 17 and then that week 18. We're going on forward. Okay, skill 16, write the next two terms in this geometric sequence, 81, 54, 36. All right, what are we multiplying by? That's always the question. Let's do 36 over 54. You can divide those, let's just say by 2. You get 18 over 27. You can divide those by 9. Okay, 2/3. All right, that's our common ratio of 2/3. What's 36 times 2/3? 36 times 2 is 72. Divided by 3 is 24. 24 times 2/3. 24 times 2 is 48. Divided by 3 is 16. Okay. Write the explicit rule for the above geometric sequence. Well, that common ratio is important, and that's our first term, 81. So a sub n equals 81 times 2/3, the n minus 1 power. See, somebody might have lucked out and figured out, oh, you're dividing by 1.5. I think we talked about this one before, that kind of problem before. But you can't write 1.5 in the explicit rule, so you still had to come up with the common ratio. All right, you bought $2,000 worth of stocks in 2022. The value of the stocks has been decreasing by 15% each year. What will your stock purchase be in the year 2026, and when will you get out and invest in GameStop? All right, so y equals $2,000 times, so decreasing, 1 minus 0.15, that's 0.85. 85 raised to the 2026. 4 years later, raised to the 4th power. So we'll go 2,000 times 0.85 raised to the 4th power. So I'm getting, we'll go 2 decimals, $1,044.01. Oh, I'm keeping that cent. If I'm going to be losing this money, I want that cent. I want that penny. The intensity of a sound decreases by 4% per second as it travels through the air. If a sound emits at 110 decibels of volume in the air, determines intensity after 6 seconds. It's going to be in decibels. So, initial amount is 110 decibels. It's losing 4%, not 40, but 4. So that's going to be 1 minus 0.4, which is 0.96. Let's raise to the 6th power. So 110. It's becoming less intense. All right. Good. I look forward to that. 86 point... I didn't have so many decimals. Let's just do one. 86 point... It's not 86. Decibels. Good. All right, graph. 10 times 1/2 to the x power. Y equals 10 times 1/2 to the x power. Yeah, this one's going a lot longer than... half of 10 is 5. Half of that is that. And 1 1/4 and 3... Shoot, it should be 3/8. No, it shouldn't. It should be 5/8. That was perfect. I should go off my visuals, not off math. If you're still watching and you hadn't fast forwarded, you are a trooper. I don't know if my videos become recommended for people. There are some videos that if I fall asleep to a video, I'll wake up in the middle of the night, there's some 3-hour something playing, and I see the comments and people are like, you know, like who else woke up to this video? I wonder if my videos are like that, where it's like, hey, hello from your little sleep. Yeah, you've been listening to me. It was recommended to you somehow. I don't think my videos become recommended to people. I don't really tag them, or I'm not really on that. All right, -2, the opposite of 2 to the x. Remember, that's a -1, therefore. That is a -1, therefore. I do wonder if this problem was done before. Anyway, -1, then doubled, and then doubled, and then doubled, like that. And divide by 2, like so. Yeah, if these problems were repeated, then you know what? Kiddos get to practice. All right, so do I. Hope I haven't gotten any problems wrong yet. That'd be nice. All right, solve. 3 to the x plus 5 equals 3 to the 12th power. Clearly what you can tell is there were some students who had some trouble with the earlier ones and had to make it a little bit easier. X plus 5 equals 12. X equals 7, right? Bases match. Do that. Now, they have to solve the next one. Multiply both sides by 2. You know I do my 1/2s. Multiply both sides by 2. 4 to the x minus 2 power equals 256. 256 is 4 to the 4th power. Bases match. X minus 2 equals 4. Add 2 to both sides. X equals 6. All right, skill 20. Use the picture to the right. There is no picture to the right. Just ignore that. Just kidding. I just maybe this is an outdated thing. I'm not sure. All right, fine. That does look outdated. Doesn't this look like... Shoot, I hope I'm not using an outdated file. Let's see what else is here. Give me 1 second. Oh, those don't look outdated. All right, this... No, this isn't outdated. I'm sorry. I was confusing with a different problem. All right, find the distance. All right, there is no picture to the right. Find the distance between the points 1, 6, and 2, 7. Actually, let me go back really fast to the previous one. Have a picture to the right. I just want to know where this came from. Yeah, I just never deleted that statement. Okay, sorry about that. All right, find the distance between the points 1, 6, and 2, 7. What's the distance from 1 to 2? 1. What's the distance from 6 to 7? 1. So we're going to do 1 squared plus 1 squared equals c squared. 1 squared is 1, so 1 plus 1 is 2. C squared is 2. C is the square root of 2. The square root of 2 is not 1. No, it's 1.4 something, something, something. The square root of 2. Find the midpoint between the points 3, -4, and -5, 0. All right, let's do this with the average thing from way back when. 3 plus -5 is 3 minus 5. Remember, I wasn't subtracting. I was adding a negative. And then -4 plus 0. 3 minus 5 is -2. And -4. We're not dividing by 0. It's a little late. Dividing by 2 there. -2 over 2 is -1. -4 over 2 is -2. And that is your midpoint. Okay. 2 different diagrams. This one unlabeled. We gotta write it in. SY is the whole thing. That's 71. sk is 8x minus 17, ky is 4x plus 4. If you're curious on how students write with this little room, they have a front side where they do all their work. So the way I'm fitting this is kind of, I really don't know where to put this. Let's go right down here. All right, we're going to go 8x minus 17 plus 4x plus 4 equals 71. That's 12x minus 13 equals 71. 12x is 84, so x is 7, and that's all they want in the problem, so we're good. Next one, we're going to find the QR. R is the midpoint of QS. So these are equal. 5x plus 2 equals 9x minus 10. Subtract 5x, add 10, divide by 4, and we get 3. QR is 5 times 3 plus 2. 15 plus 2 is 17. 9 times 3 minus 10 should also give you 17 because they should be equal, and it does, and it works out. All right, skill 22, same diagram. Treat the problems independently. So the first one, we got WXZ, that angle being 3x plus 14. ZXY, that being 5x minus 2. The whole thing, WXY, being 10x minus 18. So, these are geometry. You still got to know your algebra. It's basic algebra. It is. But, you got to, if you want to get your 2, you got to get these problems right? 10x minus 18. It's basic algebra. 8x plus 12 equals 10x minus 18. Subtracting 8x, adding 18, and dividing both sides by 2. X is 15. I think we are going to go on official record. It's 5-hour mark. I think we're going to officially, this is going to officially be my longest YouTube video. Maybe it already is. I don't know if I have one over 5 hours. Ray XZ bisects angle WXY in the figure to the right. Oh, yeah, new problem, right? So now we get rid of those. I think so. XZ bisects, so congruent parts. WXZ is 6x minus 7. CAD, okay, so shoot, that's wrong lettering. I think it was supposed to be ZXY. Let's go with that. So this guy here, 2x plus 41. I don't think it was supposed to be the whole thing. That was just another little mistake. Solve for x. So 6x minus 7 equals 2x plus 41. Just solve for x. Oh. I'm sorry. Let me go back to the previous problem. I didn't find the measure of angle WXZ. Measure of angle WXZ. I want to hold my promise not to get anything wrong here. 3 times 15 plus 14. That's 59 degrees. Okay, I got it. See my check? I was going to say, I only have to solve for x here? Don't I have to find the measurement angle? There it is. All right, subtract 2x, add 7, divide by 4. All right, x equals 12. Oh, my back. All right, skill 23. Line D passes through the points 8, 18, and 10, 9. Line E is parallel to line D. What's the slope of line E? Okay, whatever D's slope is, E's slope is the same. So how do you find D's slope? y2 minus y1 over x2 minus x1. Measure of line D is 9 minus 18 over 10 minus 8, which is negative 9 over 2. Slope E, slope of line E is equivalent to slope of line D, which is negative 9 over 2. That's the answer. All right, write an equation in slope-intercept form perpendicular to y equals negative 1/3 x plus 11 that passes through 2, 8. So perpendicular, we need to get the opposite reciprocal slope of that guy, negative 1/3. So opposite reciprocal is positive 3. So we're going to have y equals 3x plus b. 8 is our y that we got to try out. 2 is our x. Let's find the b from that. 8 is 6 plus b, and b is 2. Oh, that's not the final answer, but those are those parts. Y equals 3x plus 2. Far cry from what the previous one was, but they are perpendicular. All right, lines M and N are parallel. Great. Let's go. Name both pairs of alternate exterior angles. Well, 1 and 8 is an alternate exterior angle pair. And 2 and 7. There they are. Lines M and N are parallel, yes. If measure of angle 5 is 100 degrees, what is measure of angle 1? Well, they're corresponding angles. 5 is 100, 1 is 100. They're congruent when lines are parallel. 100 degrees. All right, treat both problems independently on this set here. So, like, if you find measure of angle 6 is that, and it's different here, so that kind of thing. Lines M and N are still parallel. Measure of angle 3 is 5x plus 3. Measure of angle 6, alternate interior, is 9x minus 33. Solve for x. Alternate interiors are congruent. Set them equal. Subtract 5x from both sides. Add 33 to both sides. And divide both sides by 4. Divide both sides by 4. I felt like I was doing like to the left, to the right now, yo. Solve for both sides. 6 and 8, those are a linear pair. 6 and 8, linear pair. They are supplementary. Supplementary. 13x minus 21 plus 5x plus 75 equals 180. That's 18x plus 54. Subtract 54. Oh, goodness. 126. And divide by 18. Another goodness. X is 7. Yeah, 7. And that's it. They just had to solve for x. All right. Okay, skill 26. The sum of the interior angles of a polygon is 900 degrees. How many sides does the polygon have? So, we go back to our d is 180 times n minus 2, but n isn't 900. It's not 900 sides. The sum is 900. So we're going to substitute, instead of for n, we're going to substitute for d, and we can solve for that. Now, dividing by 180 is one thing we could do to start with. I kind of recommend it. Divide both sides by 180 now, instead of distributing, and we get 5 equals n minus 2. Now, 5 is the number of triangles in this shape. It's not the number of sides. I got to add 2 to both sides. N is 7. 7 sides. It's a heptagon. Heptagon. 7-sided shape with 5 triangles. 180 times 7 minus 2 gives us that. Find the value of x in the diagram to the right. The remote exterior angle theorem back at work. 5x plus 2 plus 64 equals 12x minus 4. That is the setup for these problems. 5x plus 66 equals 12x minus 4. Subtract 5x, add 4, and divide by 7. X is 10. Find the value. That's it. All right, state which triangles are congruent and provide the reason. So, like, these are. We can actually pull out some more information. There's the vertical angles, right? We run into those quite a bit. Let me get some water. We run into those quite a bit, and yeah, you got to kind of mark them congruent. It's like they not always are, but they are here. It looks like a side angle side case of that triangle being congruent to that one. Now, you can kind of state your own thing. I like to do alphabetical whenever I can. A, B, C. That doesn't mean this will be. It's not C, D, E. You got to find what corresponds. So A, B, C. I want to cross the no marked step. Like that was completely unmarked. Same with this side. So it's either E, D, or D, E. But then I go across the 2 mark. 2 tick mark. So we got to go, I think, D, E, C. A, B, C, D, E, C. You can see kind of a rotation there. You need the triangle symbols. You need all that. This is side angle side. And we good. Okay, get used to this diagram. This is going to show up in the other side. I'm just going to tell you right now. This question is the same thing 3 times. First it says solve for z. Next time it says solve for y. Or x. Next time it says solve for y. Same question. I mean, different thing to solve, but I feel like I got to sneeze. I'm sorry. Really feel like I got to sneeze. All right. Triangle PHS is congruent to triangle CNF. Solve for Z. All right, I'm writing 1, 2, 3. Come on. Oh no. I'm writing 1, 2, 3 because this is the whole part. CPCTC, corresponding parts of congruent triangles are congruent. These triangles are congruent. The statement tells you that they're congruent. The parts correspond based on the letter order. And the diagram can help you. I can rotate this and one can line up into the other, right? So that's all true. But the corresponding parts are also congruent. When it says solve for z, what you recognize as z is a variable that is in the measure of angle c. C is an angle that would be congruent to P. P and C have the same measure. So I can set 36 equal to 4z minus 32. If I add 32 over and divide both sides by 4, I get 17. That's the answer. So get ready for that for the other ones when we solve for, we could probably do it right here, but when we solve for x and y. Okay, if two parallel lines are cut by a transversal, then alternate interior angles are congruent. Now, I wish I wrote this statement differently. I wish I wrote it to say that the proper form would be if two lines cut by a transversal are parallel, I think. No. Maybe? I'm trying to think about that because I want to think about the proper converse. Okay, I'm going to leave that on the bottom for now. We'll get back to that. Let's see the way that it's written because the way that this converse doesn't really sound right after if alternate interior angles are congruent. See, I don't like the way that that's written. Oh, I'm sorry. This is the converse portion. I'm not even thinking about the top part. I'll get to the top part in a second. I wanted to say then parallel lines are cut by transversal. See, if I use this one, let's see what the converse would be. If alternate, yeah, if alternate interior angles are congruent, then two lines cut by a transversal, yeah, are parallel. I mean, either are converses. The thing is, can you practice writing converses out? It's great. But this is a true statement. And we didn't get to practice this. Not you and I. I did it with my students last year, but not my own students this year. The converse statements are also true. You know when parallel lines have alternate interior angles congruent, corresponding angles congruent, things like that? If you have congruent alternate interior angles, that makes your lines parallel, or that means your lines are parallel. It actually is true. But I like the way that this is stated better because the lines are cut by a transversal, right? They're there, but now we get to state that they're parallel. We're not saying that they are parallel lines that are cut by a transversal. The conclusion isn't that they're cut by a transversal. The conclusion is that they're parallel, if that makes sense. We want to identify that a little better. So this is the way I wish I wrote it to begin with. And because that's the statement I want to try and make. This is the correct converse for that, but it's whatever. Anyway, it's true. It's true. All right, identify the hypothesis of the statement. Remember, it's an if hypothesis, then conclusion. The hypothesis doesn't use the word if. The hypothesis is just this part. Two parallel lines are cut by a transversal. The conclusion is alternate interior angles are congruent. I wish the hypothesis was two lines cut by a transversal are parallel, but that's neither here nor there. Okay, let's skill 28. All right, skill 29. Let's select the letters that match for the proof. I mean, here I can write them out for you guys. There are givens. Now, I don't love this proof for parts that are kind of missing, but that's okay. Segment GH is perpendicular to segment FI. Now, that is a given. How do I mark that? Perpendicular lines means right angles. Now, that's the part that's kind of missing here in the documentation. That's a right angle. That's a right angle. But that is a given. So is the fact that angle HFI, right there, is congruent to angle GFI. Those are both given. Now, you are allowed to write two givens on one statement. I don't necessarily condone it. Depends on what kind of room you have. There should be another statement in between these that says angle, like, see this FIG? Angle FIG, that's this, FIG right there, and angle FIH, are right angles. Now that's a statement. Remember, this was not given. I marked that. Why did I mark that? Why did I mark these right angles? Because they told us lines were perpendicular. That's the definition of perpendicular lines. That would be statement reason. And then, since you have right angles, see, you have perpendicular lines that say you have right angles. Right angles can tell you that they're congruent. So this statement should have led us here. This statement leads us here. That's not relevant to you answering these questions. I'm saying that in a proof, that's what you do. You build one thing to another. You know, it leads to it. One thing to the next. Anyway, why are these congruent? Which one of these would work? All right angles are congruent. Now that's a fact of life, right? They're all right angles are 90 degrees, 90 degrees are equal to 90 degrees, things like that. That's all great. But we didn't know they were right angles until we said they were right angles. That's why that part's important to me, personally. All right. This is a big one that we haven't seen together in this video. Segment FI is congruent to segment FI. What the heck? Because duh, right? Segment FI congruent to segment FI. That marking, I can't go deep on this, otherwise I'm going to be here forever. FI is shared in both triangles. The drawing, the nature of the drawing allows us to conclude that both triangles that share that side must be congruent corresponding parts with each other. It allows us to say the FI in this triangle is congruent to the FI in this triangle. As far as us trying to figure out which triangles are congruent, we found two parts that are congruent in both because it's the same side, it's the same thing based on the drawing. If we separated them, they'd be different. Because they're together, we can see they are back to back the same. That's known as the reflexive property right there, the reflexive property of congruence. The reflexive property. Boom. Hey, these triangles are congruent. FGI and FHI. That's an angle side angle case. Now, HL is not an option on here. It shouldn't be an option on here. But these are right triangles. This is where HL could have existed if the hypotenuses were found to be congruent and this set of legs. It's not. This is an angle side angle with angle side angle. This is an angle side angle case. These triangles are congruent. Boom. We proved it. Proving statement's the final statement. Given statements are the beginning. So if you were to write out the letters, it would be E, F, B, D. CPCTC does exist in proofs. Normally it's the statement after this triangle congruent statement if we were proving parts congruent that we couldn't prove congruent before. All right, which two angles below are congruent because the alternate interior angle theorem? Now this is interesting. Hopefully you've seen some of these before. See these parallel lines? Imagine if they were a little bit longer. Ignore the green, look at black. See this big guy? Transversal, boom. Ignore the green, look at the black. You guys see these alternate interior angles right there? Ignore the green, look at the black. See that? See that? And try and hide that away. Hide that away. You see those? Now you see them. Those are alternate interior angles. Right? Now imagine all that was not ignore the green and look at the black. Now look at the green and the parallel lines. They're still there. They're still there. These two angles are congruent because these two lines are parallel. It's because those parallel lines that those are congruent. But let's name them. Got to use three letters. IHF and GFH. This shows up in proofs all the time. If you have a diagram with parallel lines, I guarantee you you're finding somewhere alternate interior angles, more likely, or corresponding angles, possibly likely. Sometimes alternate exterior angles will show up. I can't even really think of the drawings where that works best, but sometimes. Okay, the final skill is skill 30. This is on transformations. Now, there's a lot I could say. I want to kind of try and stick to the examples outside of what transformations look like. But when it comes to rules and things like that, maybe I'll describe within. A transformation is taking an object, let's do one more unique, is taking an object such as this and doing things with it. I can translate this object by just moving it away from where it was. I can rotate this object, right? Say that I do a 180 degree rotation like that. I could also reflect the object, say like that, right? These are different transformations that we can do. Now, when we apply a transformation, there are certain ways that we do it based on the rule, the description, whatever it is. A translation is just as simple as going a certain number of units up or down or left or right or something like that. Reflections, we actually literally, and we follow the rule to a T, we reflect across a very specific line. We don't just flip it over just like this because maybe we flipped it over this line and maybe we, whatever. There are a lot of different ways we can do reflections. Rotations, we'll always go around the origin. Not every math class, but I will. We'll always go around the origin, and because we're on graphs, we'll go 90 degrees or 180 degrees, clockwise, counterclockwise, whatever, something like that. We'll always do that. When we label those things, if we draw a graph, we use something known as prime notation. You see where it says triangle ABC here? See where it says triangle A prime, B prime, C prime? Or A apostrophe, B apostrophe, C apostrophe. Those are known as primes. It's a way of saying, here are the parts that correspond by the same letter, and we give it a different name based on how many transformations it did. A single prime would be they transformed once. There could be A double prime, B double prime, C double prime. They transformed twice. You do a translation here, then you do a reflection here, and a rotation here, and things like that. So they use this thing called prime notation. Rules can be described, and they can be shown in an algebraic format as to say what you do to all of your x and y values over the course of that time. Let's look at this first one. It's unrelated to the graph. Describe the rules shown. Make sure to indicate transformation type and specifically how each variable is affected, amount, and direction. Now, if you haven't seen these before, then I can't say too much to you on it, but this has to do with a translation. This is a translation. What you do is you take every x value, like this b. This is at -2, 4, right? -2 for x, 4 for y. What if I took -2 and added 2 to it for x? I made it the x's go 2 larger. 2 larger is 2 to the right. This +2 means take your x values and go 2 to the right. The y values, subtract 3. They become 3 smaller. Y goes down if you subtract, so 3 lower. So all the points should go 2 to the right and 3 down. That's what that rule is telling you to do for every x, y value that you have as your vertices. So our rule for this is we translate 2 units right, and that's the word translate. You can say move, you can say slide, you can say shift, but the official verbiage is translate. Translate. Okay. Sorry, I'm looking at something else here. All right. Okay, that's that one. We'll see if we run into translations again. Triangle ABC is reflected over the x-axis. Write the new coordinates of triangle A prime, B prime, C prime. Okay, so the x-axis is this guy right here. Now, like I said, they do reflect across the lines. Let's do that. It's huge. We're going to reflect across that. Basically, this is like a big mirror. Everything's looking through this mirror and onto the other side. And when you look into a mirror, you look perpendicularly into it. Down, down, down. We're going to look at these 3 points and we're going to reflect across this. And on the other side will be the mirror world, A prime, B prime, C prime, that are the same distance away from this mirror as they were before. So A is 1, 2, 3 units away from the mirror, and 1, 2, 3 units on the other side exists A prime, like that. C is 1, 2 units away, so C prime is 1, 2 units away. C prime will be closer to the mirror, like C is closer to the mirror. This is an actual reflection. The object won't really look reflected so much as just translated, because the object is like an isosceles triangle, but look at where the points go. B is 1, 2, 3, 4 units away. B prime is 1, 2, 3, 4 units away. B prime is also 2 units away from C, up from C. Now B prime is 2 down from C. And if I drew it, it would look like that. That is a reflection of this object over the x-axis. Now they asked us to write the coordinates of A prime, B prime, C prime. Well, A prime is at -5, -3. B prime is at -2, -4, and C prime is at -2, negative 2. And that would be the final answer. Now, if you notice, there was a translation rule. Sorry, there was a rule to describe this type of translation here. Is there a rule on reflecting points over the x-axis? Yeah, there is. And it looks like this. If you have some sort of x, y values for your points, what you do is you keep the x values the same, and you change the y values. You make them the opposite of what they were. You make them negative. So reflected over the x-axis takes on that rule. So check this out. See if this works. A was at negative 5, 3. B was at negative 2, 4. And C was at negative 2, 2. What happens if you keep the x's the same and change the y's so they turn the opposite of what they were? 3 turns into negative 3. 4 turns into negative 4. And 2 turns into negative 2. So I didn't even need to use this graph to actually get my answer. I could have used the rule. My students are provided these rules each time that they do these things. They have to know what to do with it, how to make it work. They have to know the order of pairs. They have to write them that way, prime notation, all that kind of stuff. You can do it. Some rules are weirder than others. And, what if you were asked to know the rule? That rule should make sense to know. Reflected over x, the x's stay the same, things like that. But some get a little weird, and I'll provide you rules the rest of the way if I have to. All right, 2 more quizzes. This is the last time we're doing skill 16 and 17 and things like that, I think. Week 18 comes after this, where it's just skills 26 to 30. So here we go. Skill 16. Last time, write the first 4 terms for this sequence. All right, 6 is the first. Times 3 is 18. Times 3 is 54. Times 3 is 162. I'm just kind of sad to see it go. I'm gonna do. Oh, good. I got another problem. Find the 10th term, the exact value in this geometric sequence. So let's go by my mantra of getting the explicit rule. 10 times 1/2, or hey, let's say 0.5. Those are going to be decimals, so let's do decimal here. The n minus 1. So a sub 10 is 10 times 0.5 to the 9th power. Yeah. 0.5 to the 9th power. Oh, that is not raised to. There we go. All right, check this out. It's going to be 0.0195325. I don't even remember that answer. I hope it's right. All right. So sad to see it go. I barely knew you. I knew you more than any of the others. All right, what is 400 increased by 125%? There's a multiple choice question. This isn't easy. You don't add 125 to it. You don't multiply by 1.25. Remember, increased by 125%. 125, not a 25% increase. 125% increase. So, as far as like an equation go, it would be 400 times 1 plus 0.125. Excuse me, 1, I said that wrong, plus 1.25. That's 400 times 2.25. That's 900. What if you, here, let's think about it this way. What if you increased 400 by 100%? Then you doubled it, right? 400 increased by 100% is 800. So why should my answer be less than 800? It shouldn't. It should be 900. That's the answer. All the other ones are bait answers. Don't fall for them. A viral video starts with 100 shares, and the number of shares increases by 50% each minute. Write an equation modeling the number of shares after t minutes. We're not even solving. So 100 shares times 50% each minute. 1 plus 0.5 is 1.5 to the t power. That's it. That A one, that's tricky. All right. Oh, we've seen this so many times. I got to stop doing this dumb equation. Hopefully they got this one at this point. All right, 6 times 1/3 to the x power. Yeah, that one really did. Ooh, this looks all fancy. This looks darker than the other ones. 6, 1/3 of 6, and stuff. Oh, we might have done this kind of problem as well. But this negative 8 times 2 to the x, I clearly ran out of problem. I ran out of thoughts to do. So let's do it again. Negative 8 times 2 to the x times 2. Oh, nope, divide by 2. Divide by 2, divide by 2, divide by 2. And here I was thinking maybe I did do all unique problems the whole time. Not even. Nuh-uh. Nunzo. All right. That was -8 times 2 to the x power. Okay. I don't even know if I did +8. See, I should have done more +8 times 2 to the x power. That would have been nice. All right. Skill 19. Solve. 5 to the 2x equals 1 over 25. Okay, check this out. We haven't seen these in a while now. 25 is 5 squared. But I'm not matching base unless that 5's in the numerator. To the second, 5... Negative exponent is what gets me there. So 5 to the 2x is actually 5... 1 over 5 squared is 5 to the -2nd power. Yeah, we haven't seen one of those in a while. Now the bases match. 2x is -2, so x is -1. Okay, 16 to the x power equals, if I add 5, I get 64. No, x doesn't equal 4. Haven't you been listening on what we do here? We got to find things that match in some sort of way. Can't raise 16 to a power to get 64 cleanly. Let's do 4 though. You can do 4 squared and 4 cubed. We probably did something like this before. 2 times x is 2x. I feel like we've done this problem, but that's okay. 2x equals 3. Now that the bases match, so x is 3 halves. I barely knew skill 19. Use picture to the right. Look, I totally forgot to take that part out. Clearly do not pay attention to anything that I write. You know what? It was never there. You can't see it. All right. Find the distance between these points. All right. From -1 to 7, that's 8. From 4 to 2, that's 2. C squared is 68. C is the square root of 68. Notice, I'll use distance formula that very first time. If you were with me at the beginning, I only used it that very first time. Pythagorean theorem is the way, man. I'm telling you, it's totally the way. All right, let's finish before the 6-hour mark, shall we? -4, -5 is the midpoint between -8, -10, and another endpoint. Find the other endpoint. This is the midpoint. -4 is the average between -8 and what number? You go from negative. We're going to do this mentally. We go from -8 to -4. Let's go this way. -8 to -4. That's 4 away. From -4, another 4 away is 0. 0. From -10, as an endpoint, we go to -5. -5 is 5 away. What's another 5 away? I guess we're going down, up. What's another 5 away? 0. It's 0, 0. You average -8 with 0, you get -4. You average -10 with 0, you get -5. Cool. All right, EG is 71. The whole thing is 71. Solve for x. 71. 8x minus 17 plus 5x minus 3 equals 71. Combine like terms. Whoops. Something happened. Add 20 and divide by 13. I think that's also, so I think that's 7. All right, H is the midpoint of segment GI. Find the length of segment GH. All right, those are congruent. Set those equal. Subtract 5x, add 10, and divide by 4. You get 3. Okay, let's find the length of GH. We got to do 5 times 3 plus 2, which is 17. Okay. 17 and 7. Let's move forward. Treat both problems independently, given the diagram. Find the measure of angle PCD. If measure angle BCP is 38, and the measure angle BCD, the whole thing is 88. Hey, this isn't even algebra. All right, well, it's going to be 88 minus 38. That's 50 degrees. Sounds fantastic. Guys, it's almost 2 in the morning. All right, ray CP, independent. Ray CP bisects angle BCD in the figure. Oh, my neck. Or my back. My shoulder blade. if measure of angle PCD is 44 degrees, this one has algebra, and BCD is 4x plus 12, let's solve for x. Remember, one's 44, the other's 44. It's a bisector. Boom, boom. So 2 of those is 88. 2 of those are 88. 2 of those becomes 88. Subtract 1276. Divide by 4. 19. Yeah, sure. Why not? All right. Given these points, are the lines parallel, perpendicular, or neither? All right, we haven't seen one of these in a while. Not in this format. Slope of line AB, y2 minus y1 over x2 minus x1. 6 minus 8 is negative 2. 2 minus negative 1 is positive plus 3. There's 3. Slope of line CD is y2 minus y1 over x2 minus x1. That's 6 over 4, which reduces to 3 halves. So you got to be careful, because you see 6 over 4, you're like, nah, these are in neither case. Nothing happens. But this is negative 2/3. This is positive 3 halves. Those are opposite reciprocals. These are perpendicular. And you know how else I know they're perpendicular? Because I'm asking for parallel right here. No, that's not always the case, but parallel. So find write an equation parallel to this one that passes through negative 4, negative 5. So, and we've had a lot of these ones now. So 2x plus b. Let's plug in negative 5 for y and negative 4 for x. And we'll get 3 if I add 8 to both sides. So that's y equals 2x plus 3. Ooh, plus 4 and plus 3. They were close to each other. Still parallel. All right, name 2 pairs of linear pairs. You cannot use the same angle twice. All right, well, I'm just going to name all the different angle pairs, linear angle pairs. 1 and 2, 2 and 4, 4 and 3, 3 and 1, 5 and 6, 6 and 8, 8 and 7, 7 and 5. Those are different 8 you could choose among. Just make sure you don't duplicate a single angle pair twice. If measure, lines M and N are parallel, by the way. If measure of angle 7 is 36 degrees, what is measure of angle 2? Alternate exterior angles, 36 degrees, of course. All right, measure of angle 1 is 11x minus 7. Measure of angle 8, also alternate exterior angles, also congruent, is 7x plus 9. Solve for x. All right, set them equal to each other. Just the different pair, and obviously a different setup. Subtract and add and divide by 4. You get 4. All right, measure of angle 2 is 10x, and measure of angle 3 is 15x minus 30. Vertical angles, also congruent. Find measure of angle 2, nothing supplementary. Set everything equal and solve. This was your chance. Subtract 10x, add 30, divide by 5, you get x equals 6. Now find measure of angle 2. Measure of angle 2 is 10 times 6, which is 60 degrees. Okay, scale 26. What is the sum of the measures of the interior angles in a triangle? Period. 180 degrees. That's something you just got to know. Sometimes people even say it, not say it wrong, but say it in the wrong way. Mr. Robinson, a triangle's 180? If by a triangle's 180 you mean the interior angle sum of a triangle is 180 degrees, then yes. Some people add sides, make it 180. Some people think the area is 180. Just weird things. Like, Mr. Robinson, a triangle is 180? Like, what does that mean? Measures the interior angle sums. Find the value of x in the diagram to the right. Don't forget the right angle. Yeah, you see these symbols. I know you know what a right angle is. People just forget in the calculation. You want to write 90 here because you're going to forget writing it. I say that as I might forget writing it. Solve for x. So x minus 15 plus x minus 10 plus 3x plus 5 plus 90 equals, oh, what does this equal? It's a quadrilateral, right? 360 degrees. Do you remember that one? If not, you do d equals 180 times n minus 2. X plus x is 2x. Plus 3x is 5x. Negative 15 minus 10 is negative 25. Plus 5 is negative 20. Plus 90 is 70. 58? Yeah. Okay. Are the triangles congruent? If so, state the congruence theorem. Yeah. I mean, there are no letters. We're not doing that triangle this, congruent triangle that, but yes. How come? That's an angle. Sorry, I'm using my fingers as if you can actually see my finger pointing the screen. Angle, angle, side, angle, angle, side. I need two different, like, styli. Is that the styluses? Styluses. Angle, angle, side. All right, so this one would pop up, right? So same situation. The triangles are congruent. Now we got to solve for x, not z. Okay, so in this case, once again, 1, 2, 3, 1, 2, 3. Corresponding parts of congruent triangles are congruent. CPCTC. H is the second letter in this. It corresponds with n over here. N is 115 degrees. 6x minus 29 will be equal to the 115 degrees. Add 29 divided by 6. 6x is 144 divided by 6. X equals, I think that's 24. Let's pretend like it is, and that's x. All right, skill 28. If two triangles are congruent, then all the triangles' corresponding parts are congruent. Very true. That's the CPCTC mantra. Write the conclusion. I'm just going to circle it. All the triangles' corresponding parts are congruent. Triangles, like both of them. Write the inverse of the statement. That's negating these things. So if not, if two triangles are not, I gotta shout, congruent, then not all of the triangles, whoops, corresponding parts are congruent. It doesn't mean that nothing can be congruent, right? You can get, I mean, triangles can, you can have twins and then, someone has a bigger ear or whatever. Just, the idea is that not everything's going to be congruent. You can have certain parts. You can't have an angle-side-angle congruency case or whatever, because then it's true. All right, complete the statements in the two-column proof on the back of the answer sheet. So let's go over here. Right here. We got to complete the statements this time. All right, given segment JM is congruent to segment LN. JM and LN are congruent. And that's a given, right? So we get to write that as one of the things. Segment JM congruent to segment LN. What's the other given? JMN, angle JMN, boom, is congruent to angle LNN, LNM, boom. Angle JMN is congruent to angle LNM. Now those were the two given, so it's easy to fill out based on that thing. The reflexive properties got to be shown. It's the shared sides. That must be this guy right here. Segment congruent to itself. Segment MN congruent to segment NM. Now you might say, why did you reverse the letters? Oh, I didn't have to. It's the way that these parts correspond. You can even see it right here. See the MN and the NM? 2, 3, 2, 3. It's the way they correspond. This figure's more of a rotation of one than the other, so I tend to try and do things in corresponding parts that way. And by the way, now I write the triangle congruent statement, the proving statement. Triangle JMN is congruent to triangle LNM by side angle side, and it very much is side angle side. Sometimes what I use with quizzes and tests is, maybe this was an easy question, maybe not, I'm not sure, but hopefully they didn't just write these things as in like, okay, these are the givens, write them down, this is a proving statement, boom, and that's good to know. But hopefully they also look at this thing and say, why is this side angle side? Did I write this thing up? Does it make sense that this is a side angle side case? Can you learn as you're being tested? And the answer is absolutely yes. Remember, this statement, this is a true statement. If you try, this is CPCTC. That's what the mantra is. And we just used, wait, did we? I just mentioned it with the MN and NM part and things like that. Sort of. But yeah, that's the thing. All right, which two angles below are congruent if segment IE bisects angle KIT? So KIT is right here, and it's bisected by IE. Those two are congruent. Right? I don't know anything about those yet. Maybe not, I have no idea. But this bisected that angle. We've done angle bisectors like 20 times. So we have to know it's this one. But let's name them. Angle KIE. I has to be the middle letter. I don't know how much I got to talk about naming conventions here. It's got to be the middle letter to represent the vertex. And TIE. Now, is it the same thing to say angle EIK and EIT? Yeah. Yeah, it is. I just named it that way. All right, skill 30, back to transformations. What's new? Okay, write the new coordinates of -5, 7. After reflecting over the line y equals 6, you may use the below graph axes to assist you, or you may use the appropriate rule. It's got a little stretched here, I just noticed. Prime notation is not required. Yeah, this is a single point, -5, 7. So here's the point, -5, 7. Here's the line y equals 6. It's actually a horizontal line. The line y equals 6 is a horizontal line. How do I reflect across that? Well, the same way we just did last time. 1 away, 1 away. Boom, it's right there. That is the reflected point. So the answer, where is that? -5, 5. That's the answer. Now, I said you may use the graph to assist you. Maybe you draw the line wrong. Maybe you don't know. Maybe you thought it's a vertical line. Maybe whatever. There's a rule associated with reflecting across this kind of line as well. It's not the x-axis. It's not the y-axis. It's not an easy one. Reflecting across the line y equals d. Let me try that again. Reflect across y equals d looks like this. You go from some xy to the same x. You can even tell it's the same x here. But now 2d minus y. Now this is weird. It's a little weird. What you got to do is determine what is that d that we're referring to. D is 6. D is 6. So our official rule for this problem, we go from xy to x comma 2 times 6 minus y. 12 minus y. So we're going to use that rule. Now our xy is -5, 7. So we're going to go from -5, 7 to x is -5 and then comma 12 minus 7. You know what 12 minus 7 is? It's 5. So -5, 5 is the thing. Now prime notation isn't required because I didn't give you a letter to begin with, like a, and call it a prime. But that's the answer, -5, 5. Okay. Next one, select the transformation shown from triangle ABC to triangle A prime, B prime, C prime. So here's ABC, boom. Here's A prime, B prime, C prime. Now, man, I can't spend a long time talking about this one, unfortunately. I'm sorry, guys. But let me draw this again. I won't be able to do the rotation you want me to. If I had 20 minutes to talk about this thing, I could say a lot of things about it. I don't have the time for myself. I just don't. Okay, this is a rotation. Check this out. When I rotate it like that, it goes there. Now this rotation aspect of where it went isn't perfect. This drawing doesn't look like it's to scale, but this clearly was meant to be a rotation of this object. Oh, I'm sorry. I'm blocking this entire thing. That is so my bad. Let's do that one more time. Okay, I took this and I rotated this piece right here like that, and it didn't line up perfectly, but it's, the idea is in place. This was designed to be a rotation. Now, which way did I rotate? If you think like a clock, this is clockwise. This is counterclockwise. So this thing rotated, this object rotated 90 degrees. You can tell it's 90. See, just like, check out this grid box. Rotated 90 degrees clockwise like that. Boom. And that's the answers. Rotate 90 degrees clockwise about the origin. Now, if you were doing this on a piece of paper, you could rotate your paper 90 degrees clockwise and see where the thing ends up. There are drawings that we have to make by doing rotations. I have videos on rotations. You can find things on geometric transformations and the rules if you want to find those. Let me talk about the rule. Yeah, that's fine. Let me talk about the rule for rotation 90 degrees clockwise about the origin. You go from xy to, let's see, we'll go to y negative x. That sounds weird. What this means is your y value becomes your x coordinate. This isn't how far you go up or down. So take a point like A, which existed at 2, 3. If I go from, you can't see that. If I go from A's 2, 3, and I use that rule, then A prime will be at, I'm going to take the y value that was 3 and make it the x value, and take the x value that was 2 and make it the y value and change its sign to -2. Is that where it went? Is it at 3, -2? Yeah, that's where it is. That is the rotate 90 degrees clockwise rule. That's just what it is. I'm just telling you it. So you can use that rule to apply that and make sure that it measures up. You can try it with B and C. It'll work. There's that. There are these other ones, though. Rotate 180 degrees, which it's not. Y equals X and Y equals -X. We're going to see one of these later, but Y equals X is a diagonal line like that, and Y equals -X is like that. And the reason I put those up there is because reflections across those, you can even look at this and almost see it almost look symmetrical. It's not. Those can be confused for rotations. Quite often, they actually can. So just get ready. Those might show up. Okay, one more quiz. Now, this is just skills 26 to 30. 26 to 30, and these come in the form like the midterm. They kind of look like this because this is all they were forced to do. Let's see if we can get this done in 11 minutes here. Get past before 6 hours, or make it fancy and get to 6 hours. Find the interior angle sum of a 36-sided polygon. That's where n is 36. 180 times n minus 2. 36 minus 2. You know I'm whipping out the calculator. So 180 times, it's 34. 6120 degrees is the sum. I'm not drawing a 36-sided polygon, but we're doing that. All right, solve for x in the figure below. This is a lot like the previous one with the right angles, but it's a different kind of shape. It's got 1, 2, 3, 4, 5, 6 sides. Honestly, I think it's easier to count angles. 1, 2, 3, 4, 5, 6 angles. These are 90 degrees. The interior angle sum of a hexagon, 180 times 6 minus 2, is 720. So these will add to 720. Let's start with x. X plus 130 plus 90 plus 140 plus 150 plus 90 equals 720. Trying to beat the clock. X plus, oh boy, 220, 360, 510, 600. So x is 120. I don't need to put degrees. It has the degrees. It's solving for a variable, not finding the measure of, and that is good. All right, select which two theorems could conclude, I guess. Triangle AOB is congruent to triangle COD. So this is overly marked. Like, this is marked more than it generally should be. You don't need this much information. It's like, and I have the knife, and I have the weapon, and I have the blood, and confession. They're like, okay, that's enough. He's guilty. Here are valid ones. These are invalid. So automatically, these guys are stricken from the record. Angle, side, angle, not okay. Are these the correct ones? Not all of them. We don't have two sets of congruent angles. I see a set of congruent angles here and here. Angle, side, angle, and angle, side are not even possible in this case because we don't have two sets. Does side, angle, side work? Yes. Side, angle, side with side, angle, side. Does side, side work? Yes. Side, side with side, side. So it's these two. Side, angle, side, like that. Number 2, we've seen this diagram before, but now we got to solve for y. I give a good hint to find the measure of angle S first. Now remember, this is a 1, 2, 3, 1, 2, 3 case. In the sense that angle P and C are the same, angle H and N are the same. So if N is 115, so is H. I'm just going to put a 115 here. Remember, I'm not solving for X. I'm solving for Y. I don't know angle S, but I can find it because these add to 180. Now, this does kind of trickle in from skill 26. I acknowledge that. So 36 plus 115 plus the measure of angle S equals 180 degrees. 36 plus 115 is 151. So measure of angle S is 29 degrees. Okay, that's not the solution, but S corresponds with F, and F contains Y. So Y is 3Y minus 1. 3Y minus 1 is 29. You add 1 to both sides, and then you divide by 3. Y is 10. So that same diagram existed for the last 3 things. I'm done with that diagram as far as I'm concerned. Although this was our last quiz. All right. Skill match. Given the following sequence, MATH, math, what is the 400th term? MATH, MATH. Every 4, I'm ending on H, right? Multiples of 4. 400 is a multiple of 4. 400 divided by 4 is 100 with a remainder of 0. That's ending on H. M would be a remainder of 1, A is remainder of 2, T is remainder of 3, H is remainder of 0. This is H. The 400th term is H. 400 first would be M, 402 would be A, 403 would be T, etc. Mark T for true and F for false for each statement. Provide a unique counterexample for each false statement. Okay, so for this one, I wish I did a little bit more. I'm just going to go ahead and do this straight up right now. Boom. I want to say if it's raining, then the ground is wet is true. Falling under the pretense that you're not under an overhang, you're not indoors. We're talking about raining on that ground. It's making it wet. It's not evaporating and things like that. So I wanted to do that for my students. Some said false for those reasons. They said, oh, I have an umbrella. It's doing, whatever. So, okay, if they gave their unique reason, I'll take it. But let's say this was the case. No counterexamples provided for a truth statement. What are you going to counter if it's always true? So anyway, let's say that was the case. If the conditional statement's the case, this is converse, inverse, contrapositive. I don't know if you know that, but if we look at it, that's what happens. Contrapositive, if not Q, then not P, will always be true if the conditional is true. They have a logic equivalence. So this would be true with no counterexample. Let's read it. If the ground is not wet, then it is not raining. It's not wet. How could it be raining? Right? So true. In the scenario we're talking about. All right. If the ground is wet, then it is raining. Oh, that's not necessarily true. It can be wet and not raining. I mean, we can talk about a lot. We can flood. There's an example. If it's not raining, then the ground is not wet. Can you come up with a scenario when it's actually not raining, but the ground is wet? Right? That's what we're talking about. So, yeah. Now, I don't know. I want to come up with a unique example. I want to say we have to make a unique counterexample. So we have to say something else. Sprinklers. Car wash, right? There are other cases when I can have that. Anyway, that's what we're doing in that case. Okay, hopefully skill 28 is making sense. Not really as mathy, but kind of. All right, given, see the diagram. That means the diagram's going to show you what the givens are. We got to be able to label these. Prove that angle C is congruent to angle F. Oh, don't prove triangles are congruent. Interesting. That doesn't mean you don't use congruent triangles to get there. All right. If you look at the diagram, I kick us off with segment AB congruent segment DE. It's marked. What I'm telling you to do is look at the diagram to make the given statements. That is given. If you see that the diagram gives it to you, then we say it's a given. What else do we see that they tell us is given? Angle A congruent to angle D, that's a given. And segment AC congruent to segment DF. Okay, those are the givens. You can even see the reasons. Whoops. Segment DF. All right, triangle BAC is congruent to triangle what? Triangle BAC, boom, boom, boom. You can see it's triangle EDF. Triangle EDF. This is a side angle side case. Very clearly, side angle side side. Because the triangles are congruent, any other parts that correspond are congruent. C is congruent to F. Does C correspond with F? Yes. They are the third letter in these statements. We wrote the correspondence correctly. The triangles are congruent, therefore C is congruent to F. Heck yeah, they're congruent. You know why? Because corresponding parts of congruent triangles are congruent. That's why we use CPCTC. I'm not going to spend long explaining it. I'm within 3 minutes of hour 6. Which statement directly led to statement 5? How do we know this is true? Well, remember, we created these out of thin air based off givens, and these led to statement 4. That one, whoops, that one, and that one led to statement 4. You know what led to statement 5? Statement 4. It's because of statement 4, congruent triangles, that we could find out those corresponding parts were congruent. And that's the end of skill 29. Last set, skill 30. Given the following image, which of the following is a rotation? Well, it's going to be this one here. As you can see, this kind of foot swings up and over, like, and it becomes that. This is just a translation, B. Translation just moves one to the left. And C is a reflection. You might not be able to tell what kind of reflection it is, and it's not very obvious, but it reflected across this line like that, and we got this image right there. If you can kind of tilt your head that right way, you're going to see that C is actually a reflection. and that leads us to last question number 2, which I'm not going to end at 6. I'm not going to try and end before 6 hours. I want to talk about this one. Reflects triangle UVW across the line y equals x to draw triangle U prime, V prime, W prime. Now this y equals x is one of them lines that looks like that. This is a diagonal line. Y equals x, in y equals mx plus b form, it's y equals 1x plus 0. It's got a slope of 1 and a y-intercept of 0, and this is what we're reflecting across. We got to go perpendicularly across it the same way you would anything else. One corner away is v prime. 2 corners away is u prime. And 1, 2, 3, 4, 1, 2, 3, 4 is w prime. So it looks like this. Now, to the wrong person, to certain people, this can look like a rotation. The same exact way that this C kind of looks like a rotation. It kind of does. I mean, in its own way, it's not oriented the same way. It doesn't look like a reflection, but it is reflected, right? It is reflected, and so is this one. If you kind of see where W went, it does flip over actually that way. It's not rotated up. A rotation of this would have actually looked like that. Sorry, this from this, right? This one would have rotated and kicked up right there. This was a reflection of sorts. Now, another way we could have done this is with its rule. What is its rule to reflect across y equals x? You go from xy to yx. Check this out. V was at 0, negative 2. You know where V prime is at? Negative 2, 0. Let's take a look. Negative 2, 0. Yep. U was at negative 0, negative 4. U prime, swap them. Negative 4, 0. Negative 4, 0. And W was at 3, negative 5. W prime should then be at negative 5, 3. Does that work? Negative 5, 3. You betcha. That is a reflection across y equals x. Okay, guys. I've reached the 6-hour mark. 6 hours and 1 minute. 6 hours and 1 minute. Next slide. Blank. Guys, that ought to do it for this one. 2:14 in the morning. This is Mr. Robinson. Thank you so much for watching. I'm probably going to enjoy my summer off not recording. Well, actually, I might be recording a lot of videos in the summer, but I'll see when I end up uploading them and stuff. I will see you whenever I'm good and ready to record another video again. Take care. I so hope this was helpful for you. The longest video on record on my channel. I'm sure I'll break it and be longer at some day. I can't talk anymore. I'm going to rest. All right. Take care.